Welcome to the first course in the Game Design and Development Specialization, Intro to Game Development. I'm Brian Wynn, Associate Professor in the Department of Media and Information at Michigan State University. I, along with my colleague Casey O'Donnell, will be teaching this specialization, and I'll be leading this first course. In this video, I'll give you an introduction to this first course, as well as give a brief overview of the specialization. But first, let's talk a little bit about the difference between game playing and game development. I get a lot of students that love playing games, and they naturally think, why don't I develop them? Of course, playing games is important in terms of understanding what makes a good game and what makes a bad game. But really, these are two different things. I view this as very comparable to people that enjoy watching films versus people that actually make films. There's a lot of work that goes in behind the camera in pre-production and post-production, long hours to actually produce the content that we enjoy as we eat popcorn. The same holds true for game development. Just because you enjoy playing games does not necessarily mean you're going to enjoy making them. But for many, they actually enjoy it more. Personally, I like making games more than I like playing them. To me, watching my vision become reality is a truly gratifying experience. The icing on the cake is witnessing other people play my creation and enjoy it. But after exploring game development, some do decide that, hey, I just like playing games. I view that as part of the learning experience and part of the reason that some of you are exploring this course, to see if you will enjoy making games like I do. Of course, there are many aspects of game development. There are design roles, engineering roles, art roles, quality assurance, production, and audio. In this specialization, we're going to cover a little of all of these. We're going to focus a little more on design, engineering, and production, but we really will touch upon all the roles that make up game development. As a trend over the last 20 years, the game industry has been expanding. Recent Newzoo statistics show that the global game industry is a $91 billion industry in 2015, reflecting the expanding markets and game platforms, including tablets, handhelds, and phones. There's also year-over-year growth across the world, with huge growth in Latin America and Asia. So this is not just something that we see in North America. So there are growing opportunities in the game industry, but it is still a competitive marketplace. I view it as somewhat parallel to Hollywood and film production once again. There are a lot of people that have dreams of getting in, but it does take skills, it takes experience, it takes motivation, and of course it takes personal connections to find the job that you really want. Overall, it needs commitment. Fortunately, game development concepts apply beyond just games. So when we talk about the game industry, we often refer to it as interactive entertainment. But of course, there's a burgeoning industry that some people refer to as serious games or meaningful play. This is using games for purposes beyond just entertainment, for education, training, persuasion, healthcare-related issues, avergaming, and that sort of thing. Of course, game development concepts apply to these games just as well as they apply to games for entertainment. But really, there's a much larger industry that people sometimes refer to as digital media, interactive media, or new media. This is everything from web development to mobile applications to traditional software development. And it turns out that the same skill set that you use when you are making games really applies to this much larger industry. So the things that you will learn while making games, you can apply to many different jobs. So when we break down the industry, one way to think about it is as the things we just talked about: interactive entertainment, serious games, and digital media. You can also view it as platforms, such as game console systems, the handheld game systems, the personal computer, the web, and mobile gaming. And of course, there is still the traditional arcade cabinets and emerging platforms, such as virtual reality systems like the Oculus Rift. We can also view it as distribution channels, such as retail, digital distribution, and indirect channels. And of course, the game makers, such as the game publishers, like Electronic Arts, Activision, and so forth, the game development studios, individual consultants that maybe work for those studios or work for the publishers, and of course, hobbyists. So you may find yourself with some combination of interests across this table. So I think we all have different motivators of why we're taking this course. We have people that definitely want a career in game development. We have people that are curious about game development and want to learn more. We have people that think making games will just be good fun and want to pursue it as a hobby. We have people already in the game industry that want to further enhance their skills and or change roles within the industry. And we also have people that are in tangential industries that view learning about making games as advantageous for their non-game related jobs. With that said, we've structured this course and the specialization to service all of these needs. We definitely are focused on those targeting careers in the game industry. So in terms of the teaching method that we're going to apply in this course, we're mixing theory and practice, or you might view this as lecture and lab. So every week we'll have a combination of videos and readings where we'll build the foundations of theory that you can apply toward making games, but we really spend a lot of time on the practice of making games. Most weeks there'll be a sizable projects where you'll get your hands dirty. You will learn the tools and you'll actually build things. In particular, we'll be making 3 projects in this course. In week 2, we'll be introduced to building game projects in Unity 3D by creating a solar system simulation. This will cover the basics such as creating game objects, understanding 3D space, including vectors and transformations, attaching behaviors, creating and modifying materials, the basics of lighting our 3D environments, how to add audio to our games, how to work with cameras in Unity, and how to test and build our games. In week 3, we'll make our first game, Roller Madness. This project will cover the asset pipeline, best practices in regards to project organization, the use of physics in our games, receiving player input, creating user interfaces, and creating visual effects such as the use of trail renderers, particle effects, and animation. And we'll build several game systems such as player control, pickups, enemies, and scoring. And in week 4, we'll dive into C# programming to create Box Shooter, a first-person game. This project will cover core concepts in writing custom C# scripts to create unique games within the Unity engine. So what's required? I like the phrase game development is hard fun. There's a lot of work when it comes to making games, but hopefully that work is very rewarding. So let's talk a little bit about the sequencing of the specialization. As I said, the first course focuses on an introduction to the technical element of game development, or actually building games. We'll use the very popular Unity 3D game engine as our primary tool to do this. The second course builds on the foundation of development and adds in game design, from concept generation to documentation to early prototyping. The third course adds intermediate and advanced game development techniques in Unity 3D and discusses how to finish a game and distribute it to end users. With an understanding of game design and development gained in the first 3 courses, the fourth course applies this knowledge in the wild of the game industry and game markets, from how to run a game production team, to getting a job, to forming a game development company. The specialization ends with a capstone project, where you'll design and develop a game of your own design and develop a strategy to bring it to market. So what's next? In this first lesson, you'll get to meet the instructors of the specialization, get to know your fellow students, and learn about some of the resources that you can draw on as you take this course. So let's begin the journey into game design and development. In this video, I'll share a bit about myself and my background. My name is Brian Wynn, and I'm an associate professor in the Department of Media and Information and the director of the Games for Entertainment and Learning Lab at Michigan State University. I was born in 1971, 1 year before Pong was released to the arcade. At the early age of 7, I can remember going to the pizza parlor with my family and seeing Space Invaders for the first time. I was hooked. I would beg my dad for quarters to play. This continued over the next few years as a flurry of arcade games came on the scenes, from Asteroids to Pac-Man to Donkey Kong. These early games really helped shape my view of game design. When I was 9 years old, my family got an Atari 2600 game console. This was the first time I could play digital games at home. Of course, the games were not as good as the arcade equivalents, but rather than beg for quarters after every time I lost a game, I could play the game for hours on end and really start to think about what makes a good game a good game. 2 years later, we got an Apple II computer. Rather than buying games for the computer, my dad decided to get me a book, something like How to Program Games in BASIC. I began to learn to program. I first copied code directly from the book into the computer just to see if I can get it to work. Then I began to modify the code and change it to expand the games. Eventually, I was able to write entirely new games of my own design. Of course, they were very primitive by today's standards, but it really launched my love into creating interactive experiences and games. Ultimately, this led me to pursue computer science as an undergrad student at the University of Minnesota Duluth. This is where I really learned to program properly. During the summer of my junior year, I interned at IBM. While I cherished my time there and learned a lot, ultimately I decided I didn't want to work on traditional software projects. I really wanted to work on games. This led me to pursue graduate school. I ended up going to Michigan State University for graduate school with a focus on computer science, artificial intelligence, and human-computer interaction. While this was the best decision I ever made, unfortunately at this time, there really were no courses in game design and development. After all, this was the early 1990s, and the universities hadn't really caught up yet. The closest thing I could find was a course called Hypermedia Design. In this course, we used a multimedia authoring tool called Director to craft interactive experiences. For the final project, we were tasked to create an interactive autobiography, sort of an early version of a homepage or a LinkedIn profile. Rather than creating a straightforward menu with information, I decided to create a game. I called it The Case of the Salami Slicer, where you learned a little bit about me through role-playing as an investigative news reporter trying to break the next big story. This course really solidified my desire to create games and interactive experiences. After graduation, I worked 10 years building interactive media projects for the Communication Technology Lab at Michigan State University. We developed dozens of educational CD-ROMs and websites, many of which included games or game-like elements. In 2005, I helped establish the Games for Entertainment and Learning Lab at Michigan State University. The mission of the GEL Lab is to design innovative prototypes, techniques, and complete games for entertainment and learning, and to advance the state-of-the-art knowledge about games. I'm currently the director of the lab. Across the last 10 years at the lab, I have programmed, designed, and/or produced over 20 game titles. You can learn a lot more about the GEL Lab at gel.msu.edu. My early experiences developing interactive media led me into teaching. In the fall of 2000, I taught the first ever game design and development course at Michigan State University. This course was soon made into a regular course. The one course quickly grew into 2 courses in game design and development. And then in the summer of 2005, the Department of Media Information decided to go all in on games. We formulated a unique interdisciplinary program in game design and development. The program has grown to be one of the top-rated programs in North America. In fact, the Coursera specialization is heavily inspired by the on-campus program. My primary goal as a teacher is to motivate my students and to create a structured learning environment that actively engages them in the subject matter. In that sense, I'm more of a guide, coach, and mentor than the proverbial sage on the stage. You know, making games is hard. Making good games is even harder. In order for my students to succeed, they need to build their technical and creative skills. To do this, I try to create authentic, real-world problems for them to work on. This means that my students need to create games. And they end up creating a lot of games as they move across my courses. I really stress iterative development. That is, design, prototyping, playtesting, and refining. The more time you can go through this iterative loop, the more you'll learn and the better your games will be. Of course, making games is not typically a one-person affair. Modern game development requires teams of individuals with complementary skills working together in harmony. For this reason, I also really stress soft skills in my courses, such as communication, collaboration, negotiation, ideation, time management, and leadership. For many of my students, creating games is a labor of love. My goal is to harness this passion, polish it, refine it, and nurture it, and push my students not only to advance themselves, but also advance the art and science of making games. So what's next? Now that you know a little bit about me, let's get to know your fellow students in the next activity. In this video, you'll answer a few questions and then compare your answers to those of your fellow Coursera learners. This will give you an idea about the others taking this course. Let's begin. Now that you know a little bit about your fellow learners, in the next short video, you'll be introduced to Michigan State University and its mission. In this video, I'm going to discuss a conceptual overview of game development. This overview will give you a better understanding of how games are made. To do this, I'm going to use a construction analogy. That is, I'm going to relate building games to constructing a home. The first thing that you need to think about when you're building a home is who are you building it for? You'll build it very differently for a group of college students than, say, a small family with a second child on the way. The same concept applies to games. You need to know who you're making the game for. That is, who is your target audience? Beyond traditional demographics like age, gender, and culture, with games, one of the most significant differences between players is their play style. Are they core gamers or casual gamers? Core gamers play for the exhilaration of beating the game. They'll tolerate frustration to get to the next level of the game, while casual players typically play for the sheer enjoyment of playing. If the game becomes frustrating, they'll stop playing and put it down, or find another game. When building a house, the location is very important. What neighborhoods are hot, which have comparable properties, which have additional location features like they're in town, or they have a big backyard, or maybe they have a nice view. As they say in real estate, the three most important things is location, location, location. Our neighborhoods in game development are the game platforms. The traditional personal computer markets, Windows and Mac, the home console systems, Wii, Xbox, PlayStation. Of course, there's other consoles available. The various mobile platforms, of course, iOS and Android are the most popular today. And of course, you could view the web as a game platform as well. Each platform reaches a different audience and has certain advantages and disadvantages, which of course we'll discuss throughout the specialization. In terms of construction materials, homes are made up of brick, concrete, steel, and wood. It's very important for the builder to understand the physical and aesthetic properties of these materials. Games ultimately are made up of digital code, ones and zeros, that control literally millions of switches within the computing device. In the early days of game development, we sometimes worked at this very low level to get the most out of the primitive hardware. But today, we usually don't work with computers at this level. So let's talk about the construction materials of games, or game technology. Just like in construction, game technology is built from the ground up. We start with the earth. The earth in game technology is our hardware. It's the devices that we're building the game upon. Moving up, we've got the foundation. The foundation needs to be solid in construction. It can't be on a marshland, so sometimes we bring in extra fill dirt and that sort of thing to create a solid foundation. With game technology, our foundation is our operating system. The operating system is the interface between our game and the hardware. In construction, the next level is framing. So on top of the foundation, we frame up the home. Roughly we can construct the analogy that our frame in game technology is the middleware or the game engine. These are the common components that most games will use, like graphics rendering, physics, networking, input, and so on. We'll talk a little bit more about game engines as we move forward. So in construction, once we have the frame up, we move on to the finishing work. We put up the walls, we put in the floor, and ultimately we put in the carpet, paint it, and so forth. So with games, this is all of our game-specific code, the code that maps the rules of the game and have them play out in the computer. It also includes the graphics of the game, the sounds of the game, and so forth. However, when we think from a more game design perspective, we often conceptualize the game from the top down. So we start with the graphics, the sound, and the game-specific code. That is, we think about the target audience and what things will be attracted to them, and what mechanics will they enjoy playing. That ultimately leads to the design of the game, which of course can map to the game engine that we're using. Certain engines work better for certain types of games, for example. And then all of this will really help flesh out the technical details of the game. So we might pick the operating system and the hardware or the game platform based on the design of the game and the target audience. So games, like houses, usually employ many different roles or jobs to get them built. I created this table to kind of roughly make the analogy between the two. So in construction, we have the architect, which of course designs the home. These would be our game designers. We have the managers or the supervisors that run the team. These would be our game producers. We have all the tradespeople, the masons, the carpenters, the electricians, the plumbers, the people that actually build the home. These, of course, would be our game designers and our programmers. And then we have the interior designers, the painters, the landscapers, the people that make the house look great. These are our artists, our musicians, our sound designers, and so on. So the makeup of the team will vary largely based on the size of the project and the size of the game development team, just like in construction. I mean, if we're building a small house, we might have a small team. If we're building a large apartment complex, we're going to have a very large team to pull that off. So when we look at a small size project today, let's say a team of 1 to 5 people, the typical roles that are used in game development is that of the game designer, the programmer, and the artist. Of course, the designer conceptualizes, designs the rules of the game, communicates those rules to the rest of the team. The programmer is the one who implements those game mechanics and code. And of course, the artist is the one that creates the visuals and maybe the audio portions of the game. With this small team size, you may have one person that assumes multiple of these roles. And of course, because it's so small, you have less need for management, and people may ultimately wear multiple hats on this small project. Moving up to a medium team size project, you start to add additional people to manage the team. So this is where the producers come in. They're managing the schedules, they're managing the budget, helping with communication channels, and various other odd jobs that come along in larger scale game development. Moving up to a large team size, 25 or more, if you look at modern AAA game development, often team sizes can range from 25 to hundreds of people working on a game title across multiple years. So we need even more people to manage the team, more levels within that producer category. We also start to get more specialized or in-between roles that bridge the disciplines. So, for example, level designers maybe bridge between design and art. Technical artists that bridge between art and programming. And scripters, people that know a lot about design but can also do some code to make the levels, make the missions that would be in this larger scale game. And then let's talk a little bit about the cost of production. So just like the example I made before, building a small house or maybe a shack would be very inexpensive to make versus making a huge apartment complex would be very, very expensive. The same holds true for games. Commercial game titles are expensive often to make. This just shows maybe an average range of based on different game platforms. So, a web or mobile game typically is a little bit less expensive because maybe there's a less of an expectation or it's a smaller scale game title. Desktop or personal computing games may be a little bit more expensive. And then up to AAA game development, most AAA titles today are very much like Hollywood blockbuster movies, ranging into the tens to hundreds of millions of dollars to build. So what's next? Now that we have a conceptual understanding of game development, we're ready to dive into some of the more technical details of game development, starting with an introduction to the Unity 3D game engine in the next video. In this lecture, I'm going to give a quick introduction to the Unity 3D game engine, which is the primary game engine we'll be using throughout this course. But first, let's talk about what features all games need from a software functionality perspective. All games need the ability to load and display visual assets, load and playback sound effects, receive player input, maybe it's keyboard and mouse, maybe it's a controller, maybe it's a camera and a microphone. All games need some sort of game logic, which is essentially the mechanics or the rules of the game translated into code. And of course, all games need unique game assets. These are the visuals and sounds and so forth that make the game look and sound unique. So how do we build this? One technique, of course, is to build everything from scratch. That starts with building all the core game functionality, all those core software systems. So for example, if we want to display a JPEG image, we would have to write code to load the image, decompress it, and render it to the screen. We'd have to do the same thing for audio, player input, and all those things we just talked about. Once we get all that done, then we could actually focus on the game-specific features, the game logic, the game assets that make our game unique. Building everything from scratch certainly used to be the norm in the game industry. Today it is still done, but is no longer the norm. The second option, which has become the norm, is to use a game engine. Let's talk a bit about what a game engine is. So game engines really provide that core game functionality that we talked about. So the graphics rendering, the support of different graphics file formats, the playback of audio, reading player input, all those types of things that you use in most games would typically be built into the game engine. And then when you're creating your game, you build on top of the game engine. This is very similar to the concept of an automobile, where an auto manufacturer creates an engine and then builds multiple different types of cars on top of that engine. So what the game engine allows us to do is to focus on the unique elements of our game without having to worry about this core game functionality that really transcends many, many games. So looking back at the game technology stack that we looked at earlier, the game engine really sits between the game platform, that is the hardware and the operating system, and our game-specific code. So the game engine is your game's interface to the operating system and to the hardware. And in fact, often a game engine is designed so that your game-specific content can move easily from one game platform to another. So the engine will do the translation moving from, let's say, Windows to Mac, to iOS, to Xbox, and so on. So one other thing that typically comes with a game engine is a game editor. These are tools that make assembling the game more intuitive and more visual, so we don't have to do everything at the code level. Most engines have some sort of editor. So for example, we can consider the Flash player as a game engine. Adobe creates a tool called Flash, of course, and another tool called Flex, which are both editors that create Flash content. Of course, we'll be talking about Unity 3D in this course. It's both a game engine and a game editor. So what is Unity 3D? Unity is one of the most common used game engines and game editors in the game industry, in education, and by hobbyist game makers today. It is the engine we'll be using throughout this course. But why has Unity become so popular? And why did we pick it for this course? One thing I really like about Unity is it's not game genre specific. What I mean by that is you're not locked into making a certain type of game. You don't just have to make role-playing games or 2D platformer games, for example. You can make 2D games, you can make 3D games, you can make games of all different types of mechanics and all different types of genres. It's a very feature-rich game engine. It has very good graphics rendering, lighting, physics, particle systems, sound engine, and so on. All of those features that you want in your game engine, but you don't want to have to write yourself from scratch. And once you've learned those features while working on one game title, you can quickly move to your next game title and leverage all that knowledge that you've built. Unity is fairly easy to learn from a getting started point of view, but it has very deep features, so you can really spend a lot of time with it and become expert over that time. Unity has a really great asset pipeline. Basically, the pipeline is how to get your graphic assets, your sound assets, and so forth into the engine. Unity makes this process painless in most cases. We'll talk more about this later. Unity also comes with great documentation. This is very important when you're learning something new. There's also a great community using the game engine, so when you do run into a problem or you're exploring new features, you can find resources on the web to help you. Another nice feature about Unity is you can actually have a choice in programming language. You can program in either C# or JavaScript. Just a few more things. Unity supports iterative game development. Iterative development is one of the primary ways that we make good games today. We'll talk a lot about iterative development throughout the specialization. Unity supports iterative development very well. For example, you don't have long compile times to get your game up and ready to test. Unity is a relatively efficient game engine, so you can make high-performance games with fast frame rates. And you can also build to many different platforms. Like I said, the game engine often is a bridge to different game platforms. Unity supports building games to Mac, to Windows, to Linux, web deployment, iOS, Android, and many of the modern game consoles, and so on and so on. So the knowledge that you build in Unity can be applied to various platforms very easily. And of course, the game that you're building can be moved from one platform to another, in most cases with minimal redevelopment or minimal changes along the way. Unity is a relatively inexpensive engine. There's a free version of Unity that we'll be using throughout this course. There's also a professional version that does have a licensing cost, but it's still relatively inexpensive to build a commercial title on Unity and deploy it. Since Unity is so pervasive today, employers are seeking people with Unity skills. So the skills that you learn throughout this course and throughout the specialization apply directly to the jobs that you might be seeking, which is great. So this is not just a toy. It's not just a learning tool. It's actually a tool that you can actually use commercially and get jobs that are seeking that skill set. The other nice thing is that if you do end up using a different engine down the road, the techniques that you learn in Unity really apply to other engines. And in fact, I've talked to developers who are building their own game engine, and they love looking at Unity to mine it for ideas that they can integrate into their own engines or into their own editors. Of course, there are other tools that you'll need along the way when developing games. Unity doesn't do everything. You'll need other tools to support Unity. So for example, Unity really doesn't have an image editor. You'll use other tools like Photoshop, Illustrator, Flash, GIMP, and so forth to create 2D visuals. And 3D tools like Maya, 3ds Max, or Blender to create 3D assets and then bring them into Unity for use within your games. We'll talk more about these tools later in the course. So what's next? Now that we have a bit of an understanding about game engines and Unity 3D in particular, in the next video we'll walk through the process of getting Unity 3D installed and then begin to explore the Unity 3D editor. In this video, we'll walk through the process of setting up your workstation with Unity 3D. Our objectives will be to download Unity 3D, install it, configure it, launch it, and set up our account so we're ready to start developing games. All right, so the first thing that we're going to do is we're going to go ahead and open our web browser, and we're going to direct it to the Unity 3D website, which is www.unity3d.com. And, of course, this is the homepage for Unity 3D. We'll use this site from time to time to access various resources and get in touch with the Unity 3D community. They have some great learning tutorials and so forth, and we'll talk more about these things later. But for now, we're going to use this just to get Unity 3D. So up at the top right, there's a Get Unity option. So this brings us to the page that talks a little bit about how to get Unity. It talks about the different types of organizations that you might be. Indie and studios is what we're going to be using today, but there's also enterprise, education, and industry solutions. On the Indie and Studios page, they've got information about the 2 different versions of Unity. Of course, we're using Unity 5, which is the latest edition. And there's the personal edition and the professional edition. So we'll be using the personal edition. This is the free version of Unity. You can read a little bit about the different features that are supported on the free version versus the professional version. Really the type of things that we're going to be doing in the Coursera course, the Coursera specialization, the personal edition is plenty capable. So moving down, I'm going to go ahead and click the free download. This is where we can actually start downloading. One thing to note is the system requirements for Unity. Basically, a modern Windows computer or a Mac OS X computer with a decent GPU, graphics card, graphics processing unit. They say basically anything since 2004 should work. Of course, the newer your computer, the more powerful your computer, the better. If you want to learn more, you can click Learn More. This will give a little bit more detailed breakdown of what's required for development with Unity and what's required for running back Unity 3D games. I'll go ahead and click back on the browser and begin the download process. So I'm using a Mac OS X computer here. The process is very similar on a Windows computer. I'll go ahead and point those things out as I go. On a Mac, it downloads a DMG file. On Windows, it'll be an EXE. In both cases, I can double-click on it, to open that file. On the Mac, it basically mounts a virtual drive, and I'm going to run the Unity Download Assistant application. And go ahead and open that. So this is, the installation process, very typical. Just kind of follow through the steps here. Agree to the licensing agreement and so forth. It'll ask us what components that we want to install, the Unity 3D engine and editor, web player component, standard assets. We generally want these 3 things. I'm also going to include the 4th, which is the example project, because we'll use the example project in the next video to discuss a little bit about the Unity editor. Go ahead and continue. Where do I want to place it? I'm just going to place it on the main hard drive here and go ahead and start the download process. So this is actually a little bit over 2 gigs of information when we combine Unity itself and all the extra components that we added. So this may take some time to download depending on the speed of your connection. So I'm going to go ahead and fast forward this to the end of the download. Okay, all 4 components are downloaded, so now we're in the installation process. Once again, this will take a few minutes. to get all installed. So we'll go ahead and fast forward through this as well. All right, as you can see, my installation was successful and complete, so I'll go ahead and close the installer. Here on the Mac, it opened up the folder in the Finder of where it was installed. If I back out here, you can see it places it right in the application folder. And the folder is just called Unity. On a Windows machine, it would be in your program files folder on the C hard drive. And once again, the folder will be called Unity. Now you can see I've got various older versions of Unity here. I always like to rename the folder with the version number. That way, when I install a new version, I still have the old version around in case I ever need to go back to the older version of Unity. So I'm going to go ahead and rename this. I'll name it Unity 5.1.2 since that's the version that was downloaded. Of course, if you're running through this, you may be on a newer version of Unity because they're constantly upgrading this. You know, I'd say every month at least there's a dot update. And if I open this here on the Mac, it's going to look a little bit different on Windows if you actually go into the Unity folder. I've got the application right here. I believe it's within an editor folder on Windows. You could also rename the actual application name if you want to. You know, you can change it from Unity to Unity 5.1.2 if you want to. I'll just go ahead and keep it as Unity as installed. So I'm going to go ahead and launch this now. And I've already installed Unity, so you might get a slightly different experience here. You know, sometimes I've noticed when you first launch it, it tries to connect back home to Unity, and you might get a connection error. If that does happen, you know, go ahead and just quit Unity and relaunch it, and the second time through it should work. If this is the first time that you've opened Unity, it might also ask you for licensing information. Once again, you want the personal license of Unity. That's the free version of Unity. So go ahead and select that if it does ask you for that information. The next thing it'll ask is for you to sign into your Unity account. So the Unity account is basically the account that you'll use, you know, to get access to, as they say here, Unity services and resources. You'll definitely want to create a Unity account. There's an option here that says create one. If you click that, it's going to, I believe, open your web browser to the sign up page. And you know, you can run through the process of creating your Unity 3D account. And of course, I've already done this, so I will, you know, just skip through this. Okay, back here on the Unity startup screen, I'm going to go ahead and enter my account. And click, you know, make sure that Remember Me is checked so you don't have to log in every time. You can also just click Work Offline if you really don't want to connect back to the Unity servers. But you will want a Unity account in the future for accessing the Unity Asset Store, which we'll talk more about later. So we'll go ahead and sign in. And this will bring you to the screen that you typically will see once you launch Unity. It shows a project tab, which shows the recent projects that have been opened. Of course, yours will be blank if this is the first time that you've installed Unity. There's also a Getting Started tab, which I do recommend that you go to and play this nice little intro video. It talks a little bit about Unity, the community around Unity, and some of the resources available for learning about Unity. Over here, this shows that I am logged in. So from here, of course, I could sign out. I could go to my account on the web, and so forth. If I'm working offline, there would be a little check or a little cross here saying that I'm not logged in. So I'm going to go ahead and go back to the Projects tab, and we've got Unity installed. We've got it configured. We've launched it, and you know, we've set up our Unity account. So we're really ready to start using Unity at this point. So in the next video, we'll begin to examine the Unity 3D editor using the example project that comes with Unity. this video, we'll configure our Unity 3D editor. Our objectives will be to open the example project and then configure the editor so we're ready to start exploring. All right, the first thing that you'll need to do is open Unity 3D. I've already got mine open. I'm at the Projects tab. And I want to load the standard assets example project. And I actually happen to have it here. When you first install Unity and install the example project as part of it, it may or may not show up here. If it does not, and you know you installed it, you can click Open Other. And on the Mac, you go to the Users folder and then go into Shared, Unity, and it's right here. So you can click on that and say Open to open that. On Windows, you'll have to search a little bit. I think it's in Documents, Shared, Unity. If for some reason you don't have this folder, it didn't get installed, or you did not select the example project when you installed, you can download it after the fact. So if you once again direct your browser to the Unity 3D site and click Get Unity and then free download, rather than download the entire installer, down here where it says additional downloads, you can click that and select the example project. This will just download that example project folder. And then once again, back in Unity, you can select that to open. Okay, so I'm going to go ahead and select that. That will begin the process of opening the project in Unity. Sometimes it might take a few minutes or several seconds for the project to open. Since I've already opened this project, it actually opens pretty quickly. So, the first thing that I do when I start fresh with Unity is I configure my workspace. This is the standard default layout that comes with Unity. I'm actually not a big fan of this layout unless I'm on a very small monitor. But if you do have a decent size monitor, I do recommend changing the layout. As you work with Unity, you'll start to figure out what you like and what you don't like, and you could always customize the layout as you see fit. So under Window, there's Layouts. And right now, like I said, I'm on the default. I always like the 2x3 layout. So I'm going to go ahead and select 2x3. In Unity, there's always multiple ways of doing things. So that was under the Window menu. There's also this little quick shortcut to that over here in the upper right of the window. So once again, I can go back to default, or I can select 2x3. And it turns out that the entire environment is very customizable, so you can roll your mouse between the panes and resize them as you see fit. So often, as you're working with Unity, you'll want to resize things as you go. And if you get things messed up, you could always go back and reselect the 2x3 layout, and it will snap back to the defaults. So one other change that I like to make is to change the layout of the projects panel here. You can see there's a 2-column layout. I like to switch this to the 1-column layout. You can do that by selecting the little drop down over here on the right side and switch to 1-column layout. So there's 2-column and 1-column. There's advantages and disadvantages of each. I personally like the 1-column layout because this basically shows the makeup of the project that I'm working on, and it very much looks like the file system. So I've got folders, I can open the little cascades, and ultimately I get down to actual files. And these actually map to files on the file system, and the folders map to folders on the file system. So now that we have the Unity editor layout set the way we want it, in the next video we'll explore the example project and the Unity 3D editor. In this video, we'll explore the main elements that make up the Unity 3D editor. Our objectives will be to explore the project, scene, game, and inspector views, understand the differences between game assets, game objects, and components, and play a little bit with the example project. Okay, we're going to continue where we left off with the last video. So we have the standard assets example project open. So over in the projects panel are all the files and folders that make up this project. The files are called game assets in Unity, And as I mentioned, there's a one-to-one relationship in what you see in the project panel and what you see in the file system. So for example, if I just right click on one of these folders and say reveal in Finder, and here on the Mac, it'll open up the file system, and you can see I'm in the assets folder, and within that folder there's these various subfolders, sample scenes, for example. If I open that, you can see additional subfolders, and then scenes. If I open that, you can see here are scene files with the .unity extension. These map directly to what I'm seeing in Unity. If I back out one level, you can see I'm now in my standard assets example project folder. Within that, it's got various subfolders, including the assets subfolder. If I go back into that, once again, I'm navigating through those assets and folders that we see in the project view. While you can copy new assets directly into the assets folder in the operating system, and they'll be imported into Unity, you should only rename or move files within the Projects tab itself of the Unity editor. This will ensure that any connections to the game assets will be maintained within the editor. If you rename or move things directly in the file system, it may break connections and break your project. We'll discuss more about importing assets and organizing the project view later in the course. So let's go ahead and open a scene. Right now we just have a default empty scene here. So I'm going to go ahead and within sample scenes, I've got the scenes folder open, and I'm going to double click on car. And this will open the car scene. So over here is the scene view. The scene view allows you to navigate the 3D world, as well as select and manipulate game objects in the scene. So everything that we see out here are game objects. You can think of the scene view as your visual level editor for the current game scene. So for example, using the mouse, I can left click on things to select them, or I can click and drag to select multiple things. I can right click and then drag to essentially spin around the scene. I can use the scroll wheel to zoom in or zoom out. And then holding different key sequences on the keyboard, I can do additional things. So if I hold the Alt key and then left click, I'm essentially rotating around the view. Holding the Alt key and then pressing the middle mouse button, I'm panning around left, right, up, and down as I move my mouse. And holding the Alt key and right clicking, I'm zooming in, zooming out, or moving in, moving out, much like the scroll wheel. And there's just a whole lot of keyboard shortcuts that you'll learn as you use the Unity editor. So for example, with my mouse over any of these panes, I can hold Shift and then press space, and that will maximize that scene view. In this case, if I do it again, Shift, space, it goes back, it minimizes and goes back to the standard location. So as you use the Unity editor, you'll pick up these keyboard shortcuts. I did include a quick reference sheet, PDF, that you can use to look these up quickly. Now in the scene view, we have the little gizmo up in the top right corner. This shows our orientation on the game world. You can click on the axes to change your view on the game world. So for right now, I'm in sort of a perspective view. If I click the y-axis, I get a top-down view. If I click this again, I go back to a back view, to a bottom view, back to the top, and then I can rotate around the world and get sort of different set views on the world. Then of course, again, I can hold down Alt and then left click to, once again, modify that view using those mouse operations. And once again, using the left mouse button without holding any keys, I can select game objects out in the scene. So for example, if I click on this little camera icon, I then have selected that game object. And then I can modify things about that game object using, for example, the little gizmo that appears on that. So I can actually drag this arrow up to move the camera up, and you could actually see the results of that in this little camera preview, as well as down in the game view, which we'll talk about in a moment. I can move it down, left and right, and in and out. And there's actually a number of different transform tools available just above the scene view. So we've been using the position tool. There's also a rotation tool, for example, where we can rotate in different directions, left and right, up and down, and so forth. And you can always undo your operations, under Edit, Undo, or you can hit Control Z on Windows or Command Z on the Mac to get things back to the original state. So just below the scene view is the game view. Notice the game view is actually a different view on our game scene than we're seeing in the scene view. If you click down in the game view, you'll notice that you can't actually select things. You can't actually modify the scene from the game view. You can only preview the scene. It's basically showing what the player will see through the active camera in the game. It becomes most useful while actually playing the game. We can play the game by clicking the play button at the top of the screen. So let me go ahead and click play. So now I'm playing. I can drive forward here. I can use the WASD keys to steer, where I'll jump, and navigate around the world, spin out, and so forth. So I'm actually playing this game. And to get out of play mode, I can just tap the play button again. So there's two important modes in Unity. There's edit mode, which is the way we are when we're not playing. This is where we manipulate things in the scene and so forth. And there's play mode. Play is for testing. When we're in play mode, you'll notice that we can actually see things in the scene view, see things moving around, game objects and that sort of thing. But any change that actually happens gets erased as soon as I click play. Everything snaps back to the way it was before I played. So a couple more things on the game view. There's this maximize on play option. If I click that and then hit play, notice the game view takes over the scene, and now I'm sort of in more of a full screen type play mode, which is sometimes nice for playing to really test things out and get the sort of experience like your players might have. But sometimes you'll want to leave maximize on play off so you can actually see the scene view while you're previewing the game. One other nice thing about the game view is you could change the aspect ratio. Right now it's in free aspect, which basically means it will be whatever size I make this window. If I drag it bigger or smaller or whatnot. But if I change the free aspect ratio by clicking on it, I could drop down to something like a 16:9 aspect ratio or a 4:3 aspect ratio. And then it's going to preview the game with that aspect ratio to simulate what it might look like on a display with that given aspect ratio. So we've looked at the project view, which are our game assets. We've looked at the scene view, which is our level that we're building, or our scene, which is composed of game objects. And we've looked at the game view, which is how we preview our game. The next view I want to talk about is the hierarchy view. This is a hierarchical list of game objects that are in the scene. From the hierarchy, you can select game objects, rename them, or delete them, among other things. So for example, let me go ahead and click on the car, and you'll see that there's a direct link between the hierarchy view and the scene view. So when I've got the car selected here, it's also selected out in the world. I'm going to switch back to the position tool so I see the little gizmos. If I select the camera here, you can see the camera is selected over in the hierarchy. So the hierarchy and the scene view work together. So if, for example, I was off somewhere else in my scene and then I select the car and hit F, it's going to immediately zoom the scene view to that game object, in this case the car. The other thing to notice in the hierarchy view is that it is a hierarchy. So you can see the car, for example, has this little cascade tab which I can open and close. So the car is a game object, but it's composed of multiple sub-game objects. So if I open it up, you can see all these different child game objects making up the wheels, making up different aspects of the car. So sometimes when you select things in the scene view, it might select one of those sub-objects. So you got to be a little bit careful. If you really wanted to select the car itself, you got to look back at the hierarchy and then make sure that the proper selection was made. So I could then, in this case, click on the car. And then once the car is selected, I could go ahead and reposition it. I could use the rotate to rotate it, for example. I could use the scale tool to scale it up in any number of the axes, Y, X, and Z. And once again, I could undo those things using the Control Z on the Windows or Command Z on the Mac. So that's the hierarchy view. The last view that we haven't looked at is the inspector. The inspector basically shows details of whatever is selected. So right now my car game object is selected, so it's showing details about the car game object. So for example, I can rename it right here at the top. It shows the transform component for the game object. So this shows the position, rotation, and scale of that. And it shows a variety of other components that are attached to that game object. We'll talk a lot more about these components and how they modify game objects as we move forward in the course. So let's go ahead and open a different scene. So I'm going to go ahead and click on the 2D character scene. And Unity is going to notify us that we've made some modifications to the scene. I don't want to save those because I was just demoing things. So let me say don't save. And the 2D character scene will open. So this is an example of a 2D scene. So you can see everything looks the same. We've got of course, the scene view and the hierarchy. So let me click on 2D character and then tap F to zoom to that, and you can see it looks like a 2D character within 3D space. So one thing that we can actually do is in the scene view, we can click on 2D mode. So if I do that, you can see I immediately switch to something that looks more like what we're seeing in the game view. If I zoom out and so forth, now I'm working in a 2D mode rather than a 3D mode. So at any point in time, you can switch your scene between 3D mode, which is showing 3D space with the X, Y, and the Z axis, and 2D mode. You can see the axes go away because we just basically have the Y and the X axis. So this is a 2D game, but the Unity editor really works the same. We have game objects in the scene in the hierarchy. If we select the game objects, we can see the components over in the inspector, as we saw before. We can preview and test the game in the game view. So let me go ahead and do that. I'll hit play to enter play mode. And once again, using the WASD keys and I believe the space, I could jump, I could push these little boxes around, and you can see it's a very different type of game than the car game that we were playing before. This shows a little bit of the diversity of the types of games that you can create in Unity. Let me exit play mode. And we can see all the project files or game assets in the project panel. Now that we are starting to become familiar with the Unity 3D editor, in the next lesson we'll discuss how to create and integrate assets into our games. In this lecture, we'll talk about some of the key concepts related to computer graphics and game development. While you may be familiar with some of these concepts, I want to go over this to fill in any gaps that you may have in your knowledge so that we can communicate effectively as we move forward across the course. To do this, we use the graphics display model. In this model, we have the display layer, where we see the graphics. Underneath the display is the model layer, where the graphics are represented internally within the computer or within the game. This representation, of course, is rendered to the display. And of course, the graphics need to be saved and loaded from storage, so we have the file layer. This model maps to the hardware, the application, and file formats. We'll discuss each of these in a bit more detail. Today, displays come in many different shapes and sizes, from the display on our desktop and laptop to our smartphone and tablet, or even our smartwatches and virtual reality glasses. In general, they all work the same. Images are displayed by emitting light to create a grid of small dots that our eyes perceive as an image. One of the most important differences when distinguishing between displays is the resolution that the display supports. But what do we really mean when we say resolution? One definition of resolution is a measure of how accurately a display approximates continuous images using finite pixels. Resolution can be measured in several ways. One of the most important for us in game development is the pixel dimensions of the display. That is, how many pixels can be rendered horizontally by how many pixels vertically. Of course, the more pixels available, the higher the resolution, the more detail we can present on the display. Another measurement of resolution that you sometimes encounter is dots per inch, or DPI, or pixels per inch, or PPI. The concepts of dot per inch is most important when discussing print applications and are not that important in game development, except of course when we go to print our game poster. Pixels per inch you can think of as how many pixels can fit based on the size of your display. The more pixels per inch, the higher the pixel density, resulting in crisper text and images on the display. Of course, today we use terms like high-definition display, 5K display, and retina display to reflect the fact that our pixel density is so high that the human eye does not perceive the pixels individually when viewed at a typical distance from the display. A curve, for example, looks like a smooth, continuous bend versus a jagged approximation made with blocky pixels. Another display concept we should be familiar with is that of aspect ratio. The aspect ratio is the proportional relationship between the pixel map's width and its height. It is commonly expressed as two numbers separated by a colon. 16 by 9 is the standard for a high definition display today. Standard definition displays were typically 4 by 3 or 3 by 2 aspect ratio. Of course, the resolution or pixel dimensions, pixel density, and aspect ratio are all important concepts to grasp when designing the visual layout of our game and its interface. Another important concept is that of refresh rate. The refresh rate is how quickly the display hardware refreshes the image on the display. Refresh rate is often expressed in hertz, or the number of times per second. The faster a display refreshes, the less flicker in the display. 60 hertz, or 60 times per second, is required for most people not to exhibit any discomfort when looking at a display. Most modern LCD displays have a refresh rate of at least 60 hertz. Higher-end displays today have refresh rates of 120 hertz or more. While refresh rate is a measure of how often light is emitted from the display, frame rate is how often the display hardware can update the entire image on the display. A display may have a 240 hertz refresh rate, but because of the complexity of the game, the display hardware may display less than 60 frames per second. When the hardware can't keep up, the same frame of content is refreshed multiple times, as shown here. The human eye can perceive individual frames at anything under 10 to 12 frames per second. It basically starts looking like a fast slideshow. At over 12 frames per second, the frames blend together to create a more seamless motion. In games, we strive to maintain at least 30 frames per second, and often we try to hit 60 frames per second or above. Obviously, the computer power, resolution of display, and the complexity of the games all affect the frame rate. In the next video, we'll discuss the model layer of our graphics display model. Let's continue our discussion of game graphics concepts. Our focus will be on the model layer of the graphics display model. The model layer defines how the graphics are represented internally within the game or software. There are two primary graphics models, bitmap and vector. A bitmap image stores the color information about each pixel in the image. Therefore, this is sometimes also referred to as a pixel map. So, for example, the image shown is a 10 pixel by 10 pixel image, or essentially 100 pixels of color information, where some pixels are white and some pixels are blue. The resulting image, when viewed at a distance, looks roughly like a circle. The color information is made up of a certain number of bits or binary information. So 1 bit of information per pixel would allow you to define just 2 different color choices, whereas 8 bits of information per pixel would allow you to have up to 256 colors of information. Most images we work with today in games are 16-bit, 24-bit, or 32-bit, depending on if the image has transparency information included, which is called an alpha channel. Bitmap graphics are the most direct graphical representation to what you see on the display. That is, a bitmap image is often directly rendered to the display. Obviously, you can scale a bitmap image up, but the visual quality will diminish as you are just zooming in on the pixels that are available. You're not creating new pixels. Bitmap images can be used not only for 2D graphical elements such as game sprites and user interface elements, but also for texture maps on 3D elements, as we saw with our previous Unity project. To achieve high frame rates in our games, the pixel dimensions of bitmap images should usually be made to be a power of 2 to help take advantage of the efficiencies this allows in the graphics processing unit, or GPU. You don't have to make your images square, but both the width and height should be a power of 2, such as 512 pixels wide by 256 pixels high. While non-power of 2 images are possible, they may slow down performance of your game and should typically only be used for user interface elements. Vector images are stored internally as geometric information, or in essence, mathematical equations. So instead of storing the color information for each pixel in an image of a circle, we represent the circle internally as a coded equation within the software, such as image equals circle with radius 5 and border 1. Of course, we usually are making much more elaborate vector images through the use of geometric primitives, curves, and gradient colors. Using vector graphics tools, artists can easily create a fun cartoon look without having to know any math. Vector images have the advantage over bitmap images in that you can scale them up without the image becoming pixelated. That is, vectors scale without losing image quality. However, vectors have the disadvantage of taking longer to render than bitmap images. When the vector is displayed, it is first converted into the desired sized pixel image, and then rendered to the display. This extra step of converting the vector into a pixel map takes computer processing time. While some game engines such as Flash do support vector images, bitmap images are often used in games when high frame rate is desired. However, vector images still have their place in game development. For example, 3D graphics are essentially vector graphics in 3 dimensions. That is, a 3D model is defined by geometric polygons to create the mesh of the model. The more polygons that are used, the more detail that can be displayed. Or stated another way, the more organic or smooth the model will look. When rendering the 3D graphics, the graphics processing unit in the computer hardware often converts the polygons, which may have several vertices, into triangles for efficiency purposes. The more polygons, the more triangles, the longer it will take the computer to render the 3D model. Therefore, in game development, when we want real-time rendering of 3D graphics, we often try to limit the number of polygons or tries, or we use what is called low polygon modeling, so that the game runs at a high frame rate. In the next video, we'll talk a bit about graphics file formats. Let's conclude our discussion of game graphics concepts. Our focus will be on the file layer of the graphics display model. The file format defines how the graphics are stored in storage for later retrieval. It's important to know a bit about file formats, as they are our vehicle for moving data between one program and another, and each file format has its own advantages and disadvantages. There are many different bitmap file formats that support different features. Unity supports importing all of these bitmap formats, including Photoshop files, complete with layers and effects. While we often compress bitmap images to reduce their file size for delivery over the web, as a general rule in game development, I try to maintain the highest quality image for as long as possible and only reduce quality through downsampling or compression when I absolutely have to. Unity actually will compress bitmap images for you based on your import settings and your build settings for the target platform. Therefore, I prefer to import uncompressed images such as Photoshop files or TIFFs directly into my game projects. There are also many different vector file formats. Some game engines, such as Flash, support 2D vector images in-engine. However, as of Unity 5, Unity does not directly support 2D vector graphics. However, many artists like the workflow and resulting look of working with vector tools. Therefore, you can use a vector tool to create the graphics and then export them as a bitmap image for importing into Unity. There are a number of 3D file formats as well, including proprietary formats for Maya, 3ds Max, Blender, and a handful of other 3D modeling and animation tools, and standard formats such as FBX and OBJ. Unity actually converts the proprietary formats into an FBX file upon importing into the project. Just like using Photoshop files, this conversion is usually seamless and done in the background without you knowing it. Therefore, you can have a proprietary file format in your project, such as a Maya binary file, and Unity will convert it to an FBX automatically every time you update the file. We'll discuss a bit more about this when we talk about the asset pipeline. In the next video, we'll discuss a bit about creating game graphics. In this video, I'll discuss a bit about creating or obtaining graphics for your games. As we've discussed, game graphics can be categorized as 2D or 3D graphics. We can further subcategorize 2D graphics into 2D texture maps for use with 3D models, user interface or UI elements for creating interface in our games, and 2D sprites for creating 2D characters or props for 2D games. In terms of 3D graphics, we typically are talking about 3D models or 3D meshes, UV mapping information, which describes how a 2D texture maps onto a 3D surface, a rig structure or skeleton for controlling the model, and animation information. There are many 2D bitmap tools available. Adobe Photoshop is probably the most used bitmap graphics tool used in industry. Both Photoshop and GIMP are great general-purpose graphics tools. These tools can be used to create or edit all types of 2D bitmap elements. You may also use them to convert graphics between file formats. Corel Painter and Krita are used more for digital painting. They borrow concepts from traditional non-digital art like paintbrushes, oil paints, and chalk and bring it into the digital realm for digital art creation. There are also many 2D vector creation tools. Adobe Illustrator is probably the most used vector tool, but there are many other options, including Inkscape, which is open source and free. In terms of 3D graphics tools, Maya, 3ds Max, and ZBrush are the most used 3D graphics tools in the game industry. However, there are many great 3D tools out there, including Blender, which is open source and free. Creating art is outside the scope of this course. However, I expect most of you have some experience creating and editing graphics. I do think it's important for everyone, including programmers, to have knowledge of computer graphics creation so that they can communicate with others on the team about graphics and create, at the very least, placeholder graphics, or as they say, programmer art, until the final production art can be integrated into the game. There are many great resources available to find royalty-free, Creative Commons licensed, or purchasable graphics files. Here are just a few that I've found useful in the past. I've included a document with live links to these resources and more. Feel free to post resources that you've found in the online discussion. In the next video, we'll discuss game audio concepts. In this lecture, we'll talk about some key concepts related to game audio. Just like with game graphics, you may be familiar with some of these concepts. However, I want to cover them to fill in any gaps in your knowledge so that we can communicate effectively as we move forward. When I speak, my voice interrupts the air and creates sound waves. On the other end, your ear receives these sound waves, creating small vibrations that are transmitted as information into your brain, which you can interpret as sound and hopefully intelligible speech. So the question becomes, how do we capture these sound waves, place them into our games, and then play them back at appropriate times so our players can hear them? We use the graphics display model to speak about game graphics. Well, let's modify this model slightly to reflect audio playback. Instead of the display, we'll have a speaker as our hardware component, with the rest of the model remaining pretty much the same. Let's start by talking about the hardware or speaker layer. In terms of the speaker, I'll not talk too much about the technical details of the hardware, other than to say the speaker is what turns our digital data back into analog sound waves. That is, the speaker vibrates and disrupts the air, creating sound waves that our ears or the ears of our players hear. The type of speaker and the quality of speaker have an impact on how sound is experienced in our games. The speakers integrated into a laptop computer will not typically create the same experience as a two-speaker system with subwoofer, or a 7.1 surround system for that matter. And of course, headphones are another form of a speaker that are often used in gaming. Unity 3D is able to create 3D positional audio on a variety of speaker systems, including headphones, to create an immersive audio experience in your games. Now let's talk a little bit about the model layer. The model layer defines how the audio is represented internally within the game or software. There are two primary models: digitized audio and synthesized sound. I'm going to focus mostly on digitized audio in this lecture. The process of turning the analog or continuous sound wave into digital data is called sampling. What we do is we sample the sound several times a second. This is called the sample rate and is typically measured in hertz or samples per second. The digital sample is an approximation of the original analog sound wave. The more times per second we sample the sound wave, the better the approximation. Or in audio terminology, the higher the fidelity of the sound. Typically, music is sampled at speeds of 44.1 kilohertz or 44,100 times per second. The other component in sampling is how much data are we storing per sample, or what is the sample size. We typically store 8 bits, 16 bits, or 32 bits of information per sample. The larger the sample size, the better the resolution or signal-to-noise ratio, or in audio terminology, the more dynamic the sound is. Lastly, we may sample multiple sound waves coming from different sources and then mix them together to create one or more tracks of information. Of course, one track is typically referred to as mono audio, while 2 tracks is stereo, and we can have many more tracks in a multi-track recording. Game assets typically have a sample rate of at least 44.1 kilohertz, a sample size of at least 16 bits, and are either mono or stereo depending on their use in the game. Let's conclude by talking a bit about the audio file formats. There are a number of proprietary audio programs such as Adobe Audition or Audacity that have their own file formats that support all the features of the software. No matter what audio tool you use, you typically can save or export to a WAV, AIFF, MP3, or OGG file, which are file formats that Unity 3D supports directly for importing. When saving to one of these file formats, you typically need to specify the sample rate, the sample size, and the number of tracks. In the next video, we'll discuss a bit about creating game audio. In this lecture, I'll discuss a bit about creating or obtaining audio for your games. While I know most of you are not planning on becoming sound designers or composers, I know most of you will not have the resources to hire one while working on your games, and your games definitely need sound. Just like everything else, it's good to know enough that you can get by. There are three primary types of game audio: voice, sound effects, and music. Voice is probably one of the easier things to add to your game, as you can probably recruit friends and family as voice actors, and if you live near a college or university, theater students are always looking for experience acting. Working on a game may be exciting to them. Recording voice is not very hard if you follow a few simple tips. First off, get into an environment that is noise-free as possible. It's really hard to take out background noise in post-production. If you can, use a decent microphone and sound recording equipment. There are very affordable USB microphones that are a big step up from the built-in microphone in your computer. Don't talk too close to the microphone. Different microphones have a sweet spot of where they record best. Usually it's about the distance of the hang loose sign, away. Also, don't speak directly into the microphone. The microphone will pick up little puffs of air, what they call plosives, for the P's and the T's. So speak over the microphone or under the microphone if possible. And if possible, you can get a pop screen as shown here in the image. You can pick one of these up for relatively inexpensive. And you will probably need to adjust the mic levels based on your voice actors. If they're singing or yelling, you might have to turn the input down versus talking or whispering. You might have to turn it up just to maximize the levels that you're getting from your voice actor. There are many great sound editing tools available for recording and editing voice. Adobe creates a sound tool called Audition, which is part of the Adobe Creative Cloud. The heavyweight for audio professionals is Avid Pro Tools. Audacity is a great open source free tool. If you don't already have a sound editing tool, I think Audacity is great. I highly recommend downloading and installing it for your audio needs across this course. There are two types of sound effects: reactive and ambient or atmospheric. Reactive sound effects are sound effects that occur when something happens in your game. If something moves in the game, it probably should make a sound. And of course, most player input should probably also have a sound effect tied to it, such as jumping and shooting. From the sound of birds off in the distance to the sound of people chatting nearby, ambient or atmospheric sound effects help the player feel like they're immersed in the game world. In terms of creating sound effects, with a decent audio recording device, you can go out into the world on location and record sound effects. And if you don't have a decent audio recording device, a smartphone would probably work in a pinch. You can also do some quick Foley work on your own. It's really amazing what you can do with just your voice and a few everyday items. For example, if I was trying to create a punching sound, I could just grab a water bottle and you get the idea. In terms of finding sound effects, there are many great places to find royalty-free, Creative Commons licensed, and licensable sound effects. Here are just a few that I've found useful in the past. I've included a document with live links to these resources and more. Feel free to post what you found in the online discussion. Music is one of the best ways to add emotional impact to your games. Nearly all games should have some form of music. And music happens to be one of those things that beginner game developers often overlook as they build their games. So you should think about it early in the design process. Don't save it for the last thing that you do. You should also debate what style is most suitable for your game or the particular game scenario. And you should take inventory of what you need. Think about how many levels are in your game and other things that you might use music in, such as main menus, credit sequences, cutscenes, and so forth. Here are some common questions you should ask yourself as you think about music in your games. First off, will it loop or end naturally? If it loops, it needs to loop seamlessly. How often will the music change? You don't want to drive your player crazy with repetitive music on a tight loop. And where will the music be used? Music in the main menu probably doesn't have to compete with other sound effects, while music in the game probably is secondary to those other sound effects. In terms of creating music, there are many great tools out there. Some of them, such as GarageBand and Fruity Loops, are easy enough to use that you don't even need to be a musician to get reasonable results. The other option, of course, is to find a composer. One option that may work for you is to locate a student or a friend or a hobbyist composer looking for experience working on a game project. They may produce music for free or for a very reasonable price for this experience. Of course, music creation may be a bit far outside of your comfort zone, so you may just want to find music to use in your game. There are many great resources out there with royalty-free, Creative Commons, or licensable music. Here are just a few resources that I've found useful in the past. I've included a document with live links to these resources and more. In terms of using commercially produced music from your favorite band, just realize that you would need to seek a license to include that music within your game if you plan to distribute it. If you do not have a license for this music and you include it in your distributed game, you would be violating copyright law. So what's next? In the next lecture, we'll discuss the overall asset pipeline. In this lecture, we'll discuss the asset pipeline. The asset pipeline, simply put, is the steps it takes to get a game asset into the game. A typical asset pipeline includes 3 stages, each with various substages, starting with pre-production. Pre-production is where the design and conceptual work happens. Concept art may be sketched and reference imagery may be gathered. For example, if the target graphical asset was a 3D model of a 1969 Ford Mustang, reference imagery would include photographs of that vehicle. In large game development teams, pre-production may be done by a team of designers, concept artists, and lead artists. The next stage of the asset pipeline is production. Asset production will vary quite a bit depending on the type of asset you're creating. In the case of 3D graphical assets, production typically includes modeling, UV mapping, texturing, rigging, and animating. These steps may be completed in one or more tools and involve one or more file formats. In a large team, different individuals or teams of individuals may take on each of these roles. The final stage in the asset pipeline is integrating the asset into the game. On a large team, this would typically be the work of the level designers or the technical artists. It is important to note that the asset pipeline is often not a linear pipeline. Once an asset is integrated in the game, there may be design or production changes that lead to the asset needing to be updated. Just like game development itself, asset creation is often an iterative process. Orchestrating a smooth and efficient asset pipeline is hugely important for the success of the project. If the asset pipeline breaks down, the development of the game will halt. One of the steps that often leads to a breakdown is right here, between the production of the asset and the integration into the game. This step is hugely important to ensure that the asset works in the game and looks and sounds as it should. Of course, the integration step is highly dependent on the game engine you're working with. Unity 3D, for example, eases this process through its automatic importer. Typically, at the end of the asset production, you'll have something like a Maya binary file for a 3D asset, complete with a model, UV map, texture, rig, and animation, a Photoshop file for a 2D asset, complete with layers of pixel maps, and a WAV file for audio assets, complete with multiple tracks of audio. When you import, Unity makes an exact copy of these files and places them into the project asset folder. At the same time, Unity converts these files into a usable format for within the game engine. As we just said, when you import a Maya binary file into Unity, Unity will automatically make an FBX version of the Maya binary file and store it in the library folder of your project. If you edit the Maya binary file within the project folder and save it, Unity will detect that it is changed and automatically make a new FBX version behind the scenes, and the new asset will automatically appear in the game. This automation greatly speeds up the asset pipeline and supports iterative development. While it's not 100% foolproof, it works most of the time without issue. For example, one of the gotchas with the importer is that in some cases, it requires additional software to work properly. For example, in the case of Maya files, you must have Maya installed on your computer to import Maya files. Unity uses Maya to do the conversion to FBX. If you give a Maya file to someone who does not have Maya installed and they try to import it into Unity, they will not be able to. To get around this, in Maya you can export to FBX and then import the FBX directly into your Unity project. While this makes the asset pipeline a bit less elegant, it may be required depending on the makeup of your team and their computer setup. One final note on the import process into Unity is that Unity allows you to modify how the game asset is imported through the import settings on the game asset within the Unity editor. As we work through this course, we'll do this from time to time. Well, we're almost to the end of week 1. I'm trying to get most of the conceptual concepts out of the way this week so we can focus on more hands-on learning through the rest of the course. Congratulations, you've reached the end of the first week of Intro to Game Development. Like I said up front, game development is hard fun, and I hope you're having a lot of fun and, of course, learning a lot along the way. We have many exciting things coming up in the following weeks, so come back soon and continue your journey into game design and development. It's time to build our first Unity 3D project. For our first week's project, we're going to make a primitive model of our solar system. While the resulting project is not technically a game, this project will showcase the basic workflow in making Unity 3D games. We'll apply the knowledge that we gain in this project to all future projects. The concepts that we will learn include creating game objects, understanding 3D space, including vectors and transformations, attaching behaviors to make our games interactive, creating and modifying materials to make our games look good, the basics of lighting our 3D environments, how to add audio to our games, how to work with cameras in Unity, how to test and build our games, as well as how to save and submit our games for peer review. So as we go through this project, you really have to decide what works best for you. You can follow along with the video. Maybe you have multiple screens or a lot of real estate where you can position the video and then follow along with Unity. You can watch a bit and then pause and then try to reproduce what has been done in Unity and then come back to the video and continue. Or you could watch the entire video, then go into Unity, try to reproduce what was done, and then maybe go back and rewatch the video to make sure that you hit all the steps. Or of course, some combination of these techniques may work for you. Really, you'll have to kind of experiment, on this first project. So as we continue in the course and have similar type activities, you kind of know what works best for you. So what's next? In the next video, we'll actually get started creating our first week's project. In this video, we'll get started creating our first Unity 3D project. Our objectives will be to download the assets that we'll use in the project, start up Unity and create a new project, and then import the assets within that project. Okay, the first thing that we're going to do is download the assets that we need. So here on the Coursera website, I'm going to download the solar system assets for the week 2 project. And these will come down into my downloads folder. It comes down as a zip archive. On the Mac, I could simply double click on the zip archive to extract it. If you're on Windows, you can right click on the file and choose extract here to extract it. So once I extract it, I get a folder called Solar System Assets. I'm just going to drag it out here onto my desktop. So this folder, if I open it, has 3 subfolders. It's got a scripts subfolder that has 3 C# script files. You can see the .cs extension. It's got a folder called sounds, which has 3 audio files that we'll be using. And it's got a textures folder, which has a number of JPEG images courtesy of NASA. These are different pictures of different planets. So if we look at the Earth, for example, you see, yes, that's a nice picture of the Earth that we can use as a texture on a planet. So let's go ahead and start Unity 3D. And I want to start a new project, so I'll go ahead and click New Project. And I want to give it a logical project name, so I'm just going to call this my Solar System Simulation. And it may take a few seconds for the new project to come up, but here we go. I've got basically an empty project here. You can see there's nothing in my project tab. When Unity first starts up, it does give you an initial scene. The scene isn't saved yet, but you can see in the scene I've got a main camera that's basically the view of what I'm seeing down in the game window. And I've got a directional light just to give some initial light to my scene. We'll eventually change what's in our scene, but this is the defaults for now. So what I want to do is I want to import those assets that I downloaded. So there's many different ways to do that. I can go under Assets, for example, and choose Import New Asset. With this technique, it allows us to pick one asset at a time and bring it in. Of course, I've got many assets, so let me go ahead and cancel out of this. And if I go back to my file system and position my windows accordingly, I can simply just drag and drop these folders into my project panel within Unity. So let me go ahead and do that. I'll select all three of these and drag them over and drop them right there in the project panel. And that will start the process of importing the assets. And depending on the number of assets and how large they are, it may take longer to import. So you can see those same folders that we had in the file system are now here in the project. So we've got a scripts folder with the three script files. We've got a sounds folder with the 3 sound files. And we've got a textures folder with all of those NASA provided textures. The process of importing duplicates those files. So the original files on my file system that were on the desktop are separate. The files themselves were copied into my project folder. So if I rename these or make changes here, it wouldn't reflect back to that original folder where I got these files from. So now we're ready to start building our project. In the next video, we'll discuss a bit about the 3D coordinate system, as well as the important mathematical concept of vectors and transformations. In this video, we will discuss a bit about the mathematical concepts related to working in three-dimensional space. The first thing that we need to understand is a little bit about the coordinate systems. A lot of times when you're working with bitmap graphics tools such as Photoshop or GIMP, you might be familiar with a coordinate system like we see on the left. In this coordinate system, we've got in the upper left-hand corner, we have the 0, 0 position. As we move horizontally, we go up in pixels, the first pixel position, the second pixel position, and so forth. As we move from the top of the screen or the top of the image down, we move up once again in pixel position. So, the first row, the second row, the third row, or you can view these as rows and columns, as I was saying. So this is what we might consider an integer-based coordinate system where there is no in between. You're on 1 or you're on 2 or you're on 3. There's no halfway between 1 and 2, for example. You might also call this device specific. So it maps very clearly to your display. On the right-hand side of the screen is a 2D Cartesian coordinate system. This is a type of coordinate system that you might have experienced before in a math class like geometry, where we've got the 0, 0 position at the origin or in the middle. And as you go up, you go into the positive y direction. As you go to the right, you go into the positive x direction. And we also have negatives. So you can go below the origin, which would be the negative y direction, and you can go to the left of the origin, which would be the negative x direction. This is a real-based or a floating point-based number system. So that between 0 and 1, for example, there's actually an infinite number of positions. So you can go to 0.5, you can go to 0.55, you can go to 0.5555, and so forth. So there's an infinite number of mathematical points between any 2 points, unlike the 2D bitmap coordinate system that we just spoke of a minute ago. In this coordinate system, rather than talking about pixels, we're often talking about a unit of measurement. So 1 might mean 1 meter, like it does in Unity, or it could be 1 mile, or it could be 1 inch or 1 centimeter. But like I said, in Unity, we typically work in meters as our unit of measurement. So using this coordinate system, the next important concept is to talk about points and vectors. So a point is a location within your coordinate system. So A and B are points, for example, whereas a vector is a displacement in space. So D and C in this diagram are vectors. So let's talk a little bit more about this. So when we're defining a point, we need to know the x and the y position. So how many units over in the x and how many units up or down in the y. For a vector, they're really defined by direction and magnitude. So the question is how do we define direction and magnitude in order to define a vector? So, one thing that we can actually do is we can actually use 2 points. So one way to define the vector D would be to define the initial, the beginning of the vector, or the x1, y1, and then the end of the vector, which would be another point out in space, such as x2, y2. But it turns out that vectors are a little bit unique. So unlike a point or a location in space, vectors really are about the direction and the magnitude rather than the location of space. So here you can see that the vector D is represented in 2 locations. And the question is, are these the same vector? And yes, it turns out that they actually are the same vectors, even though they look like they're in very different locations within the coordinate system. So, really it's about the direction that the arrow is going in and the magnitude. So we can define a vector based on a displacement from the origin. It's the same thing as a displacement, anywhere else in the coordinate system. So in that sense, we could simplify, rather than talking about 2 locations, we could just simply talk about a vector, x and y. So we've got a location which would just be x and y, and then we have a vector, x and y, which, with those 2 single pieces of information, you could define the direction or the angle off of the origin, and you could define the magnitude, or really the length of that arrow line. All of those things are implicit off the origin. So, of course, with games and Unity 3D and most 3D systems, we're using a 3-dimensional Cartesian coordinate system rather than 2D. So we go ahead and we add the z-axis, which is typically represented, forward and back. So the positive z direction would be toward your face, and the negative z direction would be, out away from your eyes, moving forward. So in that sense, we can define a vector off of the origin. A vector 3 or a 3-dimensional vector as x, y, and z. So just as sort of a nice aside, the visual representation of the coordinate system, the x, the y, and the z, is shown in the same colors as we see in Unity 3D. So the x-axis is red, the y-axis is green, and the z-axis is blue. So, one quick way to remember these is RGB equals XYZ. So RGB, of course, is, the common abbreviation for red, green, blue. So, red is X, green is Y, and blue is Z. So that's one quick way in my mind that I remember when I, see the little gizmos in Unity and they have the color coding. I quickly know, oh, that's the, if it's blue, that's the Z axis. So, how do we define a model's position, rotation, and scale in 3-dimensional space? Because that's really what we're working up to, because we need to start to build our solar system, and of course we need to position our planets, rotate them, and scale them accordingly. So we can actually use multiple vectors to do this. So position, we've already talked about, is just an x, y, z location. We can actually use a vector to define, the displacement off of the origin in the x, the y, and the z location to define where that position is. The rotation, we can use a vector 3 as well, x, y, and z, and the scale. So let's talk a little bit more about that. Like I said, the position is the displacement from the origin of the world coordinate system, how many units over in the x, up or down in the y, and in and out in the z. Position or rotation is how many degrees of rotation around each axis. So how many degrees do we rotate around the x-axis, the y-axis, or the z-axis? And then scale is a little bit unique. Really we're talking about how much a model is scaled from its default size along each of the axes, x, y, or z. So it's really a scale factor where 1 equals 100%. So 0.5 would be a 50% scale of regular size, as an example. Maybe regular size is 1 or 1 meter, so 0.5 would be half of a meter in scale along the respective axis that you're defining. So, it turns out that there is a mathematical concept called the transform. And what the transform does is it packages together these three vectors. So the position, the rotation, and the scale are all combined into what's called a transform. This is also a standard component of game objects in Unity. So any game object, as we'll see soon, has a transform component that defines the position, the rotation, and the scale. So now that we understand a bit about 3D space, vectors, and transforms, in the next video, we'll get into Unity, kind of see how these concepts apply, and begin to build our solar system. In this video, we'll set up our solar system with the sun and a few planetary bodies. Our objective will be to create the game objects that make up the sun, the earth, and the moon, and to modify their transforms to set their position in three-dimensional space and their respective scale. Okay, here I am in Unity. I've got my project basically set up with my assets imported. So the first thing that I'm going to do is basically create my sun. So to do that, of course, you could use an external modeling program and model it and then import it, just like we imported the other assets. But there are some basic 3D primitives that you can create directly in Unity. So under Game Object, you can go down where it says 3D Object, and of course our sun is just a sphere. So we're going to go ahead and create a sphere. And you can see, I could just use the scroll wheel to zoom in here a little bit. We have created a sphere. In our hierarchy, of course, we can see the sphere as well. The game object is called sphere. If I click on that and move my mouse down a little bit, I can rename this. I'm going to name it sun. As you're building projects, it's always very important to name your game objects in a logical fashion, because at times you'll literally have hundreds and thousands of game objects in your hierarchy. So you want to give them good logical names so you can find them. You don't want Untitled 1, Untitled 2, Untitled 3, because then you just have chaos. So we've got our sun here. It is positioned. I can look over here at the transform component for the game object. You can see it's positioned right at the origin, 0, 0, 0, rotation 0, 0, 0, scale 1, 1, 1. Okay. If I move this, I can grab the little gizmo, move it off. You can see once again that it moves in the X direction as I move that gizmo. If I grab the Z, I can move it in the Z direction. And the Y, I can move it in the Y direction. And you can see it down there in the game view as well, moving, as I'm moving it. But I do want to position it right at the origin of the world. That'll be sort of the center point. The anchor of our solar system is at 0, 0, 0. So let me go ahead and just manually enter 0, 0, 0 in the transform component and get my sun right there in the middle. As you're moving around, once again, I could use the option key and left click, and I can use the scroll wheel and with the option move around and that sort of thing. Whenever you're moving around here, once again, remember you can always select the game object and tap the F key, and the scene view will immediately snap back to that game object. So that's a quick way, to switch around. So let's go ahead and create the Earth now. So we're going to do the same process. I'll select Game Object, 3D Object, and create another sphere. It's essentially going to create it right on top of, it didn't look like it did anything, but it actually created it right on top. If I move it off here a little bit, you can see now we've got two spheres. And once again, I want to rename this right away. So it's got a logical name. You can rename it right there in the hierarchy, or, with the game object selected. Over here in the inspector, you can also rename it right here. So I'll go ahead and name it Earth. For this game object, I'm going to make it a little bit smaller. So this isn't going to be a scale model by any means of the actual solar system. This is much like the little model that you might have in a science or a physics class, growing up with the, little solid balls on arms that spin around. So, I'm going to make this just for purpose of display about half the size of the sun. So, there's sort of two ways of doing this. You can actually use the scale tool, which is up here. And, if I grab these little gizmos, I can scale it in any one of the three directions. Let me go ahead and undo that. Or I can, click the middle to scale from there, and you can see it modifies all three at the same time. So if you're a very visual person and just want to do it visually, you can do it that way. You can also, of course, go over to the transform component and enter things. I'm going to be, somewhat precise, so I'm going to say 0.5 in all three axes, so X, Y, and Z. So it's roughly, or it's exactly 50% of the size of the sun in this model. Now I need to position it. So I can manually, once again, if I go back to the move tool, so we looked at the scale tool, the move tool is the default, which is these four arrows. And, I can kind of move it out, just in the X direction as an example. Or I can move it wherever I want. But for purposes of example, once again, I'm going to be precise. So over here in the transform, I'm going to move it out 2 meters from the center of the world in the X direction. And leave it right at Y0 and Z0. Once again, at any point, we can kind of move our camera around to kind of see what we're doing. We could always, use the little gizmo here at the top to quickly snap. So if I click here, it does, a sort of a straight-on shot. It says from the back, and I could rotate around the left side, the front, the right side. I can do a top-down view. So now I'm looking top-down at the world. Or if you click back in the middle, it'll go back to perspective view, or I can just, manually drag to do that. Okay, so I can see both the sun and the Earth at the same time. And of course, this is not affecting my camera. My game camera always is the same here. We'll actually change the game camera here in a moment. So we're going to create one more planetary body. We're going to create the moon that will eventually orbit around the Earth. We could do the same process, but just to show, a different technique. Since I know it's going to be a sphere and it's going to be very similar to the Earth, I'm going to just select the Earth and go under Edit, Duplicate, or you could always use the shortcuts. On the Mac here, it's Command D. It's probably Control D on Windows. So I'll go ahead and duplicate that. You can see it made another Earth, called it Earth 1. Immediately, I'm going to rename that so it's not confusing, and I'll call it the moon. Once again, it's right on top of the Earth, so it essentially looks like one sphere now, but I can drag it out just to see that it is different. Once again, I want to change the size. This is going to be about 10% of the normal size, so we can do 0.1, 0.1, 0.1 in all three directions, so it maintains as a sphere. And once again, we need to position it. We can do this by hand, let's say 1.5, and maybe we'll place the Earth, somewhat between the sun, 1.5 meters out from 0, 0, 0, and the Earth, I think, was at 2 meters out from 0, 0, 0. So the last thing I want to do is play with my camera a little bit. The camera, if I select, we got that for free with the untitled scene. I can go ahead and click the F, and you can see that it's represented as a little gizmo, a little icon that represents the camera here, because we don't visually see it, in the game, but we can see it with that little gizmo in the scene, so we know where it's at. The camera right now is positioned at 0, 1 meter high, and -10. So, I want to basically have it right on the same plane as rest of the world. So, I'm going to move it down 1 meter, so back down to 0. And it's a little bit far away right now at negative 10 meters from the origin, so I'm going to put it at negative 3. And you can see my game view immediately changed. It's a lot closer in with the sun right at the middle, then the moon, and then the Earth. We'll leave the camera at 0, 0, 0 rotation and just a regular scale. So the last thing I'm going to do is actually save my scene because you never know when computers might crash. So I'm going to go ahead and say File, Save Scene, and it's going to ask us to name that scene. Why don't we just call it Solar System? Seems like a logical name. It's going to save it naturally into the assets folder of the project, so you usually don't have to necessarily change this, at least when you're initially saving the scene. So let me click Save. You can see it created a new file in my project called Solar System. It placed it at the top level. For a small project, that's fine. If you have a complex project, I do highly recommend organizing your project's folder, your assets folder in a very logical fashion. So you can see we've got scripts, sounds, and textures. I'm going to go ahead and click the little Create drop-down and create a new folder. And I'm going to name this Scenes as a folder to keep my scenes. And I could go ahead and drag and drop my Solar System scene into that folder. So now within that folder, I've got the solar system. So, if ultimately we build many different scenes in our project, we would, of course, save those all in the scenes folder. In the next video, we'll get our solar system moving through the use of behaviors attached to the planetary game objects. In this video, we'll get our solar system moving through the use of behaviors. Our objectives will be to use behaviors to get our game objects rotating in a logical fashion, understand a bit about parent-child relationships between game objects in Unity, and understand the difference between the world coordinate system and local coordinate systems of game objects. All right, so the first thing that we want to do is get our sun moving. So we've got this scripts folder. This contains a number of pre-created C# scripts that we're going to be using in our project today. Most notably for this part, we're going to be using the rotate around script. So if you click on a script, you can kind of see a preview over here. You don't edit scripts directly within Unity. You typically open up a external script editing tool or a text editing tool. Unity comes with a tool called MonoDevelop, which we'll talk about later in this course. But for now, we're not going to actually do any coding. We're just going to use these pre-created scripts that come with this set of assets. So over here, let me go ahead and select on the sun, and of course I can hit the F key to zoom right in. We're going to attach that rotate around script, or often they're called behaviors, right to the sun. So there's many ways of doing everything in Unity. It is a very visual environment, so I could literally click and hold on the rotate around script. I can drag it over and drop it right in the scene view on the sun game object. I could also drop it right on the sun in the hierarchy. Or if the sun is selected, I can also drop it right in the inspector. So all three of those methods do the exact same thing. If I let go here, it will add that rotate around script to the sun game object. Scripts basically become components, just like the transform component. We've got another component now in our inspector, and you can see it says rotate around. The script has two additional properties that we can set. One is the target. The target is what we want to rotate around, and the second is the speed. If you don't set a target, it'll basically rotate around the center of the world, I believe. But we can actually set a target. These things, once again, you can drag and drop things, or when you've got the little dot next to it, you can click on that. It will open up a selection tool, which will show all the possible things that you can select of that certain data type. So this is looking for a transform attached to a game object, and these are all of our game objects that have transforms on them in the world. And we want the sun to spin around itself, so I can just go ahead and select sun. So once again, I could do it that way through that little selection pop-up. I could have also just grabbed the sun game object, dragged it over here, and dropped it into that slot. The final thing I want to do is set the speed. And this script is set to pick the number of degrees per rotation, the number of degrees rotating per second. So let me go ahead and pick 5 degrees per second and hit return. And we haven't actually played our project yet, but so now that we actually have it do something, I can actually hit the play button and the script will start to execute. And it's kind of hard to see down in the game view because we don't have any textures or any materials applied yet to the game object. We'll do that here in a moment. But we can tell up in the scene view that it is actually rotating when the sun is selected. If I click on a different object, like the Earth, it's a little hard to tell, but once again, if I click back on the sun, you can see the sun is actually rotating. Now, while I'm playing, the Unity interface darkens a little bit, and you can see the play button is depressed. I can actually make changes over here. So with the speed of 5, let me go ahead and change it to 50, for example, and hit return. You can see now I'm rotating much faster. But notice what happens when I stop playing. So let me hit the play button to stop playing. Notice the speed went back to 5. Okay, so when you're not playing, you're in edit mode, and in edit mode you can make changes. So I could, let's say change this to 10. That change, sticks in essence. It stays. When I hit play, now I'm rotating at 10. If I go ahead and modify this and change it to 100, for example, we can see the result of that as we're playing. It's sort of a quick way to do iterative development to kind of test things out, kind of. I can actually click and drag right by the speed, to kind of get the speed that I really want. But once again, after then, I have to kind of look at that and say, oh, it's 156. And then when I stop playing, it goes back to the original setting, so I would have to then change that. So for sake of example, the sun's going to rotate fairly slow, so I'll just leave it at 5. Let's go ahead and do the same thing to the Earth. So I'll select the Earth. I'm going to use the rotate around script, so I'll use the other technique. I'll drag and drop it right on the game object in the scene. You can see it attached it over here as a component on the Earth game object. Once again, I'm going to set the target to itself, so I'll drag the Earth game object out of the hierarchy, set it as the target, and go ahead and set a speed of let's just say 1 degree per second, and go ahead and play that. And you can see it's moving very, very slow. So let's go ahead and increase that up to 10. And we can always, quickly test things, see it rotating. And the last thing, let's go ahead and get the Earth rotate, or the moon rotating as well. So I'm going to go ahead and drag and drop the rotate around right onto the moon game object in the hierarchy. Select the moon to see it. I'm going to set the target of that to the moon through the select transform pop-up. And I'm going to go ahead and set this speed, let's just say to 15 degrees per second. And go ahead and play. So now, as I select these things, I can see they're all rotating, essentially spinning around their own internal axis, their sort of local axis. Or their local origin. But what about making the planets rotate around each other? I mean, that after all, that's our end goal here. So I'll go ahead and stop. So I go back into edit mode, and there's a couple different ways of doing this. For the Earth, I want the Earth to rotate around the sun. So let me actually add a second rotate around script to the game object. So I'll go ahead and drag and drop it onto the inspector with the Earth game object selected, and you can see I can actually have multiple of the same component type, and when they are scripts. I'll set the target of this to the sun rather than to itself, and I'll go ahead and set the speed. Let's just say so we can clearly see it. You got to make sure that you select the right component. So the second component here that's rotating around the sun, I'm going to go ahead and set it to 40. Go ahead and hit play. And you can see, oh yeah, the Earth is definitely rotating around the sun, but it's kind of leaving the moon behind, right? So let's go ahead and stop this. So we need to get the moon rotating around the Earth, but since the Earth is moving, rotating around the sun, if I do the same technique, basically the moon will kind of be left behind. I can show that really quick. Add that rotate around script to the moon. set its target as the Earth. Let's set the rotation speed a little bit slower. Let's just say 5 per second, and go ahead and hit play. And you can see that the moon is kind of chasing the Earth now as the Earth is spinning around the sun. Clearly, that's not what we want. And then as it comes by, it kind of tries to catch up there. Let me go ahead and click the Y axis so we can see kind of a top-down view. Zoom out a little bit. So as I'm playing, it makes it a little clearer what's actually happening there. So really the best way to resolve this is to make the moon a child of the Earth. So I'm going to go ahead and remove that second rotate around script. So you can always remove these components that are removable by clicking the little gear drop down, and you can select remove component. And that gets rid of that rotate around. I want to keep the other one because I still want the moon to rotate around itself. So I'm going to basically take the moon and drag it and drop it right on the Earth. And what that does is it makes the moon a child of the Earth. So they're both game objects, of course, but this is the parent game object and this is the child. And the child, basically, it's transformed now, modified, and it's relative to its parent. So notice the position is now -1, 0, 0, because it's -1 meters in the x direction away from its parent. If I drag it back to the top level, you can see it's 1.5 off of the world coordinate system, because the world is essentially its parent. Once again, put it back on the Earth, and it's -1 meters from the center of its parent, which is the Earth. So now when I play, without adding any scripts, you can see that as the Earth is rotating around the sun, so too is the moon rotating. So it basically maintains its same relationship to its parent all the way around, as the Earth moves. And of course, it's spinning itself. Now, if we really want to get fancy, we can have the Earth also, the moon also rotate around the Earth. So I can go ahead and add a second script like we had before. Set the target as the Earth. Give it a speed of 5 again, and go ahead and play this. And now, of course, we've got the sun spinning, we've got the Earth spinning and rotating around the sun. We've got the moon spinning. It's moving with the Earth as the Earth rotates around the sun, and it's also rotating around the Earth. So as you watch this, you can see that it does, continue to circle the Earth. So to reiterate, the world coordinate system is centered at the origin of the world. Often it makes sense to discuss game objects' location overall using the world coordinate system. So for example, the Earth rotated around the center of the world, or 0, 0, 0. The local coordinate system is the coordinate system where the origin is a defined location related to the game object, usually the center of the game object. The local coordinate system made sense to talk about when we spoke about the planet spinning around its own axis. Like the sun, the Earth, and the moon spun around its own origin. Parent-child relationships add yet a third coordinate system. That is, a child may move relative to its parent's local coordinate system, as we saw with the moon moving around the Earth as the Earth moved around the sun. So what's next? In the next video, we'll start to make our solar system look a bit more aesthetically pleasing through the use of materials. In this video, we'll enhance the look of our solar system through the use of materials. A game object is often made up of 3D geometry, sometimes called a 3D model. It is represented here as a wireframe. You could think of the material as the wrapping paper around the game objects. All game objects that are visible have a material. All game objects have a shader. A shader is basically a formula that defines how the material is rendered. That is, how the material looks. The material in the shader is what makes the game object visible on the screen. There are different types of shaders, each with its own properties. One of the common properties of shaders is a texture. In this example, the texture is what makes the sphere look like the planet Earth. Our objectives will be to create materials for the sun, the Earth, and the moon, as well as create a skybox material. A skybox is a special type of material that is a wrapper around your entire scene that displays the vast beyond of the world. In our case, it's outer space. Okay, so we're going to add materials to our various game objects here, starting with the sun. And once again, there's many different ways to do things. There's a lot of shortcuts. We'll show a couple techniques here right now. So under the textures, we can see we've got all these lovely textures acquired from NASA. So for example, if I click on one, I can get a preview over here in the inspector. So here is a sun map image, a picture of the sun surface. And one kind of shortcut is you can actually take a texture like this and actually drag and drop it right on a game object, either in the scene or in the hierarchy. So let me go ahead and do that. And you can see that that essentially applied that sun map texture to the game object. If I actually click on the sun, what actually happened is it added what's called a material component. And once again, materials have shaders, and if you actually open up the details of the shader, it's got a variety of maps for the standard shader type. The albedo map is the top level one, and it actually applied that sun map texture as that albedo map. If I actually click on this, you can see it shows that that's what's actually selected there. The other thing it did is it actually created this material. So a material is actually a separate game asset, just like the textures themselves. So you can see it actually created a materials folder for me up in the project, and if I open it up, it created a material called sun map. Of course, I could rename this if I wanted to, just like any other game asset. I can call this sun material as an example. And you can see the sun material is what is attached to the sun. We'll go back and play with some of these settings in a moment. But for now, let's go ahead and create one of these for the Earth. So I'll do the same technique. I'll grab the Earth map texture, drag and drop it onto the Earth. You can see it created a new material called Earth map 1K, corresponding to the same file name. So I'm going to go ahead and rename that just for clarity. Call it the Earth material. And once again, I can see the component attached to the Earth. I can open it up and see that texture is attached there as the albedo map for the standard shader. So let's do the moon. I'm going to do this in a slightly different way as sake of example. If I go to the moon, let's say I want to use a material that's already been created. So I'm going to go ahead and grab one of these. I'll grab the Earth map and drag and drop that onto the moon, or I can drag and drop it right into the inspector. That'll apply that Earth material to that game object. If I go ahead and tap F, you can zoom in and you can see, yep, I've got the Earth, and then I've got kind of my baby Earth here. And now I want to modify that material. I want to make it the moon. So I'm going to go ahead and grab the moon map texture and drag and drop it, right onto this spot. Or, once again, it's got that little dot. So you can also click here and it'll bring up all the possible things in my project that would work with that. So you can see these are all the textures, and of course the moon map is selected. Now what this did is it actually modified the material. So you can see that since the same material is attached to both the moon and the Earth, now I've got two moons. I've got a big moon and a baby moon. So this isn't really what I wanted to do. So I'm going to go ahead and undo that last modification to bring it back to the Earth. So really, of course, I need to make a new material for the moon. You can share materials across game objects. Maybe you've got a bunch of cars in your game and you want them all to have the same material. But just realize if you modify, a material that's attached to multiple game objects, it's going to modify it to all the game objects that use that material. So I'm going to create a new material. I'm going to do this in a slightly different way. Over here in the projects tab, I can go to the materials folder, and I'm going to go ahead and select create, and material is actually one of the options. So let me go ahead and select material. Now the reason I selected the folder first is when you create things, it'll put it in the folder that's selected. If I wouldn't have done that, it would have put it at the top level, which really isn't a problem. I would just have to then drag it into the materials folder to keep my project organized. And I'm going to go ahead and rename this moon material. You can see, I've got the material selected, so the inspector is all about the material, the shader and then its settings. I'll go ahead and click the little selection on that top map and select the moon. And then, now I can just basically drag and drop that material onto the moon, and it will change. So now we've got, the Earth and the moon, and if I pan over, we've got the sun. So they've all got their respective materials. Of course, if I hit play, you can see that my solar system model or simulation is starting to look a lot better. One of the problems, of course, is the sun really looks kind of doesn't look like it's emitting light. One thing I actually have here is I actually have a directional light in this scene that I got when the scene first started. Let me go ahead and delete that. Eventually we'll change the lighting here. But the directional light really doesn't make sense because it's shining kind of down at the sun. So I'm going to go ahead and delete that. On the Mac it's Command Delete. In your hierarchy on Windows, I believe it's Control Delete. So let me delete that. You can see the lighting changed dramatically in our world, and we'll fix that in the next lesson. But for now, let's make the sun look like it's kind of emitting some light. So let me go back to the sun, go down to the material component, and one of the settings is actually the emission setting here. And right now it's at 0. So let me just go ahead and play with this. I can move just off of that and click and drag. And you can see as I move it up, it starts to kind of emit light. So we can do that by dragging, or we can, of course, set it numerically. So I'll set it just to 0.5 for purposes of example. The other thing that we can do is we can actually set a map for emission. So, I don't really have a separate map here. So for this purpose of example, I'm going to go ahead and take the Uranus map and attach it as my emission, or maybe the Venus map. And you can see that, it essentially is kind of layering. Let me hit F to move back to it. It's sort of layering that texture on top of the other texture, and it's sort of emitting the content of that texture out. So it looks kind of like a fiery surface now. I could actually even change the color of the emission and kind of see how that plays out. So maybe if I select sort of a yellow color, it's going to really look like a kind of burning sun surface. So the last thing that I want to do is I want my system, my solar system, to look like it's in space. So we've got this kind of generic horizon effect here that's sort of the default in Unity. So I want to change that, and really I do that through another type of material called a skybox. So let me go to the material folder again and go ahead and create a new material, and I'm going to call this my space skybox material. So I'm going to actually change the shader here. So right now it's the standard shader. Let me go down. You can see there's many different shader types. One of the types is skybox. I'm going to go ahead and pick the 6-sided skybox. And we see the various properties of the shader change down below. For the 6-sided, we've got 6 textures that we can drag in here. Essentially, if you look, if you're in a room and you look around, you've got basically a wall in front of you, a wall behind you, to the left, to the right, up and down. So you basically can create a texture for the entire sort of box that you're sitting in. Since we're in space, I've got a space texture here. Let me go ahead and just hit select and pick space, and you can kind of see down here in the preview that's one side of the box. Ultimately, I could have different pictures for different boxes of space, but I'm going to use the same one since it's essentially black with some stars, and go ahead and drag it into all 6 of those positions. So I've got my space skybox material set. So now I need to actually apply it to my world. And they actually changed this a little bit with Unity 5. The way you do it now is you go under Window and go down to the lighting option under Window. and this will bring up the lighting panel, and you want to be in the scene view, and you can see right here is where we can select the skybox. So right now it's the default skybox. This is just built into Unity. I want to change this to my space material skybox. Oops, let me go ahead and bring that window back. And I'll go ahead and use the little selection thing to do that. And go ahead and pick the space skybox. And you can see immediately now we are in outer space. Let me go ahead and hit play. And our scene is looking a lot better. Our sun is actually sort of emitting light. You can see the Earth and the moon are very, very dark since we got rid of that default light. But we'll fix that once again in the next section. In the next video, we'll further enhance the look of our solar system through the use of lighting. In this video, we'll discuss the goals of lighting, the different types of lights and their purposes, and then add some light to our world. The goals of lighting include illumination, modeling, focus, and a tool to create a visual style. Let's talk a bit more about the first three goals. Without illumination, we would not be able to see anything in our game world. With illumination, we're able to see that there are game objects within our scene, but illumination alone often is not enough. With the proper type of lighting, we can use lights for modeling. That is, we can reveal the structural and dimensional qualities of our game objects. We can also use lights to reveal spatial relationships between models and help establish the time of day. And lastly, with lights we can create contrast within the scene. That is, create areas of dark and light. This can be used to help direct and focus the player's attention. This table summarizes the types of basic lights we have in Unity and their primary purpose. You can see ambient light. The primary purpose is for illumination. There's directional light, which is much like sunlight. It's rays of lights from a very far distance away. Of course, this could be used for illumination and modeling. We can use it to establish, for example, the time of day, depending on the direction of that directional light. And then there's point lights. Point lights are pretty much like a light bulb in the environment. Of course, they can create illumination as well as modeling. They could be used perhaps to establish things that are, close to the light versus things that are farther away from the light. Of course, they would be darker if they're farther away. And then there's a spotlight. A spotlight is like a flashlight, shine from a certain point in space outward in a certain direction. This is a great way to both create modeling and focus. Much like in a theatrical performance, we put a spotlight on the main actors performing at that one time. There are a few things to realize with real-time lights in game engines such as Unity. The first off is that lights have no geometry. We see the result of the light, but we don't see the light itself. If you want to see a light, you'd have to have a 3D model of the light and then put the real-time light inside of it to essentially turn it on. Lights are also very processor intensive. The more lights that we have, the more it will slow down the performance of our games. So we have to be frugal in the number of lights that we actually use within our games, and often maybe use tricks to create the lighting effects that we want. With lights, there are also a lot of special effects that we can do. We can create shadows. We can create other sort of visual effects. These are also processor intensive, so we also need to be judicious in how we use these special effects. Our objective in this video will be to add some ambient lights to our solar system to increase the light everywhere, and then add a light within the sun so it looks like it's emitting light out toward the planets. Okay, we're going to adjust the lighting in our scene. As you can see, we've got the sun, and it looks like it's emitting light, but it really is not emitting light. It's just a visual effect. The emission material, the emission property of the material, lights it up, lights the game object itself up, but it doesn't, make light on the Earth or on the moon. And everything is just really dark. So the first thing that we want to do is just add some ambient light to our world. The same place that we set the skybox under window lighting is where we can play with the ambient light in the world. So here you can see it has an ambient source set at skybox. Let me go ahead and change this to color. And now the ambient color you can see is black and the ambient intensity is 1. Let me go ahead and click the color. It'll bring up the color selection tool. And I can select different colors, and as I'm moving around, you can kind of notice that the entire scene gets brighter as I use brighter colors and takes on the color tonality of whatever color that I'm got selected. So for sake of example, let me go all the way to the right hand side and kind of pick a medium gray color. So we've got a little bit more ambient light, just kind of lights everything in the world. If I hit play now, we can actually see the Earth and see the moon. But once again, our sun is not, putting light out into the world, so we can't get the the light side and the dark side of the moon yet. So let's go ahead and create a light in our world. We can create lights in a number of different ways, but just like we created the spheres in the beginning, we can go up to Game Object, Light, and you can see all the different types of lights that we talked about and a few other more advanced lighting options. We're going to create a point light because really the sun is kind of like a light bulb that's shining out in all directions from a single location. So let's go ahead and create that point light. Lights are just like any other game object in that they exist in the world and they've got to transform, but they aren't visible themselves. You just see the result of the light. So just like the camera, we get a little gizmo here to reflect that there is a light in the scene. If I go to the top-down view, you can see as I move this light around, bring it closer, to the moon and the Earth, we can kind of see the results of that light. I'm going to go ahead and rename this Sunlight. And really, this is going to be inside of the sun, putting light out into the world. So it probably makes the most sense for it to be a child of the sun. So I'm going to go ahead and drag and drop it right on the sun. You can see its location is 1 meter, off of the origin. Of course, the sun is at 0, 0, 0. So I really want to make this at 0, 0, 0. So it's right inside of the sun. So we've got the sun as a child, so or the sunlight as a child, so if we ever move the sun, the light will come with it, of course. I'll go ahead and undo to snap it back to the origin. And we've got it positioned right there in the middle of the sun. The next thing we need to do is maybe play a little bit with some of the lighting properties of the light component. So you can see this game object really is just a regular game object that has a light component. So in essence, we could actually just add a light component right to the sun game object if we wanted to. But for purpose of example, we'll keep it as a separate game object as a child of the sun. So one of the things that we could do is we can adjust the range. So the range right now is 10, which basically means 10 meters. If I zoom out in my scene, it actually kind of visually represents the range that light is casting. So if I bring the range down, you can see it's coming down. And if I go real small, it no longer hits the Earth. If I go larger, you can see in the game view that we actually kind of see the effect of the light hitting the moon and hitting the sun. The other thing we can do with light is we can change the color. So right now it's just a white light. If I click on this and let's say I want to make it kind of a yellow color, you can see the result of the light. It's fairly subtle, but you can see the results of that. If I go red, it's maybe a little more severe. You can see that it's a red light. I'm going to go ahead and kind of keep it as a white light for now. One other option that we can do is we can actually draw a halo. So if I check the halo option, you can actually see there's a halo effect created here. I think my camera is too close right now to actually see it in the game scene. So if I go back and move my camera away, you can see now that there's sort of that halo effect around the sun. If I play, we can kind of see the Earth kind of going in and out of that halo. That may or may not be the effect that we want, but it's kind of a fun little effect, so I just wanted to demo that to you. Let me undo to move my camera back to its location, and I'll go ahead and keep that halo off. But that's something that you could always play with. Now we have a little bit of lighting in our world, and if we hit play, you can see as the Earth moves around, we're kind of seeing the dark side as it comes around. But on the other side, the sun is actually emitting light and lighting up as those surfaces face that point light. So what's next? We've been focusing on the visuals. In the next video, we'll focus on the auditory experience in our project. In this video, we'll briefly discuss how audio works in Unity and then add audio to our solar system. The basic concept of audio in Unity is fairly simple. You have an audio listener component, which, like a microphone, picks up audio from certain locations in the environment. The audio listener component is often attached to the camera. You only have one audio listener component turned on at any one time in your Unity scene. You also have audio source components attached to game objects within the scene. The audio listener picks up the sound emitted from the audio sources. Unity supports 3D positional sound. That is, the audio listener will pick up the audio from the audio source based on its relative position in 3D space. So if the audio source is to the right of the audio listener, it'll come out of the right speaker. If it's to the left, it'll come out of the left speaker. If it's close to the audio listener, it'll be loud. If it's farther away, it'll be softer. So our objectives for this video will be to add some sound to the sun and add some sound to the Earth to create a more rich auditory experience in our solar system. So let's go ahead and look at the main camera. If I select it over here in the inspector, you can see that there's actually an audio listener component attached to that. The audio listener is a pretty simple component. There are no properties. We could just turn it on or off in essence. So we've got the audio listener on the camera, and let's go ahead and add a sound for the sun. So if I go ahead and look at the sounds folder, you can see that I've got a burning sound. So let me select that, and over here in the inspector we can actually preview it. So it basically just sounds like something burning. Once again, there's many different ways of doing things. I always like shortcuts, so we can basically take that burning sound, drag and drop it right onto the sun game object. And if I go back to the sun, we can see now it's got an audio source attached to it. The audio source component actually has several properties, one of those being loop. So we want this sound to continually play. If we don't select loop, it'll basically play the few seconds of the sound clip and then end. But we want it to continually play, so I'm going to go ahead and check that. So let's go ahead and play. So as we're playing, we can adjust things. So another property is the volume. So the volume is set at 1. Let me pull it down to like 0.3 or something like that. So that's like a 30%, 0.3, and we could just barely hear the sun burning, or maybe we can increase that a little bit to 0.5, for example. Now once again, I'm in play mode, so any change that I make is not going to stick. It's just for essentially testing purposes and trying to figure out what I actually want. So now that I have what I want, I can stop it, go in here for volume, and change this to 0.5. So let's also add a sound to the Earth. For purpose of example, I can select the Earth, I can go to component, move down to audio, and add an audio source. This is the sort of manual way of doing it. Dragging and dropping a sound right on a game object is probably the quicker way. But by doing that, you can see I've added the audio source component. Right now there is no audio clip set, so I need to select my audio clip. So I can click the little selection target thing here, and this will show all of the possible audio clips that we've got. I'm going to go ahead and select the drone hum sound effect and set that as the audio clip for this audio source. And let's go ahead and hit play. So you could, somewhat tell as the Earth gets closer, the sound gets louder, and as it gets farther away, it gets quieter, since the Earth is actually moving closer and farther from our camera. The other thing I forgot to do is turn on looping, so you can see that the sound stopped. So let's go ahead and stop that, turn on looping. And let's scroll down a little bit. There's 3D sound settings down here. Let me go ahead and press play, and we can just play with some of these things as we play and kind of get what we want once again. So one thing is they have a Doppler level, which basically kind of creates a Doppler effect on the sound as it's moving. Right now that's set at 1. I could turn off the Doppler effect if I want to. The next thing is a volume roll-off, and it's sort of visually represented here. The minimum distance is 1 meter, so if I'm closer than 1 meter, I'm not going to hear the sound. The maximum distance is 500. So let me adjust this a bit. Let me go down to, let's say, 5. And now our little diagram here really kind of shows what's going on, and it shows the sort of respective volume of the sound as it gets closer to the audio listener and as it goes farther away. I'm sorry, I misspoke earlier. The 1 meter, it basically peaks out. So from 1 down to 0 would be maximum volume. So if I adjust this up, you're going to see maximum volume, as it gets, a little bit farther away. So let's go back down to 1. And after 5 meters, it'll basically drop down to no sound. So maybe something like 10 meters is a pretty good setting. Now this graph down here, you can actually drag and drop and tweak however you want it to create a sort of custom roll-off. But once again, I'm in play mode, so everything I'm doing is not going to stick. So if I stop, I can then go back and play with this and make it stick. So once again, I could turn off the Doppler. I can set the maximum distance to 10 meters rather than 500 meters. So one thing that we can do, just as sake of example, is go ahead and let's press play again. And let's go back to the main camera. And with the audio listener component, if I just turn it off, you can see, I basically turned off the sound. The sound still exists, it's still playing, I'm just not listening to it. It's sort of the tree falling in the forest concept. If I turn the audio listener back on, once again I'm listening. So this I'm doing in the editor. Obviously in an actual game we could programmatically control the audio listener to turn on or turn off, or switch from one audio listener to another if we had, for say, multiple cameras, like in a racing game where maybe we've got a camera in the car and a chase camera and that sort of thing. So in any case, we've got audio in our game now, and our overall simulation is really starting to come together. So what's next? In the next video, we'll discuss a bit more about the camera game object. In this video, we'll get a better understanding of the different types of cameras and their uses in Unity. In some regards, a 3D camera can be viewed conceptually like a real camera. To set up your shot, you need to position the camera properly and rotate it so it's pointing at what you want to see. But the differences really stop there. With the traditional lens camera, light passes through the lens, projected onto a flat piece of photosensitive film or CCDs. You can focus the lens for different depth of field effects. You can also change out the lens for different effects like telephoto, wide angle, fisheye, and so forth. In a game engine, the camera really is just a projection of the 3D geometry onto a 2D plane of the display. You can simulate lens effects like focus, lens flare, and fisheye, but they are processor intensive to do so. There's two different types of 3D projections you can create within your game: perspective and orthographic. The perspective projection is most like a real camera, or really how we see the world. This is most commonly used in first-person and third-person games. Objects that are closer to the camera are larger than the same sized objects that are farther away from the camera. Orthographic projections do not really exist in the real world. The computer maintains the same relative size of the object no matter how close or how far away it is from the camera. Common uses of orthographic cameras include top-down or isometric views on games. The view frustum determines what is rendered in the display. The perspective camera has a pyramid view frustum with a narrow field of view close to the camera and a wider field of view farther away from the camera. As an object moves closer to the camera, it'll appear larger or closer. The camera renders everything between the near clipping plane and the far clipping plane. If objects move closer than the near clipping plane, they are not rendered. If objects move farther away than the far clipping plane, similarly, they're not rendered. The orthographic camera has a rectangular view frustum with a constant field of view or orthographic size throughout. Objects, no matter where they are in front of the camera, will appear the same size relative to other objects. The same concepts apply in terms of near and far clipping planes with the orthographic cameras as they do with the perspective camera. Our objectives in our project for this video are to understand some of the camera settings, make the perspective camera controllable, and add a mini-map through the use of a second orthographic camera. So the first thing I want to do is just play around with my main camera a little bit to further demonstrate some of the concepts we just spoke about. So let me click on my main camera. It is a perspective camera, a perspective projection. And actually, as we look out in our scene, you can actually see that view frustum sort of visually represented there. As I'm playing with things like field of view here, the default is 60. Let me just make that wider. You can see how it's affecting the game world. It's kind of like simulating like a fisheye sort of view. And then if I go the other direction, it's like it's zooming in, but really it's not moving the camera. It's just changing the field of view, changing that sort of projection. So we'll go back to 60, which is the default. The other thing to look at is the clipping plane. So the clipping plane is actually set here. Basically, this is saying at 0.3 meters, things will no longer be rendered, and at 1,000 meters, things will go off the far clipping plane. 1,000 is pretty far. If I bring this back, let's say to something like 4, you can see that the clipping plane is just beyond the Earth now. And if I actually play this, just beyond the sun, I believe the Earth will actually disappear. You can see it disappear there, and then it'll reappear on the other side. So that's going, sort of out of the far clipping plane. And depending on the location of my camera, if it's too close, the object may come on the inside of the near clipping plane and then essentially kind of cut through the camera. And I'm sure everyone has seen that in games today. So 4 is probably too small. Let me go ahead and set this at something like 20 meters. So everything will be likely rendered in my display here. But that's something that you can always adjust to optimize your project. If it's rendering too big of a view frustum with objects way out in the distance, it may affect performance. So by making that a little bit tighter, things will play back better depending on the platform that we're playing on. So really, we didn't really change much there. I just wanted to kind of show some of those concepts related to the perspective projection, the field of view in the near and far clipping plane. So the next thing I want to do is actually create another camera in my world. So I'm going to go ahead and go up to Game Object and create a camera. And this camera just got created, kind of out in my world. You can see that my game view actually changed because it sort of switched to that new camera that was just created, which is fine for purpose of example. My camera isn't really where I want to have it. So one thing I could do is actually go to this main camera and see where that is. And under Game Object, I can select Align View to Selected. So what that's going to do is align my scene view to the selected game object, which in this case is the camera. So this will show, in essence, what we were seeing out of the main camera previous. So now that we have that, let me go to the new camera and select it, and then go to Game Object, Align with View. So this is going to move the game object to be aligned with the view. So in essence, it's going to put this camera really right on top of the previous camera, so they're both really right on top of the same spot. And let me go ahead and rename this camera to, I'm going to call it my mini map camera, because I'm going to use this camera to create a mini map. And, let's go ahead and look at some of the properties here. The first thing is that it also has an audio listener, and really you can only have one audio listener turned on at a time in Unity. And if you have multiple, it will throw a warning message, and Unity will sort of pick one of those audio listeners, which may not be the one you want. So I'm going to go ahead and turn off this audio listener. I could even just remove the audio listener component, but I'll just turn it off. That's fine. The other thing I want to do is change the projection. So rather than the perspective, let's go and pick orthographic. And the orthographic projection, you can see my game view just changed. If I play, for purposes of example, you can see if I go in a top-down view over here, let me move to the sun by hitting F. But you can see the Earth is, of course, rotating around the sun, and the moon rotating around it. But down here in the game view, since it's orthographic, the size of the Earth and the size of the moon do not change as it's moving around the sun. So that's the big difference. The same relative size of the objects is maintained consistent with the orthographic projection. So let me go back to the mini map here. And really what I want to do is I don't want to have the same projection, or the same view as the main camera. I actually want to have a top-down view on my world. So, over here in my scene, I've been, somewhat placing, I'm in the top view. I can switch, in and out of it, and I can zoom in and zoom out to kind of get the orientation that I want. I've got my mini-map camera selected, and once again, under Game Object, I could say Align with View. And now, if I press play, you can see I've got a top-down view on my game world. The Earth is rotating around the sun there. So that's what I wanted. But in reality, I want to have both of my cameras playing at the same time. And in fact, they're just sort of layered on top of each other right now, so I'm not really seeing the main camera because the mini-map camera is overlaying that. And that's really set here as the depth. So my depth of this camera is 0. If I go back to the main camera, it's -1. So if I change this, and let's make this a depth of 1, you can see now it just switched back to the perspective camera, because the higher the depth number, that's what's going to be rendered on top. But we can leave this at -1. And go back to the mini-map camera, which is the depth of 0, because really we want these both to be rendered at the same time. So the way I'm going to do that is I'm going to modify this view rect property. So right now the width and the height is 1, which is 100% of the screen. I'm going to change this to 0.25 and 0.25. And you can see down in the corner now of my game view, I can see that mini-map camera, and and then the main area is the main camera. So if I press play now, everything is essentially rendered. But it looks a little funny because I've got the skybox down here, or it doesn't look funny. It just is hard to see. So let me modify one other property. So you can see where it says clear flags here, and it says skybox. That's basically saying it's going to render the skybox. Let me switch this to solid color, and now it's on a blue background, and I could change that color, of course, by clicking the background and make it whatever color I want. I'll keep it as kind of a dark blue. And now when I press play, we can see the sun, and we can see the Earth rotating. It's a little bit hard to see the Earth. Part of that is the size of my projection maybe is a little bit high. In essence, it's kind of like being zoomed out. So let me change the size, make it a little bit smaller, maybe make it 3, and hit play again. And now it's a little bit easier to see the sun and the moon and the Earth. The last thing that I want to do is I want to make my camera controllable. Not the mini-map camera, but actually the main camera. In essence, what I want to be able to do is I want to be able to click on the various planetary bodies, the game objects, and have the camera look at them. So of course we could do this with scripting. Anything that's interactive, we often do with scripting. And we've got two scripts to do this. We've got a change look at and a look at target. So the look at target is a script that's meant to be placed on the main camera. So let me go ahead and drag and drop that onto the main camera. So now it has the look at target script or component attached to the main camera. And the change look at target is the script that we place on all the game objects that we want to be able to click on. So what this does is it essentially responds to a mouse event, a mouse down event on the game object, and resets the target of that other script. So let's go ahead and put the change look at script on the sun, put it on the Earth, and even put it on the moon. Okay, so if I go back and look at each of those game objects, it should now have that change look at target script or component attached. So if I go ahead and play again, if I click on the Earth, now the main camera, if I zoom out here a little bit and select the main camera, you can see the main camera is stationary, but it's rotating, so it's constantly looking at whichever game objects I've last clicked on. So if I click on the sun as it comes by here, now I'm looking at the sun. It might be a little bit hard to do, but I can even click on the moon as it comes by here and gets a little bit bigger. There's the Earth, and there's the moon. So now I'm targeting the moon as it's coming around. And since I've got two cameras, I could even click on the mini-map. So if I click on the sun on the mini-map, that's a quick way to kind of reset that main camera to be targeting on the sun once again. And I can click on the Earth. It's probably a little hard to click on the moon since it's so small within the mini-map. So anyways, we've played a little bit with the perspective camera. We've added an orthographic camera and essentially made that our mini-map. And we've made the main camera controllable. In the next video, we'll discuss how to build and deploy our Unity projects. Well, we're almost to the end of our project. In this video, we'll discuss how to build and deploy our Unity projects. Our objectives will be to save our Unity project, set the build platform, adjust the build settings, and build the project so we're ready to deploy. Now, to save our Unity project, we really are talking about saving the scene because the project files just exist on disk all along. The thing that we've been changing is actually our scene. And you can tell our scene hasn't been saved because there are little asterisks in the hierarchy after the scene name. You can also see on the Mac there's a little dot in the corner up here to represent that the file is unsaved. Now to save our scene, of course we could go under the File menu and select Save Scene. Notice there's also a keyboard shortcut or a hotkey that we can use to save the scene. On the Mac, that's the Command S key. On Windows, that would be Control S. So let me go ahead and save the scene. You can see that the little asterisk went away, so my scene is now saved. As I'm working in Unity, I try to habitually save every couple minutes, just hitting Command S here on the Mac. Just in case there's a computer freeze or computer crash, I won't lose a lot of work. Now, like I said, my Unity project is really composed of all of these files and folders that we see here in the project panel. But there's actually more than that. Let me go ahead and minimize Unity here. And I've got my Solar System project folder on the desktop where I created it originally. And if I go ahead and double click on that folder, you'll see that it is made up of various subfolders. So if I ever want to back up my Unity project or give my entire project to somebody else that has Unity, I would literally copy this entire folder and send it to them, or zip it up and send it to them. So let me go ahead and open it again. Within this folder, you see various subfolders, the first being the Assets subfolder. And if I open this up, you can see that these are all of the files and folders that we see back in Unity. So you can see the materials, scenes, scripts, sounds, textures. If I open up textures, you can see all of those JPEG images of the planet textures. So once again, back in Unity, that's exactly what we're seeing here. So that asset subfolder is a direct representation, a one-to-one representation of what you see in the project panel here. And if we rename a file here in our file system, it will be renamed back in Unity. If we move it around in the file system, it'll be moved back in Unity, and vice versa. I do recommend any naming, renaming, and moving is actually done in Unity, so Unity can maintain all of the link relationships between those files. If you move them in the file system, Unity may lose a link to a texture, for example, and then your game object wouldn't map to the proper texture. So that's the assets folder. And that's basically what you manage in the projects panel in Unity. There's also a library folder. The library folder is what Unity manages. Generally, you do not ever need to go into this folder. You should actually not go in, make any changes in this folder. Unity manages this. It's basically the components of the Unity engine that your game is using. There's also a project settings folder. This contains various settings related to how you have your editor and your project set up. And there's a temp folder. The temp folder is created when you have your project open in Unity. So for example, if I go back into Unity and I quit Unity, you can see that temp folder goes away. So generally, I recommend before you deliver an entire project folder to somebody, you should quit Unity so that temp folder goes away, before backing this up or before copying it, uploading it, that sort of thing. So let me go back into Unity and reopen my project. So once again, we typically don't deliver our entire project folder unless we're giving it to another game developer. So what we want to do is we want to build our project for a given platform. So under the File menu, you can see there is a Build Settings option. Let me go ahead and select that. And this brings up the Build Settings window. There's a number of things to talk about here. The first thing that we see is Scenes in Build. This is where we can specify what scenes or what levels we want to have in the build that we're making. So currently in the solar system project, we only have one scene, the solar system scene. So if I click the Add Open Scenes button, this will add that one scene. If we actually had multiple scenes here, you would just grab them and drag them over here and drop them. Of course, I've already got that one, so it doesn't add a new one. Then down below, we have the various platforms that we can build for. So right now, you can see the little Unity icon on this first row here for PC, Mac, and standalone. That means that's what is targeted currently in our platform build. And there's various other options for this platform. You can see them here. So you can see the target platform is set at Mac OS X. We can switch that to Windows, of course. And there's various other options you can see below. And there's even further options. So if I click on Player Setting, this will show various player settings for the platform. So let me click on Player Settings. Over here in the inspector, we can specify a company name. Mine is set at Michigan State University. You can set a product name. I've already got mine set to Solar System. And you could, of course, edit these and change them as you wish. Down below here, we see the various platforms that we can build for. So when I installed Unity, I installed Mac Windows build, which is this first option, and the WebGL settings. So under the Mac Windows settings, you can see there's various things like setting the resolution of the build and how it handles things like full screen. You can specify an icon. So when it builds the application, it would have a custom icon at various sizes. You can specify a splash image. So when the game first loads, it would show, maybe your company logo, something like that. And then there's various other settings. Some of these are fairly technically oriented. You might need to dive into the documentation to modify these. Generally, the defaults are probably okay for most applications. So let me go ahead and actually do a build for Mac OS X. So I'm going to go ahead and click the build button back here. I didn't really change anything, by the way. So let me go ahead and click build. And generally, I like to create a builds folder within my project folder. So here in the file system, I'm already looking at my solar system project folder. And I'm going to create a new folder. I'll call it builds. And then I'll navigate into that new folder. And I'm going to create another new folder. And I'm going to call this Mac OS. And then I will save this as Solar System and say save. And Unity will go through the process of building my Mac OS X build of my Solar System project. Depending on the complexity of your project, this could take some time, and it also varies depending on the platform you've chosen. So here on the Mac, it actually builds the Mac OS pretty quickly. And here we go. I've got my Solar System application here, which is within the Builds folder. So if I go back to my project, you can see Builds, Mac OS, and Solar System. So if I go ahead and just double click on this, it will open just like a normal application. It comes up with a configuration tool. This is a default in the player settings. You can change it to not open this if you didn't want this opened. And I could choose if I want to run full screen or in a window and specify the resolution here. I'm going to go ahead and just say play with the defaults. And the application opens here. And you can see I've got a fully functioning solar system. So I can click on the Earth, on the Moon, can click back on the Sun through the picture-in-picture. Up here, I've got a menu bar, and I can go ahead and quit the solar system. Okay, let's go back into Unity. I'm going to go ahead and change my target platform to Windows now. So since I installed the Windows component when I installed Unity here on the Mac, I'm able to target Windows. If you're on a Windows machine, you can target, of course, Windows, or you can target Mac if you installed the Mac build component. So I changed the target platform, and I'm just going to go ahead and click Build. Once again, I want to build this within the Builds folder. I'm going to create a new folder called Windows. And then within that Windows folder, I'll name it Solar System, just like I did on the Mac. And save. Now Unity will go through the process of building the Windows version of the game. Okay, the build is done. You can see it's a little bit different than the Mac build. The Mac build was a single file called Solar System. Here we've got solarsystem.exe, and then we've got a couple other files and folders. So if I were to deliver this on Windows, I would have to deliver the complete contents of the Windows folder here. So the exe alone will not be the complete game. The exe actually accesses various files that are in the data folder. And since I'm on a Mac, I won't actually be able to run the Windows version here, but I can actually build it, and then I could deliver it to a Windows computer for playback. So let's go back to Unity once again. And now let's target the WebGL platform. So for purposes of this project, you will actually build a WebGL version of your game. So let's switch to the WebGL platform. So we select it, then we click the Switch Platform button. And this will go through a process of re-importing the assets. Depending on the complexity of your project, this could take some time the first time you do it. Because this is a pretty simple project, it actually happens pretty quickly. And let me go ahead and click on Player Settings once again. So it's the exact same panel. Notice there's just a sort of a switch here between PC, Mac, and Linux standalone and WebGL. So under WebGL, we have a lot of the similar options that we saw for PC and Mac. So we have resolution. Here we can set a default number of pixels and width and height for our playback. So I think by default it's generally 800 by 600, but of course you can change this, so I can change it to 1024 by 768 as I had it. You can pick a WebGL template. Unity only provides two pretty basic templates, the default template and a minimal template. I'll just pick the minimal one for sake of example. And then some of these other options don't really apply, so there's no really icon for a web distribution. You can create splash images, however. If you're using the free version of Unity, they force you to have the Unity logo at the beginning. If you have a pro or paying version of Unity, you can turn that off. Once again, there's various other settings that you probably won't mess with. And then the publishing settings. Once again, you probably won't mess with these. Sometimes if I have a more complicated project, I have noticed that I have to go in sometimes and increase the WebGL memory size. So if you are playing back your game in the browser and you get an out of memory error, this is how you would resolve that. So a lot of times I'll just double this and build something with 512 memory size. So let's go ahead and click Build. And as before, I'm going to build this in the builds folder. I'll go ahead and create a new folder called WebGL. And then I'll save this as Solar System, just like we did before. Go ahead and click Save. And Unity will start building for the WebGL player. Now the WebGL builds typically take a little bit longer than the standalone builds. So I'll probably fast forward here until the build is complete. Okay, my build is complete. You can see within the WebGL folder, I now have a Solar System folder. And within that, I have two files. I've got an index.html and I have a build folder. So when I'm delivering for WebGL, I need to include the complete contents of this folder, just like with Windows. So the index.html is the web page that will be opened in a web browser, and this links into various files that are contained in that builds subfolder. Depending on the version of Unity that you're building with, there may be additional files and folders in here, and you should always include all of them when you're uploading to your web service. Now, if I actually want to test here locally, there is one gotcha. Some of the browsers, or many of the browsers, don't allow you to open local WebGL content. One browser that does is Firefox. So I'm going to test within Firefox. So if I right-click on my index.html, I can then open with Firefox. Now, if you don't have Firefox installed, I do recommend that you do install it. It is free to install from Mozilla, and it's a nice browser for testing WebGL content locally. So just like we saw with the Mac player, our Solar System opens here, and I am in the web browser. So you can see that's in the browser window, and I can click and navigate around as we've seen before. And this is just a standard web page. So I can actually open the HTML in any web editor or any text editor tool if I know HTML. So let me go ahead and right click on this and open this in Adobe Dreamweaver, which is a popular web authoring tool that you may have as part of the Adobe Creative Suite. And this opens up in the editor, and it seems relatively blank. But if I actually just start typing down here, I can say something like created by Brian Wynn, and I can type any other sort of message that I want here. If I save this and go ahead and reopen that in Firefox, you can see the created by Brian Wynn is there at the bottom. Like I said, you can open this in really any sort of text editor. So let me just open this in another text editor that I have here called Sublime Text. And you can see this is just a simple HTML file if you've ever seen HTML before. And the game is actually embedded through this div tag and some JavaScript up at the top. So anything outside of that div tag is just standard HTML. I can just edit it right there, and it won't affect the playback of the game, as long as I don't get rid of this div statement and I don't get rid of, the JavaScript code at the top. So let me close out of my windows here and get back just to the Solar System project. So you can see that we've built now for Mac OS, we built for Windows, and we built for WebGL. So depending on what platform you're trying to deliver, you would deliver the respective folder or the respective files.
In the last video, we'll discuss how to finish up your project and submit it for peer review. In this video, we'll finish up the Week 1 project. Our objectives will be to polish the project, adding a few features of our own design, do the final build, compress the project, and then upload it to the peer review system.
To finish up this project, I recommend that you go to the assignment and read all of the steps and follow them closely. Most notably, you'll be creating a more elaborate solar system with additional planetary bodies. This will help you reinforce the concepts we've been learning related to developing games in Unity. Once you get the project finished up, continue to test it in the editor, continue to save, continue to follow best practices of naming your game assets, organizing them into logical folders, naming your game objects logically, and keeping the hierarchy organized. Then go ahead and build.
So once again, you can follow the steps that we've gone over in the previous video by going to Build Settings. For purposes of the assignment, you'll just be creating a WebGL build. You don't have to make builds for other platforms. Once again, include all of the scenes that your game includes. It might, for this assignment, just be the first scene or the solar system scene. And then go ahead and build. And if you built previously, you can just replace what you had built previously. So right now I'm in my solar system project in the builds folder, in the WebGL folder, and I'll be building the solar system project. So I'll go ahead and replace that. And let the build complete. And once the build is done, go ahead and close out of Unity. Once again, this will get rid of that temp folder that's within the projects folder. So the temp folder is now removed. If I look at my builds folder, of course, I've got the WebGL folder here. And within that, I've got the solar system folder, which contains all of the elements that I need to make my WebGL build work, including the index.html. Now you can go ahead and follow the instructions in the assignment for doing any edits to that index.html file. Of course, we don't need the Mac and Windows build. Those might be out of date at this point. And since we don't need to submit those, we might as well just go in and delete those. So I'll do that right now. And of course, we want to test our final build. So once again, you can right-click on that and open it in a browser like Firefox, which allows us to test WebGL builds locally. Once again, review the instructions about testing WebGL builds locally, because many of the browsers don't actually allow that without some modifications to allow the browser to do that. And the last thing that we're going to do for this assignment is we're going to compress the entire project folder. In future assignments, you'll likely just submit your build. But for this assignment, we want you to include your entire project folder so the actual project can be reviewed in Unity. So once again, I've got everything in this projects folder. Let me just close it up here. And we want to zip compress it for delivery to the review system. So here on the Mac, the way I would do that is I would just go to that project folder and right-click on it and go down to compress. So using the compress option, that will go through the process of creating a zip archive of that project. And I've got that file right here. If you are on a Windows system, it's a very similar process. Just go to your project folder, right-click on it, move down to Send to Compressed Zipped Folder. And this will do the same thing. It'll create a zip archive of that folder, which we can then submit. So once again, follow the assignment closely. Follow all the instructions for naming of files and that sort of thing before uploading to the review system.
If you haven't already done so, follow the steps to submit your project to the peer review system and go ahead and do your peer reviews of other learners' projects. Good job! You've reached the end of week 2 of Intro to Game Development. Unity is a complex game development environment, and like most complex things, it takes some practice to become proficient in using it. Next week, we'll expand on the things that we've learned and work together to build a fully functional 3D game in Unity. Take care and come back soon. In this project, we'll build on the concepts and skills we learned in the last project and apply them toward building an actual game called Roller Madness. This ball rolling game will demonstrate many things that we have not yet discussed in Unity 3D as well. The concepts we'll learn include getting assets into Unity, including standard assets and asset packages, additional Unity editor features not covered in Project 1. We'll continue to discuss best practices in regards to project organization. We'll also introduce the use of 3D physics, something that many games employ. We'll integrate some basic user interface to display score and other messages to the player. We'll create some visual effects through the use of trail renderers, particle systems, and animation. And we'll build several gameplay systems such as player control, pickups, enemies, and scoring.
In the end, we'll have a playable game that can serve as the basis of a larger game project. Are we writing code, you might ask? Like the first project, we'll not actually be writing code in this project. We'll be using a package of pre-created scripts. For you programmers chomping at the bit to start writing code, never fear, we'll get into that in the next project. If you are a bit nervous about programming, you can relax a bit longer. The good thing is that by the end of this project, you should know the Unity editor well enough that it should greatly help you once we do actually start programming. As I mentioned in Project 1, I encourage you to follow along in Unity as you watch the videos. Pick the technique that works best for you. And remember, you could always go back and rewatch videos, even from previous projects, if a concept has become hazy. In the next video, we'll get our Unity project set up and assets imported. In this video, we'll get started creating the Roller Madness project. Our objectives will be to download the assets, start a new Unity project, and import the assets. Okay, the first thing that you need to do is you need to download the project assets. I have the download right here. You can see it's a zip archive. So here on the Mac, I could just double click on that to expand it. And this will create the Roller Madness assets folder. Let me open that and explain what's in here. You can see there is a what's called a Unity package file. We'll explain this in a little more detail later. There's also a folder called audio, and within that folder we have a number of audio files, mostly .waves and a .ogg or a .ogg file. So let's go ahead and start Unity. And of course I'm going to start a new Unity project, so I'll go ahead and click the new option here. And I'm going to name my project Roller Madness. And you can pick the location that you want to save your project. I'll go ahead and save this on the desktop just for purposes of example. And of course this is going to be a 3D project, and I'll go ahead and click Create Project. Okay, I've got essentially a blank Unity project open now called Roller Madness. One thing we're going to do with this project that we didn't do with the first project is we're going to install some standard assets. Standard assets are assets that come with Unity 3D. You can use standard assets to speed up your development. So under the Assets menu in Unity, you can scroll down to where it says Import Package, and you can see there are various named packages here. So these are the standard assets that are installed with Unity. If you don't actually see these, you can go back to the Unity website and look for the standard asset package and download and install that for the respective version of Unity that you're using. So for today's project, I'm going to go ahead and import the characters package. So let me do that by just selecting it. It'll take a moment to download and install. You'll see a pop-up that looks like this, and it'll ask which of these assets you want to import, and you could go ahead and check or uncheck whatever you want to import. Right now everything is checked, and I'll just go ahead and click Import and import all of them. And this might take a few seconds to import. And once the character asset package is imported, you can see in the project now I have a folder called Standard Assets. If I open that up, you can see there's various subfolders. But I'm going to go ahead and select a few other packages to import. So under Assets, once again, I'll go and import the cross-platform input package and click Import for that. Notice here some of these are unchecked. The reason they're unchecked is because they're already installed. But if I scroll down, you can see there's a few things that didn't come down the first time. Let me go back to Assets and choose Import Package once again and choose the prototyping asset package. And once again, some things are unchecked because they're already brought down, but most of the things in the prototyping folder need to come down. So let me go ahead and click Import. And last but not least, let me go to Assets and choose Import and choose Utility. And for this one, notice that everything is already imported. It tells us that here, so we've already got the utility package imported into our project. Now, when we're importing standard assets, it's actually creating a copy of those standard assets into our project.
So now that these are in our project, we can actually change these standard assets, use them however we want, and it's not going to affect future projects that go ahead and import those standard packages in the future. Now, these standard asset packages are actually shipped with Unity. If you open the Unity folder on disk, you'll notice here on the Mac there's actually a standard assets folder, and within that you can see all of those Unity packages. So for example, here is the character package right here, the cross-platform input package, the prototyping package, and the utility package. So what these .unity packages are is they're a collection of assets that are all bundled together. So when we actually imported those, you can see, for example, in the case of utility, if I open the utility folder, it's got a bunch of scripts and subfolders and so forth. So in the project asset zip archive that we downloaded and expanded earlier, we actually have another Unity package. It's not a standard one, it's one that I have created for you. So let me minimize Unity here, and once again on the desktop I have the Roller Madness assets folder, and right here I've got this MSU GameScripts.unity package. So this is a custom Unity package that I've created for you, and I want to bring this into my project as well. There's a number of ways of doing this. On the Mac here I could just double click on this and it will import. If I go back to Unity, I can also go to the assets and choose import package and choose custom package. So let me go ahead and do it that way. And I want to navigate, in my case, to the desktop into that Roller Madness assets folder and choose the MSU GameScripts.unity package and say open. And this will be the exact same process that we saw before. In this case, it's going to bring in a scripts folder with a number of C# scripts. Let me go ahead and import that. So that brought in this scripts folder. Notice the scripts folder is outside of the standard assets folder because it was not a standard asset. And the last thing that I want in my project is those audio files that were part of the Roller Madness assets. So once again, back in my file system, we have this audio folder here with various files. So, these are not packaged together into one file like the MSU GameScripts.unity package was. These are actually each individual files. So I want to import all of these files. Actually, I want to import this entire folder into my Unity project. Now, one easy way to do this here on the Mac is you could actually select this folder and just drag and drop it, if you can position your windows properly, right into the Projects tab, let go of that, and it will go ahead and import that entire folder. So you can see here in my project, I have that entire folder called audio. If I open it, you can see those audio files. You can also, under assets, choose import new asset and then select those files and import them one at a time or multiple at a time through that mechanism as well. So now that I've got these imported, if I select any one of these audio files, for example, over here in the inspector, let me click on the inspector tab, you can see various details about the file. You can also see a preview here down at the bottom. If you don't see the preview, it might be minimized. So here it's minimized. I just need to go down and drag it up to be able to see that. And I can actually preview this here. And in these import settings, you can actually make changes to how the file is imported. So for example, I can choose Force to Mono and select that and then choose Apply. And notice what happens to the preview after I apply. I've now got a single track, so it merged those two tracks together to make a mono track. Now this did not actually change the file on disk. It just changed a cached version of the file within my project library folder. The nice thing about the import settings is you can change them as many times as you want. So for example, I could change the compression settings. I could, of course, undo that Force to Mono and then choose Apply and then get back to the stereo music. So now we have a project with various assets and we're ready to start building our game.
In the next video, we'll set up our game scene. In this video, we'll set up the foundation of the first level of our game. Our objectives will be to create the base level for our game, including a floor and various obstacles, and then set up the player. Along the way, we'll discuss prefabs, an important concept in Unity. In Roller Madness, we're going to use many of the prototyping standard assets. These are, of course, located in Standard Assets, Prototyping. These assets are basically geometric shapes that we can use to create a quick prototype of a game, or as they say in game design, we can white box the level. Typically, you would eventually replace the prototype assets with actual production game art, but for our purposes with this project, the prototype assets will be our production game art. So within this folder, you can see there's a prefabs folder that has several prefab objects, which we'll talk about in a moment, that make up these geometric shapes. So it's a little hard to see down here in the preview, but you can see there's a block prototype. 4x4x4 means 4 meters by 4 meters by 4 meters. If I just scroll down, you can see there's blocks and cubes. There's various floor assets. I'm going to use the floor prototype 64 meters by 1 by 64 and go ahead and drag that into my world. You can see right there, it's a fairly large game object now, right there in my world. And I'm going to go ahead and rename this just floor. And I want to position this basically at the origin of the world, 0, 0, 0. So we could go over to the transform, of course, and do that. Notice I've got a little rotation on this as well. One of the quick ways, rather than entering numbers, if we want to go back to the origin, is just to reset this component. So any component you can actually reset back to the default settings or the standard settings. So let me go ahead and click the little gear here in the top right corner of the component, and notice the top option is reset. So let me go ahead and reset that. You can see that I'm at position 0, 0, 0, scale, or rotation 0, 0, 0, scale 1, 1, 1. So that, whatever you reset the transform component, that's what you get. Now, like I said, the floor is a little bit big, so I want to scale it down a little bit. So I'm just going to go ahead and scale it half size in the X direction. You can see it made it half size. The Y direction, I'm just going to leave at 1, so that's the thickness of our floor, you know, from the bottom to the top. And in the Z direction, I'm also going to go to 0.5. So I'm essentially half the size that it was in the X and the Z direction. Okay, now I want to add some obstacles to my level. So I'm going to go ahead and continue to use some of these prototype assets. I'm going to pick the floor prototype 4 by 1 by 4 right there. Go ahead and drag it out. And of course I can tap the F key to zoom in on that. And I'm going to rename this as bumper. And right now it looks just like the floor because it's got the same material attached. So you can see the material over in the mesh renderer. You can see it's got the navy grid material. If I click that, it will actually select it in the project. It's kind of a shortcut to find it. Down here where you actually see the material, there's nothing to really click to jump over there and select it. So with the navy grid selected, I'm going to go ahead and duplicate this material. So I can just go up and say edit duplicate, or use the command or control D to do a duplicate. And I'm going to name this my bumper material. Now, of course, put this in the same folder as the rest of the standard assets. That's okay because this is just a copy of those standard assets. It's my own copy for this particular project. If I wanted to kind of separate my standard assets from my actual assets, of course, I could go up and just move this to the top level of the project as an example. So with the bumper material selected, I want to change some of the properties of this. Most notably, I want to change the albedo map on it. If I select this, you can see it's using the swatch navy albedo. I'm going to use one of these pre-made assets, so I don't have to make time to make the asset. So I'm going to pick the swatch teal albedo. So I can simply drag and drop it over here and make that change. Now, one common thing that people sometimes make a mistake is they'll select something and then they'll click, and of course that's going to change the inspector. One thing that you can do is you can actually lock the inspector. So if I click on the bumper material, I could click the little lock up here to lock what is here. Now if I click down here, it's not going to change what's in the inspector. So it's going to stay on the bumper material. And then of course I could click and then drag and drop it and make that change. And then of course unlock when I'm ready to unlock it. So I've got the material made. I need to apply the material to the bumper. So let me just go ahead and drag and drop it onto the bumper. And you can see that that material is now attached, and we can visually see that. So the next thing that we need to do is we need to position our bumper. So right now you can see it's just kind of where I threw it out there. Once again, I could reset the transform, which is going to essentially put it at the origin of the world. And you can see it looks a little bit funny because it's, basically at the exact same position as the floor. So I'm getting a little rendering problem here where Unity can't decide which one it should render first. So this happens to be 1 meter tall. So I'm going to go ahead and move it up 1 meter. And you could do this visually. Once again, it's very hard when you're doing it visually to get exactly 1 meter. You could do it numerically over in the transform. One of the nice things in Unity is actually snapping options. So under Edit, I could bring up Snap Settings. So here you can actually set the snap settings. So right now it's set at 1 meter by 1 meter by 1 meter, and scale settings as well. So let's say I'm visually moving this like here, and I've got it at 0.66 in the Y. I could basically click this snap to the Y, and it will snap to the closest meter. So you can see now I'm at 0, 1, 0. Or I can say snap all axes. So let me just kind of move it off and then say snap all, it's going to snap it to the closest whole numbers here. Once these snap settings are set up, you could actually hold the command key on the keyboard or the control key on Windows, and with that key held down, you can grab any of the axes and then move, and notice it's moving 1 unit at a time. So I'm going to move this a little bit off center. You can move it in whatever direction you want with that key modifier, the command key or the control key, and it will snap to whatever the snap settings are set there in the snap settings options. Okay, I'll go ahead and close the snap settings for now. So we plan to have several bumpers in the world. Whenever we plan to have multiple game objects that are nearly identical, we should make a prefab out of them. Prefabs are essentially a template of a game object that you can use over and over again. By making a game object into a prefab, you then only need to update the prefab itself, and then all the game objects that are built off of that prefab are updated. So the way we actually create a prefab is take your game object and simply drag it into your project. And I'll just drag it here into this sort of open spot below my material, and it's going to create the bumper prefab. I'm going to go ahead and close standard assets for now just to clean up a little bit. So let's also make a prefab for the floor. So I'll show you another way of doing that. Under the project panel, I can say create prefab, and this will make what's called an empty prefab, and I'll call this floor. Notice the bumper prefab is blue shaded, and that means there's something in the prefab, where this one is gray shaded, which means there's nothing in there yet. So we can basically grab the floor game object and drag and drop it on that empty prefab, and then it will turn blue. Okay, I like the technique of just dragging from the hierarchy over to the project because it's a shortcut. So now that we've got our bumper prefab created, notice that the game object now at the very top says prefab, so it's connected to a prefab. If for some reason it gets disconnected, it'll say prefab missing here, in which case you need to resolve that issue. So I've got one bumper. Let me go ahead and drag out a couple more bumpers. So let me drag out a second one. Once again, I can go ahead and use my snap settings. So I'll bring up the snap settings and snap to all the axes. And I want to, essentially bring this a little bit off from that prefab. So I will hold down my command key and go ahead and drag that. And I freeform dragged it initially, so it did get off a little bit. So let me numerically just set that back to 7. And let's go ahead and add a few more. Go ahead and use the snap settings. So I want all of them 1 meter high in the Y direction. So basically, I'll kind of create this little pattern. I can select all of these at the same time, once again holding down the command key and then moving them sort of in unison. So I'm going to kind of center them essentially on my world. So I've got 4 bumpers out there now. Let me go back to one of the bumpers. And, I might decide later that, these bumpers are a little bit big. So I want to scale them down. So let me select this bumper, and let's set the scale in the X direction at 0.5 and the Z direction at 0.5. And of course, I'll leave it 1 meter tall. So I applied that to this individual game object. So it's built off of the prefab, but it's got these modifications now on it. Now, if I make these changes and I decide, oh, I didn't actually want to do that, I can actually just click revert. So if I click that, it goes back to the settings of the prefab. But let me go ahead and make those changes again, 0.5 and 0.5. And let's say that I do want to propagate these changes back to the prefab. I could go ahead and hit apply here, and notice that it applied it to the prefab and immediately applied it to the rest of the game objects that are built off of that prefab. So this is one of the very powerful things of prefabs. So we've got a floor out, and we've got 4 bumpers. I need to get my player character out. So I'm going to go ahead and close snap settings. For the player character, we're going to use a standard asset under characters. And we're going to use the rollerball standard asset. You can see they have a first-person character, a third-person character, and rollerball. We're going to go ahead into the rollerball, into the prefabs, and grab this prefab. So that's essentially what they're giving us is prefabs that are templated game objects that are all set up and ready to go. So let me go ahead and grab the rollerball, drag it out here. Once again, I can bring it out. I can then reset the transform to put it right into the middle of the world. If I click the F key and zoom in, notice it's actually cut into the floor. I'm going to go ahead and hold down my command key and drag it up, let's say at about 2 meters. So it's a little bit off of the floor to start with. And we've got that game object now in our world. And notice it's got a variety of components. 2 of the most notable things is the ball script and the ball user control script. So this is what actually controls the ball. So without further ado, I could just click play. And my camera's not set up yet, but I can use the WASD keys or the arrow keys and actually roll around this world. So remember the difference between play mode and non-play mode. So I'm in play mode right now, so I can actually test things. I can click on various things, in the editor to see what's happening, but any changes that I make will not take place until I stop play mode. So let me go ahead and click the play button to stop play mode and reset back to the default settings. Okay, let's go ahead and save our scene now since we haven't done that already. I'll go ahead and save the scene as level 1 and store that to our assets folder. Of course, we should save often all the time as we work in Unity.
Prefabs are a very important concept, so let's review. Once you set up a game object with all of its components, you can convert it into a prefab. A prefab is essentially a template game object. With the prefab, you can make additional game objects. The nice thing about game objects created with a prefab is that if you ever update the prefab, it will automatically update the game objects built from it. Further, you could customize a game object built from a prefab and then revert back to the prefab if you don't like the changes. Or if you customize a game object built from a prefab, you can then apply those changes back to the prefab so that all the other game objects built from that prefab are then updated. Prefabs are a very powerful tool when building games in Unity. Without understanding how they work, prefabs can also pose a major problem for you. We will continue to use prefabs across this project to help reinforce how they work. In the next video, we'll set up the camera. In this video, we'll set up the camera for our game. Our objectives will be to position the camera to get it to follow the player, modify the background that the camera sees, and add music to the camera.
So the first thing that we need to do is position our camera. So I'm going to go ahead and tap on the rollerball and press the F key to zoom in. And you can see with the rollerball, the little axes gizmo. The Z axis is blue, of course, and the arrow is pointing in the positive direction. The way the controller works for the ball is when you press forward, it applies force in the positive direction, so it'll push the ball in the positive Z direction. So essentially, we want our camera to be looking down that Z axis. So we need to decide kind of the distance. I'll back up a little bit so we can see a little more of the world. And
maybe go a little bit off that axis so we can get a little more interesting view on the world. So, mostly down the z-axis, but slightly off to the side. So now we've got our scene view roughly the way we want our camera to look, but now we need to change the camera itself. So notice the game view hasn't changed. So we did this in the first project. We'll go ahead and select the main camera, go to Game Object, and then pick Align with View. So that will make the game object of the camera align with the view in the scene window. So you can see that our game view is now updated. And if we go ahead and play, you'll see that as I move the ball, we've got that view, but of course the camera is not following the ball. So one thing that we did in the first project is we used parent-child relationships to resolve this sort of issue with the moon rotating around the Earth as an example. So one idea is, well, let's make the camera a child of the rollerball so it follows the ball as it moves. So let's try that. So I'll go ahead and drag the camera into the rollerball. So now it's a child. So let's go ahead and test this. And as I move forward, you can see, whoa, what's going on? The camera is going all out of control as the ball rolls. And this really makes sense because the camera is a child of the ball, and as the ball is rotating, the child looks to the parent's coordinate system, and that coordinate system is constantly rotating, so it essentially rotates around the ball as the ball rolls. Of course, we don't want that. Let's go ahead and stop. So I'm going to pull the camera outside of the ball back to be at the top level. So let's look at one feature of the scene view. So let me click back on the ball. Right now we are in what's called global mode, which shows the axes of the world coordinate system. So as I move this, it's in relationship to the world. If I hit play and move the ball around, notice that up is always up to the world and forward is always forward. If I change this to local modes by clicking on where it says global here, now notice that the little gizmo spins. So this is actually reflective of the local coordinate system of the ball. So you can see that the z direction is constantly changing and so forth. So this is a nice feature to kind of realize what's actually happening in the parent-child relationships with the parent's coordinate system. So when you're in edited mode, you can always switch back and forth. And since this is essentially oriented to the world initially, you can't really tell a difference. But sometimes if this was a rotated ball to start with, the local and the global would be different. So how are we going to get the camera to actually follow the ball? This is where scripting comes in. So let me go ahead to the main camera, and we're going to add a component. So in the standard assets, we brought in the utility assets, and one of those is called smooth follow. So we're going to attach this smooth follow script. Let me just drag and drop it into the inspector for the main camera. And what this will do is make a game object follow another game object. In this case, the camera will follow the rollerball. So we need to set the target of what to follow. So let's go ahead and set that as the rollerball. We need to set a distance. I'm going to maybe make the distance about 6 and a height. I'm going to leave it at 5 and see what we get here. Okay, so I'll go ahead and press play. And we've got roughly a similar view that we had before. And as I move around, notice that the camera is smoothly following the rollerball. And that's exactly what we want. Let's go ahead and stop. The other thing to notice is that we've got the default skybox here, which is not really the look that I want for my game. So I could go and make my own custom skybox as we did in the first project, but really I could just get away with a solid color. So let me look at the camera settings up here. Under the camera component, you can see it says clear flags skybox. That basically means it's going to render the skybox. If I click the drop down here, I can switch to solid color, which basically means it's going to not render the skybox, but it's going to show a background color as specified here, and you can see it turns dark blue. So I'm going to go ahead and click on the color to bring up the color picker. I want to pick a very dark red sky. Of course, you can do whatever color you want, but I'm going to make mine very dark red, just sort of an off black. And I've got the sky the way I want it. Okay, the last thing that I'm going to do on my camera is add some music. Remember, the main camera has an audio listener component on it by default. Therefore, the camera is a good place to actually add music, since it will always be a constant distance away from the audio listener. If you put music on a different object in the world, and as the camera moves closer and farther away, the actual 3D positioning will make
the volume of the music sound less or more as you get closer or farther away from it. So like I said, the camera is a really good place to place an audio source, when you want it to be a constant volume. So I'm going to go ahead and click Add Component and go down to Audio. And of course, we've already got the audio listener component by default on the camera. Let's add the audio source component and go ahead and open up the properties. We need to specify a clip. It's looking for an audio clip. I can hit the little target here. We actually have in the assets that we imported, we have background music. So let me go ahead and add that. If I play this, you can hear we have music. It's a little bit loud, so I'm going to go ahead and reduce this. I'm going to make it about 25% regular volume. And I also want this to loop because this music is seamless, so I want it to constantly play as the game plays. And let's go ahead and play the game again. So we have that music playing constantly. We have the camera following the ball and positioned the way we want it positioned.
In the next video, we'll organize our project a bit. In this video, we'll discuss some of the best practices of organizing Unity projects. Our objectives will be to organize the project assets and organize the hierarchy.
So let's clean up our project a bit before it gets too out of hand. As we discussed last week, folders are a great way to keep your assets or your files organized. So you can see we've already got some folders here with the standard assets and the audio that we brought in, the scripts that we brought in. But we've created a few new assets here. So I always like to name things by their type. So for example, I'm going to create a folder for the scene or the scenes. I'll call it scenes, and then drag my level into that. This is an alphabetically listed list of assets. So if you want scenes at the top, one shortcut is you can rename this, put an underscore, and that'll bubble it to the top. So, a lot of people like to do this and just have their scenes always right at the top. You can see we've got a few prefabs here, so I'll create a folder for prefabs. So these will be my custom prefabs. So I accidentally created it in my scenes folder, so let me drag that out. And I'm going to put my two prefabs in there, so the bumper prefab and the floor prefab will be in my prefabs folder now, and my custom material. So let me go ahead and create the folder for that. I'm not going to make the same mistake twice, so let me just deselect everything, so when I create the folder, it will create it at the top level. And go ahead and call this materials, and then place the bumper material inside of that. Okay, so at the top level now, my project has scenes, audio, editor, materials, prefabs, scripts, and standard assets. And of course, this maps to the files and folders in the project on the operating system. But what about our hierarchy? Last week, we talked about parent-child relationships between game objects. From an organizational perspective, a parent game object is very similar to a folder in the project. Therefore, we can create what are called empty game objects to act as an organizational tool. So let's go ahead and do that. So under the hierarchy, we can go ahead and create an empty game object. So it created an empty game object called game object. And notice that the game object has a transform component. So it isn't exactly empty. If you look out in the scene, notice you don't visually see anything because there's no mesh renderer on it. But it is a game object that exists in the scene. We're going to put a variety of children under this game object. So remember, child elements transform is based on the position from the parent origin. If we want the child's transform to make sense to the world origin, it's always best to put the parent game object at the origin of the world. And this one happens to be at the origin of the world, so it's at 0, 0, 0 with no rotation, no scale. If that wasn't the case, go ahead and select the gear and select reset, put it back at the origin. And what I'm going to do is I'm going to label this so I can click it and hit return and type environment. So this is going to hold all of the pieces of my environment. So that includes the bumpers. So let me drag the bumpers and the floor and rest of the bumpers all down into the environment. So now I've got a nice and tidy hierarchy here where all of my various pieces of the level are held in the environment subfolder. And they're all based off of the parent transform once again, which is at the origin. So if I look at these directly, their positioning makes sense to the origin of the world as it does to the parent game object.
In the next video, we'll discuss how to use physics in our game. In this video, we'll discuss physics. Physics is an important part of many games. Unity actually has two physics engines, one for 3D physics based on the PhysX engine, and one for 2D physics based on the Box 2D physics engine. In Roller Madness, we'll be using just the 3D physics since this is a 3D game. Our objectives are to understand and modify colliders, understand and apply rigid bodies, and make use of physics materials.
Okay, I'm going to go ahead and click on the rollerball game object. And notice the rollerball has a sphere collider on it. It was part of the original prefab that we got from the standard assets. If I click on the floor, notice the floor has a box collider on it. And if I actually look at these in the scene, you can actually see the collider. So let me go back to the ball and click F. This green circle is basically representative of the collider on this object. If I go over to one of these bumpers, it has a box collider and you can see the green box. So the collider component is what is actually used to detect collisions on the game object. You could actually modify the size of that. It could be bigger or smaller than the actual size of the game object. For example, if I scale this up to, let's say, 5, you can see that that green box got bigger than the actual mesh of the game object. So let me go back to 4. Of course, I could just change it here, or I could click Revert to Prefab, and it will go back to the options of the prefab. So by default, Unity physics does not allow colliders to overlap. So, when my ball is rolling and it hits the bumper, it prevents it from going through it. One of the options of a collider is the is trigger option. Let me go ahead and select this and play. And then roll over to that. And you can see, whoa, I'm going right through this game object now. So by default, colliders prevent things from overlapping, but if you turn on this is trigger, it makes this into a trigger. So triggers are useful to detect a collision between game objects without actually preventing the object from passing through each other. So for example, the bumper could be an invisible object that when entered causes something to happen in the game, sort of like a pressure plate or that sort of thing. Right now you can actually see it, but if you turned off the mesh renderer, now it's an invisible object that the ball can roll into. When it hits the collider, an action could be triggered, for example. And we'll see examples of that as we continue. So let me go ahead and turn that back on, or I can just revert to the prefab once again. Let me go to the floor, and let's set the is trigger for that, and then play, and notice what happens. Let me go ahead and change my scene view so I'm focused on the ball. Go ahead and press play. And whoa, what happened? The ball fell right through the world because, once again, since we set the floor collider to be trigger rather than the standard, it didn't stop the collision from happening. So one thing that you could ask yourself is, why did the ball fall through the floor but not the bumpers? Let's go ahead and look at the ball, and notice the ball also has a component called the rigid body. Rigid bodies allow colliders to be affected by physics. So since the ball has a rigid body component, and notice one of the options of the rigid body component is use gravity. So that's basically, with the use gravity on, that applies a force constantly to the ball that pulls it down. If I look at one of the bumpers, there is no rigid body component on it. Therefore, it doesn't fall with gravity. It's generally a good idea to have rigid bodies on any game objects that have colliders and that are moving in some fashion, like the rollerball. So we looked at the use gravity setting on the rollerball. One other option of the rigid body is kinematic. If is kinematic is checked, the object will not be driven by physics. This is useful when you want to move the object directly through the transform. So with rigid bodies, you typically don't move the object. I mean, you can set it up through the transform, but once the game starts playing, you move it by applying forces like gravity to the ball. And the ball script actually moves the ball by applying forces. That's how we get the more natural rolling feeling rather than just moving it directly through the transform. But if you wanted to modify the transform directly through scripts, or if you wanted to have an animation on the ball through the animation system, which we'll talk about a little bit later, you would turn is kinematic on. But in the case of the rollerball, we want it to be affected by physics directly. We want it to have gravity, so we'll set it this way. The other options here, you can set the mass, the drag, and the angular drag for the game object. These are things that you can always play with and kind of see the results of. By changing these options, it will change how physics is affected on these options. So let me go back to the floor and, of course, turn the is trigger off so the ball doesn't fall through the world. So let me go back to the rollerball now, and let's look at the sphere collider. One option of colliders that's kind of interesting is called the material. Now this is very different than the material that has the shader and the textures that we've talked about before. This is really a physics material, and notice it's got a rubber option here. Essentially the ball sort of behaves like a rubber ball in this world when physics applied to it. So let me raise the ball up a little bit and just go ahead and hit play. And you can see it fell and it had a little bounce to it. Let me go ahead and hit the target here, and let's just set it to none and play again. No bounce. Okay, so that material on the collider, let me go back and switch it back to rubber, is what makes this have that little bounce. So you can see there's several physics materials. There's bouncy, ice, max friction, metal, wood, zero friction, of course, rubber. You could actually make your own physics materials. Under Create, you can create physics materials right here and set the options of bounciness and a few other options. So we have these bumpers in the world, and right now they're really not very bouncy. When you hit the bumper, you'd expect to be bounced off. So let's use the physics material for that purpose. So let me go to a bumper. Notice the box collider does not have a physics material attached. I'll go ahead and hit target and select bouncy. If I hit F, you can see which bumper this is. So if I play, now when I roll over to it, boom, it bounces off. If I hit one of the other bumpers, it has a little bit of a bounce because the ball is rubber, but not nearly as much as that other bumper that we had applied that physics material. So we like that, we want that. So let's go ahead and hit apply to the prefab on that game object, and notice all of the other bumpers now have that bouncy physics material applied.
As a quick review, physics are created through two components on game objects, the rigid body and the collider. The rigid body component enables physics on the game object, including gravity. Through the rigid body, you can specify the physical properties of the game object, such as mass. If a collider component is also attached, the rigid body will also detect collisions between game objects. While a collider is invisible to the camera, it determines the shape of the game object in terms of how it interacts with physics. The rigid body and collider work together to detect collisions between game objects. If isTrigger is set to true, objects can pass through each other, but the game can still detect the collision and respond accordingly. Colliders can have a physics material attached to modify its physical properties, such as make the game object bouncy. In the next video, we'll modify the player to control and look better. In this video, we'll enhance both how the player moves and its visual appearance. Our objectives will be to modify the speed of the ball, adjust the look of the ball through its material, and add a trail renderer to the ball to create an interesting visual effect. Now the roller ball is a Unity standard asset that, of course, we imported with the characters standard asset package. And this made it easy for us to get a character, or a ball in this case, up and running very quickly. And of course the roller ball has a variety of components attached. One of the most important components beyond the physics components that we've already talked about is the ball script. So let's play around with the ball script a little bit. You can see here we've got a variety of settings here in the inspector for this script, including the move power that controls how fast the ball moves, this use torque option which defines if torque influences the movement of the ball. We've got a max angular velocity and a jump power. So first off, I don't want to be able to jump in my game, so I'm going to change the jump power to 0. So by setting it to 0, my player will no longer be able to jump. The next thing that I want to do is I want to tighten up the controls a little bit. By having the use torque option selected, the torque of the ball actually influences the motion. And I think it makes the control of the ball a little bit sloppy as I was testing. So I'm going to go ahead and turn off use torque. And then let me go ahead and play and see what I've got. So I'm moving around. I seem to be real pretty sluggish now, so I need to increase that move power. So I'm in play mode, and while I'm in play mode, I can actually make changes. They just don't persist after I exit. So for example, let me go up to something like 50 for move power and hit return. And you can see I'm moving very fast now, maybe a little bit too fast. And of course I fell off the world here, so I got to stop to get my ball back up there. And of course, when I stop, I reset back to the original 5. So we can use play mode to do some testing. So while I'm playing, once again, I'm sluggish. Let's say I go to something like 25, hit return. If you are using keyboard controls, you have to click back into the game view to get your focus back there. But if you're using a controller, you don't have to do that. So here at 25, this feels about right to me. It may be personal preference, and the game that you ultimately build, you might have to go back and adjust the numbers here. But I like the 25 mark. So let me go ahead and stop playing here. It goes back to 5, and then I would need to, in edit mode, go ahead and change that to 25 once again and make sure that that then persists. So now that we got the ball moving the way we want it, let's go ahead and change the look of the ball a little bit. So first off, notice that the rollerball has this rollerball gray shader on it. And of course, the shader is actually set through the material, which is on the mesh renderer up here. So I can click on this rollerball gray option here under materials, and that will show the standard asset material that was brought in with the rollerball gray. And I want to change that. So I'm going to go ahead and duplicate that. So I can go up to edit and choose duplicate or Command D or Control D, depending on if you're on Windows or Mac. And I'm going to go ahead and rename this to my rollerball material. And I'm going to move that out of the standard assets materials folder up into my materials folder. So I'll just drag and drop it up there. And go ahead and close the standard assets to get those out of the way. So we've created this rollerball material now, but it's not actually applied to the rollerball. If we go back to the rollerball, notice that it still has the rollerball gray material. So I need to apply that rollerball material to the rollerball. And of course, there's many ways to do that. One simple way is you can actually drag the material and drop it right on the rollerball itself. And notice when I did that here in the inspector for the rollerball, you can see now it says rollerball material rather than that rollerball gray material. So let's go ahead and now edit some of the properties of that rollerball material. You can see this material in the inspector. It doesn't have any textures applied for the albedo, for example. Everything is done through tinting. So for example, I can just click on the little color swatch here and bring up my color picker and then specify a color. And you can see as I move the colors, the ball changes. And of course, you can also set your colors down here. I'm going to set a hex color that I've predefined. You can make this whatever color you want, but if you want to follow along and make it look exactly like mine, I'm going to use the hex color of 0056FF. And then you can put another FF to define the transparency. So that's the albedo color. Let me go ahead and choose a specular color as well. So I'll click on the color swatch by specular. And once again, the color picker will come up, and I'll set this one to 00FFFF to kind of create an aqua looking color. Notice that time when I hit return, it added the final two Fs because it's taking that from the alpha information here. So 255 is no transparency. And once again, you can tweak this however you want. That's what I want for now. So let me go ahead and close that. And now my ball looks a little bit different. And the other thing I want to do is I want to add a trail renderer to the ball just to make the game a little bit more lively, have a little bit more pizzazz. So to add a trail renderer, I just need to add a component to the rollerball. So a trail renderer is actually a built-in component. So let me select the rollerball and go down to Add Component. And the trail renderer is under Effects. So let me choose Effects and Trail Renderer. And that will add the trail renderer component. Now I can do that in multiple ways, of course. I could select the rollerball and also choose the components under the component menu at the top. So I can go to Component Effects, Trail Renderer, for example, and that'll do the same thing. Now the Trail Renderer component has many different options. Before I change any of them, let me go ahead and just press play and see what that did. So you can see I actually have a trail renderer here. It's kind of this weird pink color. But you can see, you know, there is a path here, and eventually you can see it disappear. So let me go ahead and stop that. So one of the most important properties of the trail renderer is the material that renders the trail. So let's go ahead and create a new material for this. So I'm going to go into my Projects tab and select Materials. And by selecting the Materials folder, when I choose Create, it will then automatically create it within that folder, of course. So let me go ahead and choose Create. Go down to Material, and I'm going to call this my Trail Material. And these are just the standard options here. I want to change my shader from Standard to Particles, and then choose Alpha Blended. And of course you can play with different shaders to see what effects they might have. So I want to change my tint color. So let me go ahead and choose just a white tint color here. And I'll leave the alpha at 128, you know, sort of half opaque, half transparent. And that's all I'm going to do to that trail renderer. Let me go back to my rollerball and apply that material. So notice right now the material is set at none, and that's why we had that weird pink color. That's basically, whenever you see that weird pink color in Unity, that means probably a material is not attached to something. So here in the trail renderer, I want to attach that material to my materials, and I can go ahead and just drag and drop it right there into that material spot. And that material is now applied. So if I, without any other changes, if I go ahead and hit play, you'll see that we no longer have that pink. We have more of a white color, but it still doesn't look great. So let me go ahead and stop this and go back to the trail renderer and play with some of the different options here. So just moving down, you can see the time is set at 5. That's basically 5 seconds. The trail, you know, will continue to grow for 5 seconds and then detract. So let me go ahead and change that to be much smaller. Let me bring it down to 2 seconds. And you could adjust these how you see fit. If I go ahead and play now, you can see that the trail, you know, is much shorter than it was before. So the other thing is our trail is much too big, and you can see the width right here is set at 1. And if I change that to something like 0.5 and then play again, you can see my trail is a lot smaller, so it's half of a meter rather than a meter. But it'd be nice to kind of have my trail dissipate over time. That's what the little diagram here is representing. So for example, let me change my width back to something like 0.8, so it's a little bit bigger, but it's not an entire meter, which is the size of the ball. And then I want to adjust a curve here. So you can see the little keyframe at the beginning, and this sort of represents time here. So if I go to the very end of this and right click, I can then choose to add a key. And once I have a key there, I can actually drag this down. So if I drag it all the way down to 0, you can see the curve basically represents a transition over time from 0.8 width to 0 width over the 100% of the time. So over 2 seconds, it will have that transition. So if I go ahead and play again, we can see the effect of that. So you can see I've got a nice tapering off of that trail. Now the last thing that I want to do is actually adjust the color over time as well. So you can see the color option just below the curve. Let me go ahead and select this. And notice I don't get just the regular color picker, I get a gradient editor. So we can actually define a gradient over time. And the way this works is the bottom are colors and the top is transparency. So for example, I can choose the bottom indicator here and select that. And that will bring up our color picker that we've seen before. And I'm going to go ahead and set a starting color of 00FFEA to create, you know, a similar blue color that we've seen before. And let me go ahead and close that. And then for the final color, So this is the beginning color, and then I can go to the end here and double click on this to bring up the color picker once again. And I'm going to set the final color to 0080 FF, so a darker blue color. And go ahead and close that. So I've got a transition from this color to this color, or a gradient, if you will. I also want to transition the transparency. So if I double click on the first one, you can see I start with an alpha of 255. And then if I click on the last one here, I'm going to transition down to an alpha of 50. So almost completely transparent. And you can kind of see the effect there in the preview. Of course, you're not going to see that checkered pattern. And let's go ahead and close this and test it out. So you can see now our trail behind the ball is a blue color rather than the white, and it changes color over time, and it fades out over time as well. And I think it looks pretty good.
In the next video, we'll add the ability to die in the game through health and damage. Right now, when we fall off the floor, we fall forever. It would be ideal if the game ended or restarted when this happened. This is the goal of this video. Our objectives will be to add health tracking to the player and add a game object below the floor that kills the player if they collide with it. So right now, when we fall off the floor, notice we fall forever. It would be ideal if the game ended or restarted when this happened. Fortunately, we provided this behavior for you through two included scripts, health and damage. The health script provides code to track the health of a character in the game, while the damage script damages the character. So let's get this set up. So we want to add health to the rollerball. There's actually a script under the scripts, which are the scripts that we brought in, the MSU game scripts, called health. So, there's multiple ways of doing things. We can drag this onto the game object. Down at the bottom, you can click Add Component. These are all of the named components. Notice there's one called scripts. And we can find that here as well. So I'll do that this way, for example. So let me pick health, and we've got the health script attached. There's options to set how many health points the player has, or the character has. If the character has multiple lives, how many health points they get when they respawn, and then the number of lives. I'm just going to set these all at 1 for now because my game is going to be pretty simple. 1 life, 1 hit point. You die, you die. There's various other options here for exploding. We'll use some of these later. One thing that we are going to change is this option that says on lives gone. Right now it says do nothing when dead. Let me select load level when dead. So when we die, we want to reload the level. So right below, we can actually specify the name of the level. And of course, it is called level 1. That's the name of our scene. If we wanted to go to a game over screen, we had a separate scene for that. We could type that here. So when you died, it went to the game over screen. But for now, we'll just reload the level that we're in. So now we need something that will detect when the player has fallen off the floor and then deal damage to the player. There's many ways to achieve this, but one simple way is just to create a game object that the player collides with. So essentially what we can do is we can take the floor, and I'm going to go ahead and duplicate this. So I'll hit my Command D or Control D to make a second floor, and I'm going to rename this. Death Zone. And right now this is attached to the same prefab as the floor. I want to break that connection and make it into its own prefab. So I'm going to drag the Death Zone into the prefab. So I've got now a link between that game object and this prefab rather than the floor prefab. So obviously it just looks like the floor, and in fact it's right on top of the floor now. Let me go ahead and drag it below. If we look right from the side as we drag this, it's a little bit hard to see because they're the same color, but the floor is about 1 meter thick. So I'm going to go ahead and set this just below the floor at 0, -2, 0. And I'm going to scale it up quite a bit. Right now the floor is at 50% X and Z. I'm going to set this at 2. So make it twice as big as the original floor that this was based off of. So if I look at top-down view, you can see here's the floor, here's the death zone, which is much, much bigger. Like I said, the material is the same, so it's kind of hard to distinguish the two, so let's make a new material. So let's look at the material. On this is the Navy grid material that we've seen before. Once again, I'm going to go ahead and duplicate that. So I'll select it over here and Command D. I'm going to name this my death zone material. And once again, I'll drag it up into my own materials folder, just to keep it separated. And let's go ahead and apply this right away to the Death Zone game object. So I'll drag it out there. If I look at Death Zone, you can see that, yes, that material is now on there rather than the Navy grid. And I want to change a few things on this. So the first thing is the actual albedo texture. So let me click on that so I can see, it's built on this swatch navy albedo. Let's go ahead and change it to the swatch white albedo. So drag that over there. So now you can see it's white. And given that it's white, we can change the tint color and directly see that. So let me bring up the color picker and let's make this, kind of a bright red. So now that we've got our material set up, let's go ahead and add that damage component. So once again, I can click Add Component, go down to Scripts, and select the damage script. So here we have the damage script. You can see it's going to apply amount of damage. This would be like 10 hit points coming off. Of course, our character is only 1 hit point, so 10 is more than 1, so this would kill the player. So I'll just go ahead and leave that. Notice it says damage on trigger. So this is what is going to actually cause the damage to the player. Right now, there's a box collider on this. We got that with the floor when we duplicated it. But I'm going to change this to a trigger because we want to make it, the collision of this death zone to trigger the damage. We don't want the ball to actually bounce off the death zone. We just want it to kind of go through it and, have the script run. So let me go ahead and say is trigger. And we're not going to change any of the other settings on the damage script for now. Let's just go ahead and test this. Boom, I died and the game was reset.
In the next video, we'll make our game a lot more interesting by giving the player something to do. What is a game without the ability to collect things? In this video, we'll add pickups, otherwise known as coins, to our Roller Madness game. Our objectives will be to set up the coin game object, populate the game with coins, and discuss the concept of tagging game objects.
To create our coin, once again, we're going to use the prototyping standard assets. So under prototyping, there's actually a prefab called pickup. But one thing I noticed, and I think this is a bug with the standard assets, is notice over here that there's no mesh attached. No mesh filter, no mesh attached. So I think for some reason this prefab got messed up. But that's okay. This gives us a good learning opportunity. So let me go under model and notice there's actually models for most of these prefabs. And one of those is the pickup prototype. So right here, we can see there's the model. It's sort of a coin. So we'll go ahead and use this model to create a new game object. So let me go ahead and just drag it over to my scene. This created a game object. I'm going to go ahead and rename it right away as coin. Let me click F. I am, kind of in a top view. So let me switch that. So it gave it a transform. I can go ahead and reset that transform just to be at the origin of the world. And of course, it's kind of half cut in the world. So, holding my command key down, I could use the snap setting just to move up, 1 meter, and then let me move it sort of away from my ball, but I'll keep it kind of close because we're gonna, test with it for a little bit. Right now, the coin's a little bit big compared to the size of my ball, so I'm gonna go ahead and scale it down. So I'll scale it to 0.4 in X, Y, and Z directions. And I also want to change the material because I don't like the pink color on my coin. So let me go ahead and select the material. You can see it's in the prototyping material. So just like we did before, I'm going to go ahead and duplicate that and give it a new name. I'll call it my coin material and drag it up into my materials. And then go ahead and apply that. So right now you're not going to see any change because it's the exact same thing, just a copy of it. And let's go ahead and change the texture that's applied to the albedo. There actually is a swatch yellow, so let me go ahead and drag that rather than the pink one, and that's instantly applied. So now it looks much more like a coin. So let's look at a couple of the other components on the coin. There aren't many because we created this from the material. So one thing that we want to do is we want the coin to collide, or we want the ball to collide with the coin. So right now there is no collider component on this. So let me go ahead and add that. So I can say add component. Colliders are part of physics, so let me select physics. And I want to use a sphere collider. So the coin shape is not actually a sphere, but I want to collide sort of in the area around the coin. So let me select that sphere collider. I could tap F to zoom in, and we could kind of see that sphere around the coin. Once again, colliders, you can change their size, so I can make it slightly bigger, just so you have to be kind of just close to the coin for this collision to happen. I also want this to be a trigger because I want you to not bounce off the coin. I want you to be able to go through the coin. So I actually want the coin to also rotate. I can sort of simulate that by going up to the y-axis and, kind of clicking and dragging. You can see the sort of rotation effect there. I'll undo that to go back to 0. I actually have a script that I've provided that creates this rotation. So I'm going to click Add Component, go down to Scripts, and choose the Rotate script. You can see the options here. There's a speed setting. This is how many degrees per second. I'm going to change this to 180 degrees per second. So it'd be sort of half of a whole circle in 1 second. And then you pick which direction you want to rotate. So I want to rotate around the y-axis. So let me go ahead and play this. So you can see the coin spins. So another thing that I want to do is actually add a rigid body. So this isn't going to have gravity on it, but because it's a moving object with a collider, you always want to have a rigid body on those so the physics system knows that this is a dynamic object in the world. So let me go ahead and click Add Component, go down to Physics, and choose Rigid Body, the top option. Now, once again, we're not going to have this fall at this point, so we're going to turn off Use Gravity. And this is actually being driven by this rotate script, which just rotates the transform. So we're not applying forces to this or torque, we're just rotating it. So I'm going to make this is kinematic. So the last thing that we want to do in terms of setting up our coin is to add another script to let the game know that this is a pickup. This is treasure. So under Add Component, under Scripts, we've got a script called treasure. So I'm going to go ahead and select that. You can see the components added. It's got a value. I'm going to set it as a value of 1. So I'm going to have just a direct 1 coin equals 1. So I do that. Let me go ahead and play. And I can move my ball over there, and boom, I picked up the coin. It disappeared. So what's actually happening? This treasure script basically looks to see if the object that collided with it is the player. And if it's the player, then it destroys itself. So how does it know that the object that collided with it was the player? Let me go to the roller ball, and notice there's a tag at the top, and it's tagged as player. So basically that script on the coin looks at the tag of the game object that ran into it, and if it's tagged as player, then it does the appropriate things. So tagging is a very powerful way. Once we get into scripting, you'll see this. It's great to tag your objects. Then through code, you can actually respond to things based on their tag. You can also, of course, respond to things based on their name, but sometimes there's more generic things. So rollerball is very specific, where player is a much more generic name. So for example, under coin, let's say we wanted to tag this. So right now the coin is untagged. Let's make a new tag. So I can click Add Tag, and this goes over to this tags and layers editor. Right now there are no tags. There's just the default ones that we saw before. So let me click plus and give it a new name, and I'll call this a pickup, which is maybe a more generic name than coin. So I created it. Now I have to go back to the coin and actually tag it. So by creating it, it added that to the pop-up list. And let me go ahead and select this as a pickup tag. So now our coin is basically all set up. We're going to have multiple coins in the world. So let's make this into a prefab. So let me drag it over into my prefabs folder, and once again, close up some folders here just to make it a little bit cleaner. And let's go ahead and drag out a few coins. Just for sake of example, let's go ahead and maybe bring out kind of a 4-coin pattern around my player. And of course, we can look at their transforms and make sure they're positioned properly. So my original coin was exactly 1 meter off. So I could go ahead and set these exactly to 1 meter. And they're off by a little bit. So if I really want to be precise, I could select all of them and bring up the snap settings and then say snap all axes, and they'll snap right to the whole numbers. So the final thing that we can do is clean up our hierarchy a little bit. We've have several coins in here now, so this is a good opportunity to create another empty game object. So let me go create empty under the hierarchy. Go ahead and label this coins. Once again, I want to set this at the origin of the world, so let me go ahead and reset the transform of this. So I'm going to go ahead and grab all of my coins and put them into that coins empty game object. So now they're all organized there under coins. So let's go ahead and play and pick up our coins.
In the next video, we'll add a display for the number of coins collected, as well as add a game over screen. Now that we have pickups, we need some way to display our score to the player. It would also be nice to have a game over message upon death rather than just restarting. We'll do both of these by creating a basic user interface in this video. Our objectives will be to learn a little bit about Unity's graphical user interface system, and then use this system to create a score user interface and a game over user interface.
So let's first add our user interface to display our score. So under the hierarchy, we can go to Create, UI for User Interface, and we want to create a text display for our coins. So let me go ahead and select Text. And notice what this did. It created a game object called Canvas and a child called Text. So the canvas defines the 2D space in which the UI elements are rendered. We'll talk more about user interfaces as we go, but for now, let's just get this set up. So the first thing I'm going to do is I'm going to rename the canvas as main canvas, because this will be the main canvas for the game. Notice there's various options over here. One of those is the canvas scaler. So this defines how this scales depending on the size of the game screen. Right now I'm in a 4:3 aspect ratio down here, but perhaps I might be in like a 16:9, which will show a lot more. So I want my UI to scale properly. So rather than constant pixel size, I'm going to go ahead and say scale with screen size. Okay, let me go to the text game object, and I'm going to go ahead and rename this right away. Hit return. I'll call this my score text. And let me tap F. So notice F actually zoomed to this. So the game object we can see is out here in my scene. It has new text on it. But we're in 3D view now, which doesn't exactly make sense when we're looking at 2D elements. So let me click the 2D option under the scene. And if I zoom out, we can actually see here's the canvas and here's the text below that canvas. So the first thing that we want to do is we want to anchor our text properly to the canvas. So at the very top, notice there's this little diagram. Let me click on that, and this brings up the options of anchoring. So at the top it says Shift, also set pivot, Alt, also set position. So in general, if you hold Shift and Alt at the same time, this will allow you to do several things at once. So let me go ahead and say I want to anchor this score. I'm going to have it, at the top of the screen here. So holding Shift and Alt, let me click the top portion, and you can see, boom, it jumped right up there to the top of the canvas. So right now it says new text. I'm just going to show the score, so I'll hit 0 as a placeholder. And then I can modify some of the font properties, so I'll just use the default font here. I want to make it a lot bigger, so I'm going to make it 40. And I want to make it bold. And notice I can't see the text anymore because it's actually too big for the display. So one thing I could do is actually drag this out and make it bigger, and there it appeared again. but let me go ahead and undo. One quick way to resolve this is to change the overflow from wrap to overflow in both the horizontal and vertical directions. And you can see, oh, there's the text. So it's actually bigger than the size of the text box, but it's actually visible. I usually like to overflow depending on what I'm doing, just to make sure that it will always show properly. So if I got a huge score, it's not going to all of a sudden disappear from my display. So I'll set the alignment to align to the middle of the display, and I want to change the color of the text. I don't want it to be black because it's not showing up very well. You can actually see it there. So let me click color, and once again, I've got a pre-selected color, EEFFFB9B. So it's kind of a off-white color, and I'm going to go ahead and add that as a preset, and I'll just call this my text color, so I can use it again in the future. Notice there is an alpha set on this, so it is semi-transparent a bit, which is okay. So we have our very basic main canvas, our main UI, our score display set up. While we're creating UI, why don't we create a game over screen as well? So to do this, I'm going to basically create a whole nother canvas. So under create, I can go down to UI and actually select canvas. So I get another canvas. Canvases, once again, hold all of the UI elements. I'm going to name this my game over canvas. Once again, I'm going to set the scalar, the canvas scalar, to scale with the screen. So just like before, I want to have text on the end game screen. So with the canvas selected here, I could go to create UI and select text, and then it will put it as a child object of that canvas. So I need to set up this text component like we just did, but one thing that we could do is we could actually copy values from one component to another. So if I go back to the main canvas and go to the text component, I could actually go and click the little drop down gear and select copy component. Now when I go to this text component, which I'm going to rename end game score text. So I'm going to go over to the text component, select the gear, and then I can say paste component values. Since it's the same type of component, I don't want to add another text component. I just want to paste the values into this component. So I do that, and boom, makes it 0, sets up the font, sets up the color, and all of that stuff. I'm going to tweak it a little bit, but at least that gets me started. So where I want to place this is actually in the middle of the display. So this is going to be the game over screen. So I don't want the score to be at the top anymore. I want it to be in the middle. So let me click on the anchoring options, and once again hold Shift and Alt on my keyboard, and I'm going to click on the center, so it's right there in the middle. And on the end game screen, I want to make this a lot bigger, so I'm going to set the font from 40 up to 150, so it's going to be a nice big display. And I want to move it up a little bit, so sort of the top of the text is in the center. There's various ways I could do this. One way is I could just take this position Y and run it up a little bit. So I'm just clicking and dragging on that, or I can just type in a fixed number. So right there, just sort of slightly above center. So one thing that you can see is I've got sort of two canvases here, and it might become a little bit confusing. So let me actually inactivate the other canvas. So if I click on that game object, I could just click the active inactive checkbox. So it's inactive now, I don't see it. So now I'm just focusing on my game over canvas. Okay, so this is the game over, so we see the final score. I also want to have a button to allow the player to play again. So let me go under Create UI and choose Button. And you can see it made a button below that. I'm going to go ahead and rename this as Play Again Button. So the first thing let's do is anchor the button. So let me click on the anchor, holding down Shift and Alt. Let me put it right there in the center of the screen. You can see it overlaps a little bit with my option above. So sort of in the opposite direction, the position Y. I'll drag it down a little bit to put it below the score. And the default button doesn't look all that great. So let's tune it up a little bit. So right here where it says image, this is based off of a UI sprite image. Let's go ahead and change the color from white to EEFFFB9B. which I think was actually the same color as the text. You can see it's a little bit semi-transparent. I also don't like the fill, so I'm going to turn off that fill in the middle. So I've got my button looking about right, but I also want to change the text. And the text is actually a child of the button. So let me click on that text. And once again, I can copy the properties from the score text as an example. So let me go back to the score text and copy that component. It might still be in my clipboard, but it may not be. So let me go back here and then paste the values. And you can see it says 0, but I want to make it say play again. It's probably too big, so let me scale it down to maybe 27. And the text is overflowing, so it's overflowing the edges of my button. So if I go back to the play again button, I can basically either visually, tap F, I could drag these out, or numerically up at the top, I can make it a little bit wider, maybe a little bit taller, and then I could go to the text and maybe center within that area. So the last thing that I want to do is actually set up the behavior of my button. So on the text where it says play again, I'm going to go ahead and add a component, and that component is going to be a script, and I've got one script that's called UI button level load. There's also UI button quit game, which would be another option if I wanted to have a quit button. So let me use the UI button level load. It asks the level to load, and for now I'm going to set this as level 1 since I only have one scene in the game, and when we load that scene it's basically like playing over. So I've got that script component attached to my text. The last thing I need to do is make the button actually select that. So back under play again, down here it has an on click where we set up what happens when you click the button. So let me go ahead and click the plus, and we drag in a game object here, or I can hit the target. Let me just drag that game object right onto that option, and by doing that it basically loads all of the sort of components and properties of that game object. So if I click the drop down now, you can see that UI button level load is here, and it kind of decomposes the script, which is a little confusing, but the script basically has a load level function. This will become more clear once we look at scripting, but for now, just trust me, pick load level. So our button is all set up. So we've been looking at the game over screen. Once again, that's the one that's active. So I'm going to go ahead and click on the game over canvas and make this inactive, and then go back to the main screen or the main canvas and make this one active. So we have our UI all set up and ready to go.
We have our GUI elements created, but they're not yet working. We'll resolve that in the next video. In this video, we'll create a game manager that will control the states of our game and update the user interface elements accordingly. Roller Madness is a pretty simple game with just 3 states. The game starts in the playing state and remains there until the player dies. The game then moves to the death state, where the user interface switches from the main canvas to the game over canvas and the music fades out. Then the game transitions to the game over state, and the game over sound effect plays. The game stays in the game over state until the player clicks the play again button, which transitions the game back to the playing state. Our objectives will be to create the game manager game object, attach the game manager script, and configure it properly.
So let's start by creating an empty game object to essentially be our game manager, or to hold our game manager component. So under create, let's create empty. Let's name this game manager. And for the game manager, I always like to have it right up at the top of the hierarchy. So to do that, I can simply just drag it right to the top, and it can hold that number 1 spot, so I could always find it. Just like everything else, I want this to be at the origin of the world. It doesn't really matter that much, but I like to be neat and tidy. So let me go ahead and reset it back to 0, 0, 0. And really what makes the game manager work is the game manager script. So let me go to add, scripts, and choose the game manager. Now this is a pretty basic game manager that can actually work with a lot of game types, and it's actually perfect for the game that we're creating here. So you can see there's various properties that we need to set up here. Number one is the player. So let's go ahead and attach the player to the player spot. The game state is sort of what state the game is going to be starting in, and as the game plays out, we can visually see that. You can see there's a playing state, a death state, a game over state, and a beat level state, which we're actually not going to use currently, but you could use it as you extend this project in the future. The score is basically what is going to keep track of the score of the player. Can beat level is an option, yes or no. We don't want to be able to beat the level. We want you to play until you die. So I'm going to leave that off for now. But if we did have that on, we could then set a level score. So for example, we could have a level where maybe you have to get 5 coins or 10 coins before you move on to the next level. Now we need to set up linkages to all of our UI. So there's the main canvas UI, which we have to set the main canvas. So let me drag the main canvas onto that option. There's a score, there's a main score display, which is our score text. There's a game over canvas, which we've of course created right there. And there's a game over score text, which is the in-game score text. If we did have a beat option, we could have a separate canvas for beating the level where maybe it congratulates you, and has you move on to the next level through a button like we created before. The background music is looking for an audio source. Of course, that's on the camera. So kind of a shortcut is you can actually just drag the game object itself, and if it's got the proper component, it will then set that accordingly. So you can see main camera audio source. There's a game over sound effect, which once again we could use the little targeting. So there is something called game over. And notice there's also a beat level sound effect, which I actually included for you, level victory right here. But we're not actually going to use it, so I don't really need to set it. You could set it if you want. Okay, our game manager is all set up, but we do need to change one thing on the player. So if I go to the player, if you remember, when we attached the health script, we set that once your lives are gone, it's going to reload the level. The game manager now is going to handle that operation by bringing up the game over screen. So I'm going to go ahead and change this back to do nothing when dead. So once the player dies, the health script will not load a level. It'll just do nothing. And the game manager will detect that the player has died and then display the proper UI. So let's go ahead and test this. So I can collect coins. You can see they're tallied up in the UI there. And if I go over to the side and fall off the world, boom. Over. I get my nice little game over sound effect. I see my final score, and there's a play again, which I can click, and the game reloads.
In the next video, we'll add an enemy to increase the challenge of our game. This game would be a lot more challenging if there were enemies in the world to avoid. In this video, we'll add enemies to the game. Our objectives will be to create an enemy game object and set it up. In doing so, we will review several of the concepts that we've covered so far.
Okay, we're going to create our enemy game object. And to do this, we're going to harken back to our first project where we created just primitive assets. So I could use some of the prototyping assets, but for sake of example, let's go up and say create 3D object and make a cube. Okay, so the cube is created. It's not in the center, so let me go ahead and reset that so we can see it. It's essentially a 1 by 1 by 1 cube. Let me select that here in the scene view. Oh, I'm still in 2D mode. Let me switch back to 3D and drag this up. And of course, I want to rename this not cube. I want to name it enemy. And we need to create a material. So let me go ahead and look at my materials. I'm going to base this off of the death zone material. So let me go ahead and select that and then duplicate it and rename it my enemy material. And let's change the albedo texture from the white swatch to an orange swatch. And I'm going to change the tint color back to just pure white. So it's going to be kind of an orange looking enemy. And now that material is set up, I'm going to go ahead and drag and drop it on the cube. So we've got an orange enemy. So there's various components or scripts that we need to attach to the enemy to make it do what it needs to do. So let me go ahead and choose add component, go down to scripts. One of those is the chaser script. So the chaser script basically makes a game object chase another game object, which is exactly what we want our enemy to do. So let me choose that. You can see there's a speed. Right now it's 20. Just by testing before, I know this is pretty fast, so let me change this to something like 4. Minimum distance is how close will it get. I'm going to say 0, so it would try to get right on top of the enemy if possible. And then there's a target. So the target we can specify as rollerball. Basically, the way the script works, though, is if the target isn't specified, it will default to a player tagged game object. But let me go ahead and specify that to start out with. Okay, we have the chaser set up. Let me go ahead and play this so you can see that. Right now it's right on my ball, so my ball fell right on top of it. But you can see the enemy is, essentially chasing me around the world. Notice it is going through bumpers because we haven't fully set up the enemy yet with colliders and that sort of thing. So the first thing that I'll do is I'll actually move the enemy away from the player at the beginning of the game. So let me just drag it over here. Maybe I'll make it so we can kind of just see it in the camera right there on the edge. So let's add a few additional components. So we do need a rigid body because we want this to collide with things like the bumpers. So let's go ahead and add physics and add the rigid body. Once again, you can modify the mass and drag and so forth. I'm just going to leave everything at the defaults for now. I do want this to use gravity just like the player, so it will fall off the world just like the player will. It's going to be affected by forces, so I will not check is kinematic. So the other thing that I might want to do is it already has a box collider on it, but there's no physic material. Let me go ahead and make this bouncy, so the enemies kind of bounce off the ground depending on how high they are when they originally appear in the world. So right now, if I once again zoom in on this, it's pretty much right on the ground. So let me move it up a little bit. Once again, if I want to be precise, I could snap it or just go over and type. So I'll start it at 2 meters high and go ahead and try that. So let's just hit play. You can see now that it won't travel through bumpers, so we can kind of block it, get away from it. But the enemy isn't really doing any damage yet. It's just kind of getting in our way. So just like with the death zone, we need to add a damage script on the enemy. So let me go and say add component, scripts, pick damage. We could define the amount of damage. I'm going to just leave it at 10 because I do want it to kill my player on contact because 10 is greater than 1. I don't have a trigger right now. I could actually create a second collider on this, so you can actually have multiple colliders. So I can have one collider that's not a trigger and bouncy, so it interacts with physics, and I can have a second collider that is a trigger that would detect a trigger collision. But this script is actually set up to also have the option of damage on collision. So I'll switch to damage on collision. And the final thing that I want to do is I want to give the enemy health, just like the player, because I want the enemies to die as well when maybe they run into each other or when they fall off the world and run into the ground. So let me add the component for health. And once again, I'll leave it with the defaults. So let's go ahead and play. You can see the enemies come in pretty quickly, so maybe I need to adjust their speed a little bit. But once I get moving, I am able to get away from it if I focus on that. So we have our enemy pretty well set up. So let's make it into a prefab by dragging the game object into our prefab folder to create a enemy prefab. And let's go ahead and add 2 enemies to the world to start out with. Once again, let's position it. So I'm going to make this, maybe 2 meters high, and let's do a top-down view. And I'll position both of these guys to be kind of at the far extremities of the world so they don't attack me immediately before I have a chance to start moving. And just like the coins, it might be nice to have an empty game object to organize my enemies. So I'll call this enemies. I'll set it back to the origin, and then I'll drag my enemies into that empty game object. So let's go ahead and try this. So you can see the 2 enemies up there in the scene view are chasing me. If I'm good enough, I can see if I can get them to run into each other. Might be a little tricky to do that. There, they just destroyed each other. In the next video, we'll add visual and audio polish to the game through particle effects and additional sound effects. In this video, we'll create a few particle systems to create visual polish in our game, as well as add a few sound effects. So far, we have just had solid objects in our game world. A particle system allows you to simulate fluid-like entities such as fire, smoke, and clouds. The larger visual effect of the particle system is achieved by having many simple 2D images or 3D meshes moving together. Our objectives include using Unity's particle system to create a simple explosion of sorts for the player, coin, and enemy game elements. We will also add sound effects to go along with each particle system. Ultimately, we will add the resulting effects into the game. So let's go ahead and set up a particle system for our player explosion. So under the hierarchy, let's select Create, and Particle System is actually an option here. So let me select that to create the particle. And you can see it creates a particle system game object. And you can see it's emitting particles out in my world, sort of these white glowing balls floating up. So I'm going to go ahead and rename this as my Explode Player particle. And particle systems are a thing that you sort of just have to play with and kind of see the visual results. When the particle system is selected here, you can see it's sort of previewing. There's a particle effect option down here where I could pause it or start it playing again. I can stop it and so forth. I can play with the speed and the playback time and so forth to see the results there. When I unselect that, it just freezes at the last setting. So particle systems are a great way to sort of iteratively test in the editor the sort of results of that. So over here in the components, I'm going to kind of expand this a little bit. You can see that particle systems are just a component on a game object, and they've got several different little tabs here that you can open and close. So there are literally hundreds of things that you can play with, and if you roll over these, a little tooltip will pop up that'll explain what it does. So duration, for example, is how long does the particle exist. Right now it's 5 seconds. Let me switch this to 1. So obviously I played a while to kind of figure out what settings that I want previous to this demo. Otherwise we would take forever here. So I'm going to go ahead and just talk through the options that I've selected. So the start lifetime I'm going to set at 1, so they only last a second. The start speed I'll leave at 5. The start size I'll leave at 1. Start rotation at 0. I'm going to give it a little bit of gravity. So rather than 0, I'll set to 0.5. And you can see that visually they're kind of coming up and then falling off a little bit. Let me go down to emission. Emission sort of defines how fast things are emitted. If I set the rate to 0, you can see that nothing's being emitted, which is actually what I want because I just want to set a burst at the beginning for this sort of explosion to happen. So down here it says burst, let me click plus, and I want a burst of, let's say, 20 particles right at time 0, because it's sort of the player falling off the world or getting hit by an enemy, and they're just going to sort of explode into pieces. So the next option is shape. Shape defines the shape of the particle system, and notice it's got this cone that sort of defines that shape. There's various options here, including sphere. You can see that visually represented, so it's going to shoot out in all directions. I actually kind of like hemisphere for this, so it's kind of a dome where things are coming out. So they're all sort of shooting up, but around the area. So let me close these up as I go. Let's go down to size over lifetime, and I'm going to turn this one on. And I want to basically have the particles get smaller over the life. So let me go ahead and click on the size. This actually brings up this curve editor down here, and I could just basically drag the endpoint down, or there's sort of these presets that you can select. So you can see now over the life they start big and then they get smaller. So I'll close that up. The last thing that I want to modify is the renderer. So the renderer defines what's actually rendered, and that's what's kind of setting these sort of white things coming out. Right now it's set at the render mode is billboard, which is sort of Billboard are like 2D images are sort of emitted out of this particle system. And very often that's really what you want. You want to emit a bunch of 2D images to make the look of smoke or fire or that sort of thing. But for this particle, we actually want it to look like our rollerball is blowing into pieces. So I'm going to change from billboard to mesh, because we're going to actually use the mesh of the rollerball in our explosion. So once you have mesh, you can pick the mesh to use. Just default it to cube. Let me pick the little target. These are all the meshes in our world. I'm going to select rollerball. And then, of course, I also need to set the material of my rollerball. So right now it's just a default particle material. Let me go ahead and choose my rollerball material. And you can see the effect out here. It looks like a bunch of little roller balls exploding. Okay, we've got our particle system set up the way we want. Like I said, you could play with this for hours literally if you wanted to get different effects. But I'm pretty happy with what I have there. The other thing that I want to add to this game object is an audio source, because with the particle system, I actually want to play a sound effect. So let me go ahead and add a component to this. I want to add an audio source. And go ahead and open that. I can close the particle systems if I want to. And let's go ahead and add a sound effect. So I actually do have a sound effect called Player Explosion that will play. And I don't need to change any options. I'll just go full volume. It's not going to loop or anything like that. And basically the way that this game object is going to work is every time the player dies, it's going to add this particle system to the world and play the sound. So, one thing that you start to have is you start to get a lot of game objects in your world when you do things like explosions and that sort of thing. So I actually want the game object to clean up after itself. So let me go and click Add Component, Scripts. And there's a script in here called Timed Object Destructor. So let me pick that. And basically what this will do is it'll destroy the game object after a set of time. So I'm going to say after a timeout of 3 seconds, I want it to kill itself. I want it to destroy the game object from the world to sort of clean up after itself. Otherwise, you might get, many particle effects out in your world. Not necessarily for the player, since you only die once, but for the other objects that we're going to work with. So we have this set up. I'm going to go ahead and make this into a prefab. So I'll drag it over to my prefabs. So it's my explode player particle. And I don't want it to actually exist in my world initially. I only want it to come out at the appropriate time. So I'm going to go ahead and Command or Control Delete to get rid of the game object. If I ever want to edit it again, I can just drag the prefab out and then edit it and then apply back to the prefab. So I'll delete that. So let me go to the rollerball and scroll down to the health. And we have this explode prefab. So this is where we want to actually set that explode player particle. So let me drag it down there. So let's go ahead and test this out. So I'm going to let the enemy hit me. So you can see the particle played, but actually look, it's actually looping. So it played 3 times before it destroyed itself. So I need to fix that, obviously. So it's one of the settings that I didn't set properly. So let me go ahead and bring out the particle system and open it up. And notice there is this looping option, so let me turn that off so it's not looping, and then apply it back to the prefab. And then, of course, I can delete it out of the world. So let's play again.
Game over.
Okay, that's the exact effect I want. I want it to blow up one time when the player dies. So now that we have the player explosion, we can quickly make additional particle systems for the coin and for the enemy. So I'm going to basically take that prefab and duplicate it, and I'm going to rename it Explode Coin Particle. And you can also edit the properties directly on a prefab. So with the prefab selected, I could come over here to the inspector and make the appropriate changes. So one of the things I want to change is the start size. So rather than 1, I want to make it a little bit smaller. So I'll do 0.2. Let me go down to the emissions. Rather than 20 particles, maybe only 10 for the coins when you run into them. And then at the bottom, the renderer, of course, I don't want the coin to blow up. I want it to be, I don't want the rollerball to blow up. I want it to be the coins. So I can go ahead and click the target, select the pickup mesh, and then change the material. So I'm going to go ahead and use the coin material. So that particle system is now set up. Of course, I probably want a different sound effect on it. So let me go into the audio source, and rather than the player explosion sound effect, I'll use the coin explosion sound effect. And once again, I'll keep the timed object destructor. So let me go to a coin to attach it appropriately. So let me just select one of the coins in the world and go down to the treasure script. It has an explosion prefab option. So let me go ahead and drag the explode coin onto that. So that'll just be on this individual game object. And of course, if I click apply, it'll apply it back to the prefab. So let's go ahead and test.
Game over.
All right, we're starting to get a lot of nice visual effects in our game and sound effects. So lastly, let's do the same for the enemies. So I'm going to go back to my original explode player particle and duplicate this, rename it to explode enemy. I'm going to leave pretty much all the settings the same except for the renderer. So rather than the rollerball mesh, I want it to be a cube. So I'll just select the cube here. And for the material, I want to choose the enemy material. And once again, I'll modify my sound effect. So go down to audio source, select the enemy explosion sound, and leave everything else the same. So now I need to go to my enemy game object and set this up. So there's actually two places that I can place this explosion. One is on damage. So when the enemy runs into the player or into another enemy, I want it to destroy itself. So I can check this self-destroy on impact and then add the enemy particle effect to that. And also on health, so when it loses health, I also want it to play that particle effect. And I notice I made a typo here, so I could go ahead and correct that. Unity's smart enough that it always keeps things linked, which is nice. So let's go ahead and test this. So if I run into one of these guys, we both explode.
In the next video, we'll add a simple animation to our game. Animation is one way to add visual polish to our game. We'll discuss the animation tools in much more detail in the future, but for now, let's just create a simple animation. Our objectives will be to create a simple animated shimmer on the Death Zone game object to communicate the fact that it is dangerous to the player.
Okay, the first thing that I'm going to need to do to create my animation is select the Death Zone game object. Of course, I could find it in the environment, but we haven't actually used the hierarchy search, so let's go ahead and do that. So up here at the top of the hierarchy, I could just start typing death, and there it is. It basically modifies the hierarchy just to select or just to highlight the things that we're searching for. If I cancel out, it will actually show the entire hierarchy and show the actual object that I selected, which is a nice feature. One other nice editor thing that we haven't looked at yet is actually full screening panes. So with your mouse over one of the areas of the editor, you can just hit Shift Spacebar, and it basically makes the scene view, in this case, full screen. And of course, I can do all the things that I do with the scene view, and then hit Shift Spacebar to go back. If I want to highlight the hierarchy, I can do Shift Spacebar over the hierarchy, and it makes that full screen. Shift Space to reduce that. So there's some other nice editor things that you can pick up along the way. So we're going to create an animation. So the game object is selected, and the way that we create an animation is through the animation system. We haven't looked at that yet, so let's go ahead to the window, and you can see there's animation right here. So we're going to open up the animation window, which is Command 6 or Control 6 on Windows. This is a pretty straightforward animation editor, as we'll see. It says to begin animating Death Zone, create an animator and an animation clip. So the way animation works is it attaches an animator component to the game object, and then the animator component uses animation clips to actually create the animation. We'll be looking at animations in much more detail down the road, but we're just going to create a simple animation today. So let me go ahead and click Create. Animation is actually an asset, just like your other assets, so there'll be a file in the project. And I'm going to go ahead and call this my Death Zone Animation. And you can see it actually created a Death Zone animator in my project, and it attached it to my game object. You can see it right here. And it created a Death Zone animation. So it sort of seeded it with one animation. And you can see here in the animator, right now I've got that Death Zone animation showing. There's no data yet, but here it is. And you can create additional clips right here in the interface. But we're just going to have one animation. Working with this animation system, this is where multiple monitors would be nice. But since we don't have that here, I'm going to actually take this window and I could drag on the tab and bring it right down into one of the panes. So now I've got the game view and the animation. So I can actually see this in my standard interface and not have it in a separate window, which is kind of nice when working with animation. The animation editor is pretty straightforward. We've got a timeline here. It goes from basically 0 time to 1 second. It's based on the number of samples, of 60 samples. We can, of course, increase that, but it'll work fine for what we're doing here today. And notice record is hit. So I can, hit that to stop recording. But when the record button is pressed, basically the things that I do in the editor will actually record. So with the Death Zone game object, let me go over to the materials. And I'm going to go ahead and pick the color swatch for the tint of the albedo texture. And let me go ahead and drag this down a little bit to make it slightly darker. And you can see over here in the animation editor, because I'm recording, it actually created a keyframe for the item that I just did. Let me move out in time a little bit. So I can just click up in the timeline. Let's move out to, let's say, 0.2. And open up the editor again. Let me go back to maybe about where it was, kind of a bright red. And there you can see another keyframe was created. And then let me go out a little bit farther to maybe 40 and open up the editor again. And ideally I get the exact same red color because it's going to loop. So I'm just going to eyeball it here about to there. And then let me sample this clip. So press play and you can see it's basically cycling from the dark to the light and back to the dark. And once again, I probably would want to be precise with this to have the exact same color for the looping to take place. Now, this is just one property. I can, of course, edit additional properties. So with the record button still selected, I could go back here and let's say I'm just going to move it down a little bit to -2.1, set that keyframe, come out here to 0.2 again and set it back to -2. Come out a little bit farther and set it to -2.1. And once again, I can play again. And you can see that, it's changing the color and it's slightly moving it up and down a little bit. Okay, so my animation is essentially done. I could untap record, so I'm not recording anymore. And I can switch back to the game view. So if I actually play the game now, you can see that effect is happening.
Game over.
And of course I could go back and play with this additionally. Now one thing of note is, since this has a box collider on it and now we're moving it with animation, we should probably have a rigid body component on the Death Zone just for optimization purposes. So let me go ahead and add the rigid body component. And since we are moving it through animation, we certainly don't want gravity, and we want is kinematic because it is being driven by animation. So that'll just speed up the game due to efficiencies in how the Unity engine works.
In the next video, we'll finish off our game by spawning additional pickups and enemies in the game. The final thing that we will do to make our game more interesting is add spawners for both coins and enemies. This way the game will continually add more coins over time to collect, but at the same time add more enemy to increase the level of challenge. Our objectives will be to create both enemy and coin spawners in the game.
This will reinforce several of the concepts we have discussed across the project.
All right, the first thing that we're going to do is we're going to create our enemy spawner. So to do that, we're just going to create an empty game object to represent the spawner. So I'm just going to get outside of any of the game objects and go ahead and click Create Empty. And I'll name this my enemy spawner. And I'll go ahead and reset the transform just to have it at the 0, 0, 0 location to start out with. And what I'm going to do is I'm going to add a component to this. There's a script that we provided called spawn game objects. So let me go ahead and select that. And what this script is looking for is what prefab to spawn. So I could go to my prefabs folder, and of course I've got my enemy right there. And the minimum seconds between spawning and the maximum, so it picks sort of a random value between these 2 points. So I'll just leave this at the default for now. And then a chase target. So the chase target, of course, will be the rollerball. Okay. So we've got that enemy spawner created. I'm going to go ahead and make this into a prefab. And I could take the one that's now connected to the prefab and let's say drag it up a little bit, maybe put it at about a height of 9 meters off the ground. So they're going to spawn up pretty high, so they'll be pretty bouncy. And let's go ahead and go in the top-down view. And I'm going to put these maybe at the maximum corners of my level. And I'll just kind of eyeball this and duplicate that and move that one over. Duplicate it again. And I'm just putting these in 4 corners, so we'll have 4 enemies spawn locations, places to avoid on the map, of course. And I'm going to get rid of the original enemies in this game object because I don't want to start with enemies, I just want them to spawn out. So I'll get rid of those, and I'll go ahead and put the spawners inside of that empty game object. And of course I could rename it enemy spawners. So let's go ahead and test this. I'll go ahead and hit play. And we can see from the top-down view, there they are. They're spawning into the world. And of course, they got me right away. Once we have all of these enemies, it's going to get a lot more hectic, hence roller madness. And of course, when you get a lot more, they can also start running into each other more, so we'll get a lot more enemy collisions. So let's go ahead and set up our coin spawner now. Since we're going to have multiple coins spawning, let's make them a bit more interesting by having them interact with physics, just like the enemy. So I want to keep my current coins in place, the ones that spin and just stay there. So I'm going to go to the prefab for the coin, and I'm going to duplicate it. And of course, I'll rename it. I'll call it Coin Bouncy, because these are going to be our bouncy coins. So a few things. So the first thing is we need the rigid body to actually fall with gravity for the bouncy coin. So before I edit this too much, let me go ahead and drag out one of the bouncy coins so we can kind of play with it in the editor. So let me just drag it up a little bit and we can kind of see how it behaves. So when I play right now, of course it's going to behave just like the other coins. It's going to just sit there and spin. So let me go ahead and go to the rigid body. Let's turn on gravity and play. Notice it doesn't fall. The reason it doesn't fall is because is kinematic is checked. So once again, we did that before because the coin was purely being driven by the rotator script and not by physics. But we do want physics to actually affect this. So let me turn that off and play again. And you can see it does fall, but it actually fell right through the world. So the reason it fell through the world is because we've got a sphere collider, but the sphere collider is set to is trigger. And we actually want it to be is trigger because that's the way the treasure script works. So when the player once again hits that sphere collider, it triggers the action of collecting the coin. So what we're going to do is we're going to actually add another collider to our coin. So let me go ahead and click Add Component, Physics. There's many different colliders that we can pick. If we wanted to hug the coin exactly, we could pick the Mesh Collider. But I'm going to actually pick the Box Collider. And let's go ahead and zoom in on this, and we can kind of see that, yes, there are 2 colliders. There's the Sphere Collider and the Box Collider. So the Box Collider, we will
leave is trigger is off because we actually want this to, run into the ground or whatever it runs into and bounce. We're going to give it a physics material of bouncy because we want it to be a pretty bouncy object. And let me go ahead and test now. So you can see, yes, it bounces and flips around. So I'm going to do one more change. I'm actually going to remove the rotate script component. So the way we remove a component is we go to the little gear and then we select remove component, of course, because this is going to be driven purely by physics. So if we go ahead and play again, you can see it bounces and then it flips around. Okay, we use the trail renderer, of course, on the player to create that interesting visual effect. So why don't we put a trail renderer on our coin as well? As a shortcut, I'm going to go to the roller ball, which has the trail renderer that we've already set up, and I'm going to copy it. So I'll go ahead and copy this component. Let me go to my bouncy coin, and I could really kind of select anywhere and paste a component as new. So that'll add that component to the inspector or to the game object. And of course, I want to customize this a little bit. I've got the default settings. The trail material actually works well for both of these. And I'm going to change the starting width to a little smaller because the coins are a little bit smaller. So I'll say 0.2 meters. And I want to adjust the colors. So rather than blue, of course, my coins are yellow. So I could go in and pick a yellow color here. Really anything works. I'm going to go ahead and add this as a preset, and I'll just call this my coin color. I guess I maybe already even have this up above. And I'm just going to go through and select the coin color across this. Of course, I can adjust the alphas as I do. So I think that was 200. This one's 150. So once I select the preset, I've got to reset the alpha. This one's 100. So we'll set that to 100. And the final one was 50. So we've got the trail renderer all set up. The last thing is, these coins are going to bounce, and they might actually bounce off the world. And of course, when they bounce off the world, they could continue to exist forever. And, over time, if I'm able to last that long, I would have a whole bunch of bouncy coins that I couldn't even see. So, there's a couple ways of getting around this. One is actually to create maybe a health script for this. But, the way I was going to do it is actually add that timed object destructor to the coins. So let me go to the script and select the timed object destructor. If you remember, this is the script that deletes the game object after a certain point in time. So this will maybe become a game mechanic that the bouncy coins will exist just for 10 seconds. So if I don't collect them quick enough, they'll just disappear from the world. So I go ahead and set that. And we've got our bouncy coin, essentially set up. So I'm going to go ahead and, first let's test it to see if it looks the way we want it to look. You can see it's bouncing, it's got the trail render on it, and so forth. So I'm going to apply that back to the prefab, and I'll go ahead and remove the game object from the world since we've got the prefab set up. And just like we did with the enemy spawners, I need to create a coin spawner. So let me create an empty game object, and I'll call it coin spawner. I'll go ahead and reset the transform back to 0, 0, 0. And I'm going to apply the spawn game objects component. I'm going to set the bouncy coin as the object to spawn. I could modify maybe the time so these will spawn a little quicker. Maybe I'll say between 1 second and 5 seconds. It doesn't have a chase target in the case of this, so I don't need to set that. And now I've got my spawner set up. So I'm going to make this into a prefab by dragging it over. And now that I've got a prefab, I can set several of these out in the world. So let me go ahead and select that. And let's put this up at maybe 9 meters again and get a top-down view so we can place these properly. And I'm just going to drag it over and kind of spawn them around my level. the heck, I'll keep one in the middle, right by the player, and maybe some on the outer edges. So now that I've got my coin spawners all set up, I'm going to create an empty game object to hold those. I'll call this my coin spawners. And I will select each of those and drag them into that game object. And let's see the result. So we can see coins spawning in with their little trails. We can see our enemies spawning around, and you can see it's getting pretty crazy. This is Roller Madness.
Game over.
In the next video, we'll finish up the project. In this video, we'll finish up the Roller Madness project. Our objectives will be to polish the project, add a few features of our own design, do a final build, compress the project, then upload it to the peer review system. To complete this, follow the steps closely listed in the peer review assignment. If you need a review of the process of how to build and upload your project, you can rewatch the Build and Deploy video from the Solar System project. Once you submit your project to the peer review system, make sure to go ahead and do the peer reviews of the other learners' projects. Congratulations, you've reached the end of the third week of Intro to Game Development. If Roller Madness was the first real digital game that you've created, you can now consider yourself a game developer. Next week, we'll unlock a whole new level of what you can do in Unity by beginning to write our own scripts. Onward into game development. In this lecture, I'll talk about learning to program in Unity and what our goals are. Now, I want to speak with the non-programmers for a minute. I truly believe that everyone on the game development team should learn to program, from the traditional programmer to the designer to the artist. Programming is truly empowering. It unlocks the potential that you can solve problems yourself and build things yourself. If you cannot write code, you limit yourself to the will of others on the team. And if you don't have a team, you severely limit what you can do. Learning to program really helps you understand how games are made. From a designer perspective, it allows you to come up with ideas that are not only creative, but technically possible. From an artistic perspective, it allows you to greatly expand your craft. For example, with programming skills, you can go much farther in tools like Maya, not to mention Unity. It also helps you communicate better with the technical team. If you can speak the language of the technical team, not only will they respect you more, you will also be able to communicate in a way that will make their job easier, which in turn makes your life easier. If you become a strong programmer, you open yourself up to many more jobs, including programmer, of course, technical artist, technical designer, and level designer. Lastly, learning to program is very obtainable. I've found that with many of my students that have struggled with programming in the past, when they get to programming within Unity to make games, something clicks in their brains and suddenly they just get it. When it comes to programming, there are many levels of understanding or expertise. It takes effort to move to higher levels of expertise. This graph represents the learning curve, or the amount of effort it takes to move to higher levels of understanding. When you first start with a language, you have a very primitive understanding. This may be where you are right now with Unity and C#. You really have no knowledge of the language, but like in the last two projects, you're able to use other people's code to get things working. But if something doesn't work, you really are stuck. Next, we have a basic understanding. It takes more effort to achieve this level of understanding. Here you have basic knowledge of the language. You understand the syntax and some of the basic commands. With this, you can probably write some basic scripts. You can borrow code and insert it into your own code, but unless it's very basic code, you might not understand it. So if it doesn't work, once again, you're stuck. The amount of effort or the learning curve is the steepest while achieving intermediate understanding. Within this level, you grasp the core language. You can borrow code, understand it, and modify it. But you often must use example code to get started, or at least a good reference to create your own code. The most effort is required to move from intermediate to advanced understanding. With advanced understanding, you can generate complex code from scratch.
You don't really need to borrow code or refer to a reference that often, except when you're doing something out of the ordinary. Going from advanced to expert usually takes time and practice, not necessarily more effort. With expert understanding, you are proficient at writing quality code very quickly. You are the go-to person on the team whenever anyone has a question about how to do something. You understand all the intricate details of the language and of the environment. In terms of programming in C# in Unity, your goal expertise level probably depends on your role on the game development team. As an artist, you should have at least a basic understanding of programming. As a designer, I recommend an intermediate understanding given that you have to be more hands-on with the code and often work closely with the programmers. And of course, as a programmer, I recommend trying to get to an advanced level of understanding as soon as possible and strive to become an expert over time. So what are our goals in this course? Well, first off, this is not a comprehensive programming course. If you have not programmed before and you really want to build your programming knowledge, I encourage you to seek out additional Introduction to Programming courses to complement what you're doing here. However, even if this is the case, I believe this week will be a good introduction to you. You may feel that things are a bit over your head at times, but don't be nervous, don't freak out, just proceed on with the content. With time and practice, things will start to click. If you are a programmer, but are new to Unity and game development, this week's content will be a great introduction for you. What we're going to do is introduce programming in C# within Unity. We'll do this through a number of code walkthroughs that should introduce both beginner and seasoned programmers to the concepts of programming within the Unity environment to make games. Finally, I will hopefully provide you with the resources you need to continue your learning beyond this course. In the next lecture, I'll discuss some important programming concepts in Unity. In this lecture, we'll discuss several programming concepts in Unity. Unity follows an object-oriented approach in the way it's structured and in the way that you write code. I like the object-oriented approach as I think it parallels the way we think about the world around us. Everything is considered an object. For example, a clock is an object in the real world. It has properties such as color, weight, size, and probably most importantly for a clock, what time is it? And it has methods or actions that you can do with it, such as the ability to set the time, the ability to set the alarm, the ability to snooze the alarm, and so on. The same concept can be translated into code. That is, in code, you could have a clock object that has properties or variables that we can reference to determine the current time. The clock object could also have methods or functions to set the time, set the alarm, and so on, for example. When building games in the Unity editor, virtually everything you're working with can be considered an object. The editor makes these objects visual. For example, the scene and hierarchy view visually represent game objects. You can also consider the components that are attached to game objects as a type of object as well, with their own properties and methods, some of which are made visual through the Unity inspector. So for example, this game object has a transform component. The transform component is an object that has position, rotation, and scale properties, as well as methods that you can use to translate or rotate the object. I believe that if you understand what is going on in the Unity editor, you're halfway to understanding how to write code. One important concept in object-oriented programming is that of classes. Classes are templates for creating objects. For example, we could have a clock class that defines how clock objects work. We could then instantiate or create objects from that class. The properties and methods of the objects are defined within the class, but each clock, for example, could have its own color and be set to a different time. Prefabs are one way to visualize this concept in the Unity editor. That is, prefabs are template game objects. We can create many game objects from one prefab. While each game object has their own unique attributes, they are all based off the original prefab template. So now that we know a bit about object-oriented thinking, let's dive into the world of Unity programming. From the Unity editor, you can create a C# script or a JavaScript. We will stick to C# in this course. Personally, I feel that C# is the most feature-rich of the two choices and is the preferred language by the majority of the Unity developer community. As a programmer, becoming an expert in C# will probably serve you best career-wise, even outside of game development. The script that you create becomes a game asset, just like graphics or audio files, and shows up in your project assets. Scripts, when attached to game objects, become components of the game object and appear in the inspector, just like other components. Said another way, a script, which defines a class, is instantiated to become an object when it's attached to a game object. When you create a new script, Unity will give you a template similar to the script shown here. The two using lines at the top just say that this script should use classes from the Unity engine and systems.collections. That is, the namespaces of these two classes should be part of this script. If you're new to C# programming and this doesn't make sense yet, don't worry, just keep the two lines at the top and ignore them for now. The next two lines define the class. The name of the class, basic target mover in this case, needs to be the same name as the file name for the script. The mono behavior means that this class inherits from the mono behavior class. Mono is an open source implementation of Microsoft's .NET framework. Unity scripts are built on top of Mono. What this means is that if you're already a .NET programmer, your knowledge will apply in Unity. If you're not, you'll be building skills as a .NET programmer by programming in Unity. Within the class, you define the variables and functions that make up the details of the class. You can think of variables as properties of a class. If you make variables public, they'll appear as properties of the component within the Unity inspector. For example, here we define two public variables, one of type Boolean called doSpin, which we initially set to true, and one of type float called spinSpeed, which we initially set to 180. These two variables show up in the basic target mover component in the inspector when the script is attached to a game object. You can also create private variables that are used solely within the class. These are not shown in the editor by default. So for example, when we click the play button in the Unity editor, the start event occurs. If this script were attached to a game object in the scene, it would see that the start event occurred and the start function would run. Every time the frame updates, an update event occurs. This will cause the update function to run, and it will run each time the update event occurs, which is typically many times per second. Overall, we can say Unity is an event-driven environment. You often add functions to your classes to respond to events that occur while the game is playing. For example, just like start, there are a few other events that happen when you start playing, including awake, on enable, and start in that order. This is a great place to set things up. During the game event loop, the update and late update events happen in that order. This is a great way to do things or check on things while the game is playing. And there are several other events that you can respond to, such as fixed update for updates that are synchronized with the physics engine, and events for collisions and triggers, as well as events for mouse input on game objects, such as mouse down and mouse up. And there are several other built-in events as well. You can also create and respond to your own custom events. One thing that we do in scripts is modify game objects in some way. When a script is attached to a game object, we can refer to the game object in the script as this.gameObject, or just simply gameObject for short. For example, these two start functions do the same thing. They make the game object that the script is attached to inactive. This is the same thing as clicking the active inactive checkbox in the inspector, except of course it's done dynamically as the game is being played. If we want to reference a game object that the script is not attached to, we can do this in a number of ways. We can have a public variable of type gameObject that we attach to another gameObject or prefab in the Unity editor. We can search for the gameObject using gameObject.find to search for a gameObject by that name, or we can search for the gameObject using gameObject.find with tag to search for a gameObject with a particular tag. All three of these techniques are demonstrated in the script. You can see that once we have the reference to the gameObject, we can call its setActive function in the same way. Once we have a reference to a game object, we often want to modify a component of that game object. Every property that you see in the Unity editor for a component can be referenced and often modified through code. For example, let's say we want to move a game object along the x-axis. We can do this through its transform. In code, we can reference the transform of a game object through the transform property of the game object, or gameObject.transform. The transform property has a position property, which in turn has an x property. So, gameObject.transform.position.x is how we would reference or change the x property of a game object. We could do this in the update function, so the game object moves every frame update. It turns out that the transform class has a built-in translate function that will do essentially the same thing. So alternatively, we could use that to move the game object along the x-axis. Not all components are properties of game objects like transform. To get a reference to other components on a game object, you can use gameObject.getComponent function and then specify the type of the component. Once you do that, you could then manipulate the component. For example, this script gets a reference to the rigid body component attached to the game object and sets it to a variable named RB. It then modifies the useGravity variable, setting it to true or on. If some of the concepts we just discussed are very foreign to you, don't worry, you're learning a new language. Remember, it takes time and effort to get up that learning curve. I recommend jumping into this week's project and then coming back and watching this lecture again. Also remember, Unity has excellent documentation. I recommend that you reference the online documentation often, particularly the scripting reference. Unity also has a vibrant community with a very active forum. If you have a question on how to do something, search the forum. Someone probably already has had that question and you can find an answer. If you can't find an answer, you can always post your own question to the forum and someone will usually get back to you. In the next lesson, we'll begin this week's project. In this project, we'll dive into code and learn how to create our own custom scripts and ultimately our own custom game. The game we will build is called Box Shooter. This first-person game will introduce several new concepts and reinforce several things that we've already learned in Unity 3D. In the game, you'll use traditional first-person shooter controls to shoot a variety of targets. The targets will either increase or decrease your score, or increase or decrease the timer. The game is over when you run out of time. The concepts we will learn include creating custom C# scripts, using MonoDevelop, the IDE that comes with Unity, the link between the Unity editor and the world of code, a few basic debugging techniques, the use of classes, variables, and functions, responding to game events in code, and we'll also learn how to play sounds through code, obtain user input from the keyboard and mouse, instantiate prefabs dynamically during gameplay, update user interface through code, and add image effects to the camera. And we'll learn to use the animator to control animation states. In the end, we'll have a playable first-person game, complete with several scripts that can serve as the basis of a larger game. We will be writing some code in this project. We'll also be doing several code walkthroughs. While some of this may be confusing and perhaps even mind-blowing if you're new to programming, follow along and stick with it. Over time, it will become more clear. As I said, learning a new language takes time and practice. Don't be too hard on yourself in the beginning. Give yourself time and practice. Before you know it, you'll be doing amazing things in Unity with code. As in previous projects, I encourage you to follow along in Unity as you watch the videos, probably even more so since we're writing code. Pick the techniques shown here that work best for you. And remember, you can always go back and rewatch videos, even from previous projects, if a concept has become hazy. In the next video, we'll get our Unity project set up and assets imported. In this video, we'll start creating the Box Shooter game. Our objectives will be to download the assets, start a new Unity project, and import the assets. Okay, go ahead and download the assets for the project from the Coursera website. This will bring down the Box Shooter asset.zip archive, which I'll go ahead and double click on to extract. And we get the Box Shooter asset folder, which contains a Unity package. So I'm going to go ahead and start Unity now. And I want to create a new project. And I'm going to name this Box Shooter. And of course, you could pick the location. It's going to be a 3D project. For purposes of this project, I'm not going to include any of the standard assets via this mechanism. Some of the standard assets are already included in the Unity package that we just downloaded. So let me go ahead and click Create Project. Okay, I've got my empty Unity project here. I'm going to go up to Assets and click Import Custom Package. And I'll navigate to the desktop to find the Box Shooter assets and go ahead and select that Unity package and import it. And this shows all of the assets that are going to be imported, so I'll go ahead and click Import. And this will take a second or two to bring in all the assets. Okay, you can see our project panel now has various folders in it. At the very top, there's an underscore scenes folder, which has a level 1 scene in it. I'm going to go ahead and double click on that, which will load the scene. You can see the scene has a few game objects. It's got this sort of platform with a floor and these sort of bumpers around it. These are the same sort of prototype or prototyping assets that we used in the last project. You can see over in the project we actually do have some standard assets. These came in through the Unity package that we just imported. We have the effects and the prototyping standard assets included. And of course the prototyping assets are what were used to create this very basic level. Just like the previous project, we've arranged the game objects for the environment into an environment empty game object, which serves as its parent. We also have a directional lights empty game object, which you can see there's actually 3 lights included here. So just a sort of basic lighting pattern that we'll use as we work. So this will serve as our basis for the box shooter project.
In the next video, we'll create a target to shoot. Box shooter is all about, you guessed it, shooting boxes. In this video, we'll create the target and write some code to get it moving. Our objectives will be to create a box to serve as a target, write a custom script in MonoDevelop, the script editor that comes with Unity, make public variables that show up in the Unity editor, write code that moves the game object through the transform component, and learn how to quickly access the Unity scripting API reference.
The first thing we'll do is create a target to shoot. So I'm going to go under the hierarchy and go to the Create 3D Objects Cube. And this, of course, will create a basic cube into our world. So I'm going to go ahead and name this cube by hitting the return key with it selected and typing target. And I'm going to move it. So I want to position it to 0, 3, 0 in the world. I also want to scale it up a bit. So I'm going to make it twice the regular size. So I'll set the scale at 2, 2, 2. So it's a slightly bigger target to shoot. And let's go ahead and attach a material. I've included all the materials for you so we don't have to take the time to create materials in this project. So within the materials folder, we have a target positive material. Let's go ahead and drag that onto the target. It'll just turn it a sort of shade of green. So we want to create a script that moves our target. For example, the script could make the target spin along the y-axis. Of course, we could simulate this in the editor through the transform component. So if I go up to the rotation in the y, I can just click and then drag back and forth and kind of simulate how the script might actually spin this item. I'll go ahead and undo that. So to create a script, there's a variety of techniques. One of those is with the game object selected, I could go to Add Component and scroll all the way down where it says New Script. This will let me name the script right here, so I'm going to name this Basic Mover, no spaces, and it lets me select the language. In this case, I'm going to stick with the default of C# and click Create and Add. This will actually create a script file, so you can see up in my project assets, it created a file named Basic Mover. It put it right here at the top level. For organizational purposes, typically I like to keep my scripts in a script folder. So I'll go ahead and drag and drop it into the script folder, and you can see there's a number of scripts in here already. It also attached that script to the target game object. So I need to edit this script. There's a variety of ways of doing that. We could just double click on the script. This will open MonoDevelop. MonoDevelop is the default integrated development environment or script editor that comes with Unity. You are welcome to use other IDEs such as Visual Studio, but I'll stick with MonoDevelop in this class. So whenever you create a new script in Unity, it will populate it with a standard script template. So at the top, you'll see that it's got using Unity Engine, using system.collections. For now, we'll just leave those alone. We always define a public class for the script with C#, which extends the MonoDevelop class. You can notice the name here, Basic Mover, is the name of the file name, minus the extension, of course. And the file name and the name of the class always need to be the same. And inside of the curly brackets for the class are the actual meat and potatoes of this class. And you can see this is pre-populated with 2 functions, the start function, which of course responds to the start event, and the update function, which of course responds to the update event. So let's write a little code. I don't need an actual start function, so I'm going to go ahead and delete that out of the template that was given to me. And I'm going to go ahead and create a public variable right here at the top inside of the class definition. So I'll make it public. It's going to be a float, type float. And the variable name is going to be spin speed. I always like to use lower camel casing for my variable names, so I start with a lowercase letter, and then between each word, we can't put spaces, of course, when we're naming variables or functions, so I use a capital letter. So spin speed is easy to recognize. For class names, like you see at the top, we typically want to start with an upper camel case, so an uppercase first letter, and then, of course, each subsequent word is another uppercase letter. So a public float spin speed, I'm going to set it equal to an initial default value, so I'll equal to 180.0 f for a floating point number, and end this line with a semicolon. And then down in my update function, I'm just going to write some code here, and then we'll talk a little bit about it. So I'm going to type game object. Notice that MonoDevelop does code completion for us. It gives us, as we type, various options that we can select from. And in this case, I want it to say game capital object. So I could just hit return to make that a little bit quicker. Dot, and I want to get at the transform component for this game object. So dot transform. And what I want to do is rotate it, just like we saw there in the editor. So I'll do a dot, and then you can see that there's a variety of options here. If I scroll all the way down to the R's, you'll see there is a rotate method or function. So I'll do that. Start it with open parentheses and put in the arguments that I need to pass to this method. So I'm going to type vector3 dot up times spin speed times time, capital T time, dot delta time, closing parenthesis, semicolon. Okay, so there's maybe a lot of complexity there if you're new to programming, but we'll go ahead and talk through a little bit of this. One thing to note is when you're working with Unity, of course we're writing in C#, but a lot of what we're doing is accessing the Unity API. So even if you're familiar with C#, some of the details here may be confusing to you. But hopefully now that we know the Unity editor, it starts to make sense. So we're referring to a game object, the game object that this script is attached to. We're then referring to the transform component of that game object. And the transform component has a variety of methods of things that you can do with it. So with that selected, under help, I can select Unity API reference, or notice it's command apostrophe here on the Mac or control apostrophe on Windows. So let me select that and say Unity API reference. This will bring up the scripting API reference. This is an excellent resource that I recommend that you check religiously as you write code in Unity. And it does a search for me on transform, and you can see we've got a variety of results here. Often it's toward the top, maybe the first in this case. Let me hit transform, and you can see it describes what a transform is in scripting terminology, because I'm in the scripting manual, or the scripting API reference, not the manual. If I wanted to look at the transform component, I would click on manual and look at that there. But for scripting, I'll stay in the scripting API reference. So you can see that it talks about it's the position, rotation, and scale of an object. Every object in a scene has a transform, and it talks about all the variables that are attached to the transform. So for example, we can get the up direction of this particular transform, and then all the public functions or methods for this transform. So you can see right here is the rotate, which is the function that we just used. So if I click on rotate, I can then get reference on using the rotate function. And a lot of times there's actual example code, so you can see how the function might even be used. I find this very useful as I'm actually writing code of my own. So let's go ahead and switch back to MonoDevelop. We've been editing the script, but I haven't saved it. In MonoDevelop, there's always a little asterisk next to the file name if you haven't saved it. One of the common mistakes people make is they edit the script, they go back to Unity and they forget to save it, and then they're wondering why their script isn't working or why it didn't change. So make sure to always file save or Command S or Control S on Windows. So I'll go ahead and save it. The asterisk goes away. Let me switch back to Unity. And you can see now in my target game object, I've got the basic mover. It added the spin speed. So the public float variable that we created got mapped here to the editor. So if I go back to my script, you can see we called it spin speed, no space. The editor tries to make things a little bit more human friendly, so you can see it took that variable name and it capitalized and made a space. This is something that maybe drives programmers crazy, but I think it's friendly for designers and artists that are working just exclusively in the editor. And you can see our default value of 180 is actually present here. So let me go ahead and press play. And you can see our target is spinning. Over here in the editor and the inspector, you could dynamically see the rotation is changing. This is spinning at a speed of 180 degrees per second. So every second it halfway rotates around. And of course, dynamically while it's playing, I could change this so I can go up to 360 degrees. So now it's moving twice as fast. I can go down to 10 degrees. And of course, I'm in play mode, so I'm just experimenting. As soon as I press play to stop playing, it will go back to 180. So if I wanted to change that, I would do that here. So in the editor, we can actually override the default values. So even though in the script I defined this as 180 initially, because I changed this in the editor, it will reflect that change upon the next playback.
In the next video, we'll continue to set up our movable target while learning more about scripting in Unity. In this video, we'll continue to set up our movable target. Our objectives will be to identify and resolve script errors using the Unity console, use Booleans and if statements to create more complex logic in our code, identify the link between the script file name and the class name, expand our script, and discuss scaling operations based on the speed of the computer.
Okay, let's go back to MonoDevelop. And let's say I make a mistake. A lot of times we make mistakes when we're writing code because they need to be so exact. So at the top, we defined our variable name as spin speed. Let's say down below here in the update function, I misspelled this. So maybe I missed an E, so I said spin sped. Notice MonoDevelop helps us. It recognizes that there isn't a variable called spin sped, and it makes this red to sort of notify us of that. But let's say we don't notice that as we're typing. I'm going to go ahead and save my script. Let's go back to Unity. So Unity immediately compiles the scripts when they change, and you can see down at the bottom of our editor, we get an error message. So if you click on that error message, it'll bring up the console. The console is a very useful tool when you're writing code in Unity. You can see the error message is listed here. It says the name SpinSped does not exist in the current context. That's a fancy way of saying it doesn't know what that means. And you can see there's various other error messages. A lot of times the first error message causes subsequent error messages. So if we resolve the first one, the rest of these will likely go away. So a shortcut, you can actually double click on the error message and it will bring up MonoDevelop and actually move the cursor to the line where the error took place. Now that doesn't always mean that that's where the source of the problem is. The source of the problem may be above that line, but at least it helps you somewhat isolate where the issue is. So of course, if I go and change this back to spin speed, it changes black here. If I save it and then go back to the Unity editor, it'll recompile the script and notice the error messages went away. So I'll go ahead and close the console and go back to MonoDevelop once again. So I'm going to modify this script to also move the game object. So at the top, just like before, I'm going to create another variable. So I'll type public float because it's going to be of type float. And I'm going to type motion magnitude. So once again, I'll follow that lower camel casing. I'll set this equal to initial value of 0.1 f for a floating point number and end the line with a semicolon. And then down below here, it might be nice to add a comment. So let me hit return and let's add a comment before this line of code, which we can do a / to create a comment. And then we'll type rotate around the up axis of the game object. We won't spend a lot of time on the math involved, but basically a vector 3 up is 0, 1, 0. So we're multiplying that by the spin speed, which we defined above, which will affect just the y, since that's the only one that's not 0, and then times time.delta time. So time.delta time is the amount of time that's changed between the last frame update and this frame update. This is typically a fraction of a second. So we were running typically at 60 or more frames per second. So when we multiply that, that's the fraction of the spin speed in the up direction changing per fraction of a second. So let's go ahead and actually write some code to move our game object. So I'll hit return twice just to make a little bit of extra space. I'll write another comment. And I'll say move up and down over time. Okay, so that's my human readable version. Now I need to write the C# code. So just like above, I'll start with the game object dot transform because I'm going to be modifying the transform component dot, and I'm going to use the translate method or the translate function of the transform. So the translate works very much like the rotate function in that it accepts a vector 3. The vector 3 in this case defines the vector to move the game object within this time step. So I'll do the open paren. I'm going to do vector 3 up once again because I'm going to move in the vertical direction. And once again, we don't have to be too concerned with the math here, but I'm going to say times math f, which is a built-in class that has math operations, dot cos for cosine. Do another open paren. I'm going to do time dot time sense level load. And we'll end that with the end paren to end the cosine operation times the motion magnitude variable that we defined at the top. And I'll do another end paren. Notice it does a little highlighting here to let us know which one we're matching up with, so we can make sure that our parentheses are balanced. And then we'll end that line of code with a semicolon. So once again, we don't have to spend too long on the math, but what this is doing is it's going to translate the game object through the transform in the up direction. And the cosine function, what that does is it basically makes sort of a wave pattern. So our game object will go up over time, and then it'll come down over time, then back up, and then back down. And this is multiplied by the motion magnitude, which defines the sort of magnitude of that wave that goes up and down. So let me go ahead and save this and go back to Unity. You can see that our basic mover, once it compiles, updates. So we've got spin speed now and motion magnitude. If I hit play, we'll see that our target is now spinning as before, and it's moving up and down, just as we wanted. So now our script does two things. It rotates and it translates. And of course, I can set one of these to 0. So if I didn't want to spin, maybe I'll set spin to 0 and just leave the motion magnitude set. So when I press play here, notice it's not spinning, it's just going up and down, and vice versa. I could make this 180 again and make this 0 and press play, and you can see it's going to spin, but it's not going to move. But perhaps I wanted to make this a little bit more clear for my designers, if I'm the programmer working with a designer or working with an artist. So let me go back into my script. First, I'll set this back to 0.1, so it both spins and moves. Let me go back into the script. And let's create a couple variables at the top again. So let me do a public bool do spin. So this is going to be a boolean called do spin. Booleans are either set to true or false. So I'm going to set this initially to true, and then I'll do another public bool and say do motion and set this equal to false. Okay, so these are going to be controls that our script will look at to decide if it's going to do the rotation or the spin. So down here in the update function, we'll just create an if, open paren, do spin, close paren. So that's basically saying if do spin is set to true, in sort of shorthand, we'll do the curly bracket. And I like to tab these over for formatting purposes, and then close that. So of course, this is our sort of control logic. So if we're spinning, then we should do the spin code. And then down below, I'll say if do motion, and I'll tab these over. Okay, so if do motion is true, then it's going to do the do motion code. And of course, this ends this. And once again, these always match up, or they need to match up. So if you select it, you can always make sure that the parentheses all balance out. If you miss one, you're going to get an error back in Unity. So let me save this, go back to the Unity editor. You can see once our script updates, now we've got do spin and do motion. Do spin was initially true, so that's checked. Do motion was false, so that's not checked. So you can see the sort of mapping of variables, floating points up here and booleans down here to create the sort of nice editor look that our designers and our artists and even our programmers get. So let me go ahead and press play. You can see we're spinning. If I uncheck do spin, it stops spinning. And then if I check do motion, it'll do the motion. Okay, so we've been building up the functionality of our basic mover. Let's say that, we decide we didn't like the initial file name that we picked. Maybe I think this is for target, so I want to call this basic target mover. So let me go ahead and rename this basic target mover, as I can do right in the editor. And then let me go ahead and hit play. And you can see that I get an error message. It says the reference script on the behavior is missing. What do you mean? If I go back to the target, you can see that we don't see our parameters here anymore. It does say that it's still attached to the basic target mover. But remember, the class name of the script has to match the file name. So if I double click on this to go back to the editor, notice this is called basic mover class and the file name is basic target mover. So these have to be the same. So I either need to change the file name back or I need to change the class name right here. Let me just change the class name to basic target mover. Go ahead and save that. Go back to Unity. Once it recompiles, we have our variables once again, and we're back in business.
When we make a game, we don't want the speed of the game to be tied to the speed of the processor on the computing device. For example, on a slow performing computer, perhaps our game runs at 15 frames per second. On a medium performance computer, 30 frames per second, and on a fast computer, 60 frames per second. If the speed of the game is tied to the frame rate, the game would run at half speed on the slow computer, normal speed on the medium performance computer, and double speed on the fast computer. This may make the game unplayable on the fast computer and too easy on the slow computer. To solve this problem, it's important to scale the updates that are made each frame by the amount of time that has passed between frames. We saw this technique in the target mover script that we've been writing. Time.delta time is the time in seconds that it took to finish the last frame. This is typically a fraction of a second. With the rotate operation, we determine how far we want to rotate in 1 second, and then multiply this by time.delta time to get the amount of movement that should occur in the current time step. That way, if the game runs at 15 frames per second, the game object will rotate at the same speed as if the game ran at 30 frames per second or 60. The motion would just be smoother on the faster frame rate. The concept of scaling an operation by time is an important one in game development. In the next video, we'll explore a more complex target mover script. In this video, we'll finish setting up our movable target. Our objectives will be to examine a more complex target mover script and build the prefab for our target game object.
So it turns out I've already written a target mover, a little bit more sophisticated one for you. So let me go ahead and remove the basic target mover by clicking the little gear and saying remove component. And let's go ahead and add a component. Go down to scripts and choose target mover. So this looks very similar to what we had before. You can see there's a spin speed and a motion magnitude. The one difference is I've got this motion state at the top. So here we can pick either horizontal or vertical motion or spin, because I want my target mover to just do one of these three states, not a combination of them. So for example, let me pick spin, press play, and we spin. If I switch this to horizontal and press play, it's going to move in the horizontal direction. And then if I switch this to vertical and press play, it's going to move in the vertical direction as we saw before. So just really quickly, if I go into that script, you can see it's very similar. We've got the floats at the top for spin speed and magnitude. The one difference is we've defined two other variables. The first being an enumeration. So public enum is a new data type that we haven't seen before. The variable is called motion direction, or motion directions. And we define a list of possible directions. So you can see spin, comma, horizontal, comma, vertical, all within the curly brackets. Down below, we store the state. So we make a public motion directions. So this is the variable type we just defined above. We call it motion state. And we set it equal to the initial motion state, motion directions.horizontal. So the way we refer to these different states is through the name of the enumeration dot and then the name of the particular item. So down below in the function, we use a switch statement rather than an if statement. Switch statements are great when you have a multiple state system, as we do here. So motion state can be one of three different cases. So you can see there's a case for spin. This runs the spin code. We have a case for horizontal. This runs the horizontal code, which is exactly the same as the vertical code. except we're using the vector3 right. So this will modify it along the x-axis rather than the y-axis, and then the vertical code, which of course translates along the up axis. Okay, let me go back to Unity, and we've got our basic target set up. So let me go ahead and drag it over to the prefabs to make it into a prefab. So you can see now we've got a third prefab here of target, and I'm going to go ahead and remove my target from the scene for now. And we'll save our scene.
In the next video, we'll set up our first-person player. In this video, we'll set up the player game object. Our objectives will be to create a game object for the player, attach the character controller component so that the player interacts with physics, use a simple but useful debugging technique, learn about the input class and the input manager, and explore a script that makes the player controllable through the keyboard.
Okay, we need to create a game object to represent our player. This is going to be a first-person game, of course, so we won't actually see our player, but we still need a game object to basically hold everything for the player and be the object that interacts with physics for our player. So under Create, I'm going to go down to 3D Objects, and we can pick one of these standard geometric shapes, and it turns out that the capsule is actually a really nice geometric shape to represent players. So I'm going to select Capsule. And you can see it created this little capsule out in the world. It sort of looks like a Tic Tac. Let me hit F to zoom in. And I want to position this just right on the world. So I'm going to set it to 0, 1, 0. And I can hit F again to zoom to it. Now I want to name this capsule Player. So I'll rename my game object as Player. And I also want to tag it for future scripting reasons. So under the tag editor, there actually is a pre-created tag for Player. It's built in. So let me go ahead and tag this as Player. Now the player is going to interact with physics, but instead of attaching a rigid body component, there's a special physics component in Unity for character controllers. Let's go ahead and attach that. So let me click on Add Component, go down to Physics, and pick Character Controller. So the character controller defines numerous properties of how the character will interact with physics. For now, I'm just going to go ahead and stick with the default. So if I click Play now, and then perhaps use the WASD keys or the arrow keys, notice that nothing happens. The character's not actually moving. Why is that? The character controller component just defines the physics interactions for the player. It does not actually accept input and move the player. We need to write a script to do that. So let's go ahead and stop, and let's create a script. So I'll create the script this time in a different way, not going through the Add Component. Let me click on Scripts here in the project, and then go to Create, C# Script. Because I selected the scripts folder when I create it, it will place it right in that folder. Now it starts with a default name, a new behavior script. If I change the name right away, it will actually update the script template to reflect that new name. So let me type basic controller. Now if you make a mistake and accidentally hit return first, it's going to actually set the script with the class name of whatever was typed. So if you modify the name here, you'd have to then modify it back in the editor to reflect the same name as we showed before. So let me go ahead and double click on this script. Once again, this gives us the standard template for the script. Let me go ahead and get rid of start because I'm just going to use the update function. And let me just type a line of code. I'm going to type capital D debug dot capital L log open parenthesis. Then I'm going to type quote horizontal input equals, in quote, plus input dot get access, open parenthesis, quote, horizontal, capital, with a horizontal, in quote, inpren, which ends the get access function, and then another inpren that ends the debug.log function, and then semicolon to end the line. So debug.log is a great way to place output into the console during playback. It's probably the most basic debugging technique to determine what's actually going on in your code. So what is this code actually doing? On every update, we are outputting the current horizontal access value from the input class. So you can see debug.log is what outputs the information. Horizontal input is just a string that we're going to output. So it's going to say horizontal input equals. And then right here is the magic sauce. This is what is actually getting information from our input and then outputting that value to the editor. So let's save this script. So I'll Command S, go back to Unity, and let's see what is actually happening here. So I created the script, it's in my script folder, but if I go to the player, it's not actually attached yet. So let's go ahead and attach that. I'll drag Basic Controller onto it, and let's hit play. And you can see it says down here at the bottom, horizontal input equals 0. Now if I hit A or D or the left arrow and the right arrow, you can see that the inputs are changing. And let me go ahead and hit stop, and let's click on this. So here is the console. And basically every frame update, if I scroll back through time, is outputting that line of code. Horizontal input equals, and then the value. So we can see as the program played out, all of the output that was actually derived from that debug.log. Let me go ahead and close this. So the input.getAccess horizontal is basically looking at the horizontal access. So what does that mean? If I go under Edit, Project Settings, Input, this will bring up the Input Manager in the inspector. Let me open the axes here, and you can see there's horizontal right at the top. Let me open that. So this defines the horizontal input. It's looking for either the left or right arrow. That's what left and right mean for negative and positive. And the alternate inputs are A and D. And there's various other settings here as well for other forms of input, such as joystick input. Verticals down below, the same sort of thing. The negative button is the down arrow. The positive button is the up arrow. The negative alternate button is S, and the positive alternate button is W, and so forth. And you can see there's a variety of other things defined: Fire 1, Fire 2, Jump, Mouse X, Mouse Y, and so forth. So the Input Manager defines these basic sort of inputs. We'll be using them throughout the project today. And you could define new inputs, or you could even remap the inputs that are here to different keys if you so choose. Okay, I'm going to go back to the player now, and let me go ahead and remove the basic controller script. And I've got a full-blown controller script over in my scripts folder. So let me go and drag and drop it onto the game object. So without further ado, let's go ahead and test this. I'm going to go ahead and hit play. Hit W down here in the game view. Notice I move forward. Hit S. It goes back. A goes to the left. D, it goes to the right. So I've got basic controls now for my little capsule. So let me go ahead and double click on the controller. Just as a quick code walkthrough, notice that at the top we've got a couple variables, one for move speed and one for the gravity amount. We also have a private variable, so private variables are just variables accessible within this class. They don't show up in the editor. So back in Unity, notice that we don't have that third variable here. We just have motion speed and gravity. So that private variable is looking for a character controller. This is the physics component that's actually attached to this game object. And this creates a variable name, but it's not set to anything. So what we do in the start operation, which only runs once when this game object first starts up, we look for the component called character controller within the game object. So this is the code to do that. GameObject.getComponent, the less than and the more than sign. We define the name of the component and then open and close parenthesis. We set the result of that to that variable name. So once we have that stored as a variable, we can then do operations on the character controller. Most notably down here, we do a move operation. So myController.move is a function of the character controller. So what happens every update frame is we do a number of calculations to determine the Z movement direction based on the vertical input axis, the X movement direction based on the horizontal input axis. We then remap those vectors from local space to world space. We apply gravity, and we output this through a debug.log message. So I'm going to comment that out because I don't always want to output that to the console. And then we actually do the move operation. So let me go ahead and hit save. So within these scripts that I provided, I tried to provide reasonable documentation. Remember, as you're looking at things, you can always select things. For example, I could select input and go up under help, Unity API reference to look up the reference on the input class in this case. Or vector3, you can select that, go up to help, Unity API reference will open up the vector3 reference.
In the next video, we'll set up the camera.
this video, we'll set up our camera to behave and control as we would expect in a first-person shooter game. Our objectives will be to get the camera to follow the player and respond to mouse input. We'll also apply a number of rendering and image effects to the camera, including a skybox, contrast, and bloom effect. And we'll add our game music to the camera. So how do we make the camera follow the player? Given this is a first-person game, it probably makes the most sense to make the camera a child of the player game object. So let's go ahead and move the camera. So let me do a top-down view and we can look at the relationship of the camera right now. And it's a little ways away in the Z direction, so it's -10 where the player is at 0. So let me move it to 0. So it's right on the player. And once again, we can look at it now. You can see that it's quite a ways above the player. So let me move it down. I could visually move it here in the editor down, or I could just do it numerically. So through play, I want to put it right at the top of the head. The player is 2 meters high, so I'm going to set it at 2.1. So the camera will be right there mounted sort of to the top of the player. So now that I got my camera positioned properly, I'm going to make it a child of the player. So let me just drag the main camera right into the player. And boom, we've got it as a child. So let's go ahead and play to test this out. So now when I move the player using the WASD keys, forward and back, left and right, you can see the camera moves right along with it, as you would expect. So the other thing that would be nice is the ability to actually look around using the mouse. So let me hit stop. And I've included a script called Mouse Looker, which you attach actually to the player. So let's go to the player, click Add Component, go down to Scripts, and choose Mouse Looker. This script was adapted from a script provided with the standard assets. It will change which way the player is facing and rotate the camera up and down based on the mouse input. So let's go ahead and try that out. So hit play. So you can see I can move my mouse up and down. As I spin, it's actually rotating my player. And of course, I continue to use the W, S, A, and D. So I've got pretty much a standard sort of first-person control now on my character. So the Mouse Looker script also locks the mouse to the middle of the screen and makes it invisible. If you press the Escape key on the keyboard, you can get the mouse cursor back. You'll need to do this to be able to click on the play button in the Unity editor to stop playing. So let me go ahead and hit Escape. Now I've got my mouse cursor back. I can go up and hit stop. The Mouse Looker script is a fairly complex script, so for now we won't do a code walkthrough, but you're welcome to take a look at it if you so choose. So while we're working on the camera, let's improve the visuals that the camera is producing, starting with adding a skybox. In our first project, we added a skybox through the lighting window, which of course is under Window, Lighting, and this is where it defines the skybox, this default skybox that we're seeing with the sky and the moon and so forth. So we can change the skybox there, but you can also change the skybox on an individual camera. So perhaps in your game, maybe you have multiple cameras and you want them to have different skyboxes, for example. So let me do it the other way for purposes of example. So I'll go ahead and close lighting, go to main camera, and I'm going to add a component, go down to rendering, and notice there's a skybox component that we can add. And it just takes a material. So I've actually got the skybox material created. Let me click on that. You can see it's a standard skybox, a 6-sided skybox like we saw in the first project, and it's just got a grid texture in all 6 sides. So back on the camera, let's go ahead and drag that material onto the custom skybox. And down here in the scene view, you can see the changes reflected. Now, when you apply it to a camera, you're going to see it in the game view, but it's not going to change in the scene view. So we still see that default skybox in the scene view. So if we wanted to get rid of that, we can go to the lighting window and hit the target for the skybox, and then maybe select none as an example. And you can see it just got rid of the skybox in the scene view. There are a number of image effects that we can enhance the look of what is rendered on the camera. Let's apply some of the image effects. Now, the image effects came in through the effects standard assets that were included with that package we brought in. So you can see effects and then image effects here. But usually these scripts and other things are mapped right into the Unity interface. So on the camera, let me go ahead and click Add Component. You can see if I scroll down, there's an image effects option here. Let me select that. And we're going to apply 2 different image effects, starting with Contrast Enhance. So this is under Color Adjustments, and we'll select Contrast Enhance. And you can see the effect takes place immediately in the game view. So if I turn this off and back on, you can see it's just sort of brightening up the world a little bit. I'm going to make it a little bit more intense, so the intensity is 0.5. Let me go ahead and move that up to 1. And it's just giving our world a little bit more of a Tron-ish feel, if that's a word. Let me go ahead and add an additional component. Once again, go down to Image Effects, and I'm going to do Bloom and Glow, and I'm going to choose the Bloom effect. This has got a lot of different parameters. I'm just going to leave it at mostly the defaults. I'm just going to change the bloom intensity from 0.5 to 2. And if I click this on and off, you can see the effect that that bloom intensity has over the contrast enhance. Okay, I'm going to go ahead and close these up. And we also want to have our background music playing on our camera, because once again, the camera has the audio listener, and the audio listener goes wherever the camera goes. So let's go ahead and add an audio source. So I'll add component, audio, pick audio source. I need to specify the audio clip. I provided a number of audio clips that we can use for this project, including background music. Let's go ahead and drop that on audio clip. And for me, I'm going to change the volume down to 0.25, so this isn't too loud. You can set the volume as you see fit. I'm also going to change the pitch. So the pitch is typically 1. I'm going to make the pitch a little bit higher, which will just make the music sound a little bit more upbeat. So I'll change it to 1.2. And let's go ahead and play to see the result. So we can walk around. We hear the music playing. We've got this enhanced view of our camera with the skybox and the contrast enhance and the bloom. Notice as I look down, you can see a little bit of that capsule collider, so we want to get rid of that. We don't want to actually see our player, and we probably don't want the shadow either for our player. So once again, to get out of play mode, I hit escape. I get my mouse cursor back, and I can go up and hit play to stop playing. So let me go to the player, and I'm going to turn off the mesh renderer. So the mesh renderer is what actually renders the game object. So I can turn that off. Notice here in my scene view, we can still see the capsule collider. We still want the collider to exist. If I hit play again, you can see I no longer have a shadow. I no longer can see the capsules as I look down, but it is actually keeping me within the confines of these bumpers. Let me go ahead and stop. Now that I have my player set up, I want to make it into a prefab, so let me go ahead and drag player into the prefab folder. And it brings the camera right along as a child of the player. And let's go ahead and save our scene.
In the next video, we'll set up the projectile that will shoot in our game. In this video, we'll set up the projectile game object and prefab. Our objectives will be to create the projectile game object, apply the rigid body component as it will be driven through the physics engine, and then add a trail renderer for visual effect. Finally, we'll create a prefab for the projectile since we'll be shooting a lot of these in our game.
Okay, our projectile is just going to be a small sphere, so let's go ahead and create a sphere. So create 3D object sphere. It created there in my world. Let me go ahead and tap F to zoom in on it, and I'm going to rename it. Click on the hierarchy, rename it projectile. And I'm going to apply the projectile material. So once again, I've got the materials pre-created. So let me go ahead and just drag the projectile material onto the projectile. So I want to make my sphere smaller. Right now it's just a standard 1 by 1 by 1 size. So let me go ahead and make this quite a bit smaller. So I'm going to make it 0.2, 0.2, 0.2. So it's just going to be a little ball that we're going to project across the world. Eventually, we are going to apply a force to the projectile, so essentially it shoots across the world. Therefore, we need to attach a rigid body component so that it interacts with physics. So let's go ahead and do that under Add Component, Physics. Let's make it a rigid body. However, we don't want it to fall with gravity. I mean, you could have a projectile that you shoot and it arcs with gravity. But for our game, I just want it to shoot and not be affected by gravity. So let me go ahead and turn off gravity. And let's also add a trail render to the projectile to create a trail effect behind it. So let's go ahead and say Add Component, choose Effects, and Trail Renderer. So the first thing that I want to do is I want to set the material. And I didn't actually create a material for this, but there's a nice built-in material called Default Particle that we can use. So let me hit the target to bring up all the materials that are in the project and the defaults. So at the bottom here, you can see there's a default particle. So let me select that. Okay, we're just going to tweak a couple parameters. So the start width is 1 meter. Let me make this 0.1 to make it quite a bit smaller. and we'll end it at 0, so it'll trail off to nothing. And let's go ahead and modify the colors as well. So right now they default to just white. Let me click on that first color to bring up the color picker. And I'm going to set the color as sort of an aqua color. So once again, I've got a pre-made hex value, so we can all be the same if we want to be. So let me do 00 FF D FFF. Okay, so we've got this aqua color. I'm going to go ahead and preset this here down in the presets. Let me click the little add new preset button, and I'll name this my aqua color because we're going to use this a number of times across this project. And I'll leave the alpha as 255. So let's go ahead and close that. And then for each color, I'll pick the same aqua color, but I'll continually move the alpha down. So this one I'll make 200 alpha, so it's slightly transparent. The next one we'll do aqua color, make it at 150. And the third one, aqua color, 100. And the last one, aqua color, and 50. Okay, my projectile is set up, so let's go ahead and drag it to the prefabs to make it into a prefab. And I'll go ahead and remove it from the world and save my scene.
In the next video, we'll start shooting projectiles. In this video, we'll add a few targets to our scene and give our player the ability to shoot projectiles. Our objectives will be to add a few targets to our scene and apply the shooter script so we can shoot projectiles. We'll examine this script and make sure the projectiles destroy themselves after a period of time to keep our game running smoothly.
Okay, we want to create 3 targets out in front of the player to have targets to shoot at. Notice my scene view right now is not the same as my game view, and you can actually see the camera there. So I want to align my scene view to my game view. A quick way to do that is actually to select the main camera and then go under Game Object, Align View to Selected. So this is sort of the opposite of what we've done in the past. You know, sometimes we've aligned the camera to the scene view. This time we're aligning the scene view to the camera. So let me clean up my folders here a little bit, just close them up. And within prefabs, we've got that target that we've created. So let me drag it out here into the world, and you can see it there in the game view. So I'm going to position this at 0 in the X direction, 6 high, and 10 meters out in the Z direction. And I'm going to set the mover for this target as spin. And then I'm going to go ahead and duplicate this target. So I'll just hit Command D or Control D. And then holding down the Command key, remember we can drag along the axis and it will snap to whatever our snap settings are, which they default to 1 meter. So let me go ahead and move this to 8 units out in the X direction. And I'll go ahead and make this one move vertically and go back to the original target and duplicate. And then let's move it in the other direction, holding down the Command key so it snaps to -8. So they're sort of on each, 1 in the middle and 2 on the sides. And I'm going to make this one to move horizontally. So if I go ahead and hit play, you can see we've got 3 targets now, each moving in a different fashion. I'll go ahead and stop. So let's go ahead and create an empty game object to hold our targets. So let me go ahead and set create empty, and I'm going to rename this targets. And it's always a good idea to reset the transform when you're making a parent game object once again, so all of the children's coordinate systems are really the same as the world coordinate system. It's not a requirement, but it generally helps, I find, in most cases. So let me go ahead and reset that, and let's select the 3 targets and then drag them into that target's game object. Okay, now we want to actually shoot our projectile. So the question is, where do we shoot from? Now, it probably makes the most sense in our game to shoot right from the camera, because the camera, if I click F, is basically our vision out into the world. So we want to shoot basically right down this Z-axis of the camera. So it's coming right out of the middle of the screen. So I've actually already included the shooter script. We'll go ahead and attach that and take a look at it. So here in the camera, let me click Add Component, go down to Scripts, and let's pick Shooter. You can see it's looking for a projectile or a game object or a prefab as a starting point. So let me go ahead and set that projectile prefab as the projectile. And then it's also looking for a shoot sound effect. So let me go ahead and pick the laser as the shoot sound effect. So let's go ahead and check this out. So of course we still have our controller moving back and forth, left and right, up and down using the mouse. And clicking the left mouse button, I can now shoot, or I can hit the space bar to shoot. And you can see the projectiles go out and hit the targets and they bounce around. They're moving really rather slow, but it creates kind of an interesting effect here with the bouncing and the trail render and so forth. So let me go ahead and click escape to get my mouse cursor back and stop. And let's modify the power. So the power is how quickly the projectile moves. So let me move this from 10 and let's go up to 200. And let's click play to check it out. You can see the projectiles now are flying very quickly, which is really the effect that I want in this game. So let me go ahead and stop. And let's do a quick code walkthrough of the shooter script. So I'll double click on it. Once again, in the editor, we set the projectile, and you can see how that's done here. So we have public, and then we have the variable type as game object, and the variable name is projectile. So when we make a variable name of game object, we can attach a game object or a prefab to that, because of course the prefab is a template of a game object. As before, we've got another floating point that defines the power. And then we also have an audio clip. So when we have audio clip, we can actually attach, in the editor, we can attach an audio clip game asset. And of course, shoot FX is the variable name that would then refer to that audio clip. All the magic happens down in the update function. So you can see we're using the input class once again. Rather than get access, we're getting button down. We're looking at the fire one. If you remember back in the input manager, we saw fire one and we saw jump. So fire one is mapped to the left mouse button and jump is mapped to the space bar on the keyboard. So if we hit either the mouse button or the space bar, then we're going to do the code that's down below. So if a projectile is defined above, this is sort of a shortcut. Basically means the same thing as if projectile is not equal to null. Null means nothing. So if we haven't actually set this up, if we haven't actually attached a projectile, it would equal null, in which case we don't want to actually project nothing, or else we'll get a null reference, which is generally a bad thing when a Unity project is running. So we do a little check here to see if the projectile is actually set up. And if it is, then we instantiate the projectile. So there's a function called instantiate, which we pass the name of the game object that we want to instantiate or create in our world. We specify the location that we want to create it at. So we create it at the position of the camera. Since this is attached to the camera, transform.position is the position of the camera. And then we add 1 meter in the forward direction for the camera. So this is a vector 3, which would be 1 meter in front of wherever the camera is at. And then we also pass in the rotation, in which case we want it to be the same rotation as that of the camera. The next little bit of code checks to make sure that the projectile has a rigid body on it. So we're checking to see if this new projectile that we just created, so the instantiate actually returns a reference to that game object, so we set it into this variable. So if that actually has a component, so we check to see get component rigid body, does it have a rigid body? If it doesn't, we actually dynamically add a rigid body. So the projectile prefab that we created actually has a rigid body, so this code doesn't need to run, but if, for example, we forgot to add the rigid body, this would actually do that for us. Of course, it's not turning off gravity. We could do that if we want to, but since we already have the rigid body set up and gravity is turned off, this code doesn't need to run. It's just added to make the script a little bit more robust for future use. Then we apply a force to the projectile's rigid body. So, of course, rigid bodies are what open up the possibility of physics for our game object. And one of the functions that we can apply to the rigid body is add force. So new projectile, we get the rigid body component, and then with that we add force. And we're applying a forward vector of force times the power that's specified at the top here. So remember the default was 10. That made the projectile move fairly slowly. When we moved it up to 200, it started to move much quicker. And then down below, we play the sound effect if it's set. So once again, so if there is a sound effect that's specified, then I've got code that would play the sound in one of two ways. So first, it looks at that projectile to see if it has an audio source on it. If it does, it actually plays the audio clip through the audio source of the projectile. So what that will do is, as the projectile is moving, of course the audio source is moving with it, it's moving away, so the sound would dissipate as the projectile moves away. Otherwise, so if it doesn't have an audio source, I use this command called audiosource.playClipAtPoint. So what this does is it dynamically creates a game object at the location specified and plays the audio clip specified, and once it plays, that game object is then removed. So since our projectile does not have an audio source, we're actually using this technique, which is really what I want to in this case, because our projectile is moving so quickly that the audio source would move away very quickly, and the sound of the laser would fade. So I really want the sound to play sort of right at the point of the camera. So let's go back quickly to Unity and play once again and check this out. So let's look over at the hierarchy, and as I shoot, notice that the projectile clones are being made, and you can see that one-shot audio. So that is the audio that's actually being created, and then you can see that they clean up. Now, one thing that's not being cleaned up are these projectiles. So as I shoot more and more and more, you can see we get more of these projectiles in the world, and they just continue to exist forever, even though they've moved way out of the range of the camera. So let's clean this up a little bit. Let me go ahead and hit escape and stop playing. So if you remember in the last project, we had a script called Timed Object Destructor that destroyed a game object after a certain point in time. We're going to actually use that. I've included that for you here. So where do we want to attach this? We want to attach this onto the projectile, because the projectile is the game object that's being cloned over and over and over again. So let's go to the projectile prefab, go to the bottom, click Add Component, go to Scripts, and let's pick the Timed Object Destructor. It's a fairly simple script. After a certain point in time, we're going to say after 2 seconds, let's destroy the prefab. I've applied that right to the prefab, so when the prefabs are cloned or instantiated in the world, it will have that script attached now. So let's go ahead and hit play. And let's shoot a bunch of projectiles. And then just wait a few seconds and they all clean up after themselves. So let's go ahead and stop and save our project.
I'm sure your mom always reminded you to clean up after yourself. You should do the same when you're making games. If you continually add prefabs to your scene and never clean them up, they may eventually fill up the computer's memory and crash the game. As a general rule, whenever instantiating a lot of prefabs, have a strategy in place to destroy them once they're no longer needed. In the next video, we'll set up the user interface of our game. In this video, we'll create the user interface for the box shooter game. Our objectives will be to create a targeting reticle or crosshair, which will help our player know what they're shooting at, create a scoreboard to display the score, and create a timer display.
Let's start by creating a UI canvas for our 2D game UI to be rendered upon. So on the hierarchy under Create, let's go down to UI and create a canvas. And I'm going to rename this Main Canvas. And for the last project, we changed the canvas scaler, the scale mode. But for this project, I'm going to leave it at constant pixel size, since we want the UI to be a fixed size, no matter what the size of the display. So we want to represent a crosshair in the middle of the screen to help the player know where they're shooting. So with the main canvas selected, I'm going to go to Create, UI, and choose Image. And that will make it a child of that canvas. And we're still in 3D mode here in the scene view, so let's go ahead and hit F to zoom to the image, and then let's switch to 2D mode so we can really see, and of course I could zoom out so I can see the canvas and I can see the image that I just attached. So I'm going to go ahead and rename the image as Crosshair. And let's go ahead and modify some of the properties. So the first thing that I want to do is change the anchoring. So I can click the anchor graphic here, and holding down the Shift and the Alt key as it defines above, I'm going to go ahead and click the middle to anchor to the middle and center of my canvas, and you can see the effect that has. Now I want to change the source image. Right now it's just white, it's not defined. Let me click the target, and I've got a crosshair image that's imported as part of the assets that came with the project. So let me click on crosshair, and you can see that the crosshair appears there, and you can also see it down in the game view. It's a little bit small, so let me go ahead and modify the width and height. I could do that visually over here, or I could just type it. It's actually a 256 by 256 image, but I think that's a little bit large. If I click set native size, you can see that's the native size of 256 by 256. So I'm going to make it a little bit smaller. I'm going to make it 144 by 144. So now when I play, we've got a nice crosshair, and you can see my projectiles are shooting right out of the center. Okay, we also want a scoreboard in our user interface, so let's place it just above the crosshair and have it visually defined by a box. So once again, with the main canvas selected, I could go up under Create, and I'm going to start by creating another image, which will be the background of my scoreboard. So I'll go ahead and rename this Scoreboard. I'm going to set the anchoring for the scoreboard. So the same sort of thing, I'll hold down Shift and Alt and anchor to the center of the screen. Of course, my crosshair is right in the middle, so I want to move this up. So the Y position here, I could just visually drag it up or down. I want to set it to around 100 pixels up. And right now it's just a box. Once again, I could visually drag out, the size that I want it. I'm going to go ahead and just type a number here. I want to make it 160 by 50 high. And I messed up my X position, so let me set that back to 0. So it's centered. And just like with the crosshair, I need to pick a source image. So let me click the target. I'm going to use one of the default images that come in, the input field background. So let me select that. And I want to change the color. I don't want it to be white. I want it to be a very dark color. So I'm going to basically make it black. But I'm going to make it semi-transparent. So rather than 255 alpha, I'll make it 100. So it's a transparent box. Okay, we've got our scoreboard background. Let's go ahead and create our score text. So I'm going to go to Create, UI, Text, and I'm going to go ahead and name this Score Text. Now I want the score text to work in relationship to the scoreboard background. And this is where parent-child relationships work very well, just like we've seen before. So I can actually move the score text into the scoreboard, and it becomes a child of the scoreboard. Once I do that, all of its anchoring properties are in relationship to its parent. And of course, the parent's relationships are in relationship to the canvas. So I'm going to go ahead and anchor the score text to the center. So holding down Shift and Alt once again, let's anchor it right there to the center and middle of the background. I'm going to change the text just to be 0 because this is going to hold my score. Let's go ahead and change some of the font properties. I'll leave it as Arial. I'll make it bold. I'll make it much bigger, 40. I want to center it. And put it in the middle of the area. And if it gets too big, I don't want it to disappear, so I'm going to change the horizontal overflow to overflow and the vertical overflow to overflow. And I want to go ahead and change the color as well. So let me bring up the color picker, and I'll go ahead and choose that aqua color. And there we go, we've got our score text. Now the last UI element I want to create is I want to create a border that will appear around my scoreboard when the game is over. So it sort of visually represents that the score is locked in. So let me go ahead under Create and go to UI, and I'm going to create a border much like we created our scoreboard itself. So I'm going to pick Image. And I'll go ahead and rename this Game Over Outline, or maybe Game Over Score Outline. And just like the score text, I want it to be a child of the scoreboard. So let's go ahead and drag it into the scoreboard and go ahead and anchor it just like we did before. So I'll anchor it using the Shift and the Alt and middle center. And I want to change the image to be the same as the scoreboard. So let me pick the target, and remember that was the input field background. Set that. Go ahead and change the color and make it that aqua color that we've set as a preset. And I want to turn off Fill Center because I just want it to be an outline. Now, of course, I want it to outline precisely. Let me tap F to zoom in a little bit. I want to outline the scoreboard background. So this is where maybe the visual tools are nice, and there is a little bit of snapping. So we can go ahead and do that to create that outline effect. Of course, we could numerically enter the width and height if we knew what that width and height was. So this outline will turn off and on. So using the little check at the top of the inspector, it'll basically be off during play, and once the game is over, it'll turn that on. So for now, I'll go ahead and leave it off. Okay, we're going to create one last UI element to represent the timer in our game. So we've got the crosshair, we've got the scoreboard with its various components. Now let's go ahead and create a timer. So the timer is just going to be text. So create UI text, and I'll rename it timer text. And it's going to be just within the main canvas. It's not going to be part of the scoreboard. So the parent is the main canvas. And once again, I'm going to anchor it, holding down Shift and Alt to the center middle. And you can see it's right down there on the crosshair. But I want to move it up, of course, just like we moved up the scoreboard. So going to the Y position, once again, I could visually sort of move it up here, or I can just set a number here. So I'm going to set it to 160 pixels above center, which happens to be just above my scoreboard. And let's go ahead and modify some of the text properties. So this is going to be a time. It's going to look like something like 15.0 for like 15.0 seconds. So I'll put that in as sort of an initial default for visual purposes. I'm going to pick the font information. So we'll leave it at Arial, set it to bold, make it bigger. I'll set it to 20. I want to center it and make it in the middle of that text area. I want to change the color to white. And for safety purposes, it does actually display here, but I'm going to go ahead and do the overflow mode on. So if it does get too large, it'll continue to display if it overflowed the area that I've defined here.
In the next video, we'll get our user interface working by setting up the game manager. In this video, we'll create a game manager that will control the states of our game and update the user interface elements accordingly. Box Shooter is pretty simple with just two game states. The game starts in the playing state and remains there until the player either runs out of time or beats the level. The game then moves to the game over state, where the UI changes and the music changes. Depending on how the game ends, the player can restart the game or move on to the next level, which of course will start the game playing again. Our objectives will be to create the Game Manager game object, apply the Game Manager script and set it up, and examine the Game Manager code. We'll also modify the target so it responds to the projectile hitting it. And lastly, we'll adjust the rigid body on our projectile so that collisions are better detected in the physics engine.
So let's go ahead and create our game manager. So we're going to create an empty game object to be our game manager. So let's rename that game manager. And I always like my game manager to be the top element in my hierarchy, so I'm going to go ahead and drag it up to the top of the hierarchy. And I also like it to be at the 0, 0, 0 location, so I'm going to reset the transform to 0, 0, 0. And I've already got a game manager script, so let me go ahead and add component, scripts, game manager. And this has a whole variety of variables that need to be set up. This will track the score, so the initial score will be 0, of course. We could define if we can beat the level or not, or if the game is basically an endless game, and then the beat score if we can beat the level. The start time is the amount of time that we have in the game in endless mode. It's set at 5 seconds, so I'm going to leave that as a default for now. And then we actually map in various components, UI components that we just set up. So the main score text, that's the actual score text display. So let me go ahead and drag it over here to attach that. The main timer display, so we can go ahead and attach that. And then the game over score outline. So that was the thing that we inactivated here, but will turn on when the game is over. So let's drag that in. It's looking for the music audio source, which is of course on the camera. So I can drag the main camera to this, and it will find that audio source component within that game object and set that here. And then there's some various other properties that we'll play with in a little bit. So without further ado, let's go ahead and play. So you can see the timer started at 5 and is playing down. I'm shooting and time is out and it says game over and the outline came over the score of 0. So I can't actually shoot my targets yet. I could shoot them, but I'm not actually getting score. So the game manager actually tallies the score, but I need to add one more script to make things work. So let me go ahead and escape and stop the game from playing. But before we do that, let's do a quick walkthrough of the Game Manager script. So let me go ahead and double click on that to open it in Mono Develop. This is a much more complicated script, so there's a lot of details here. I'll just quickly describe a few things here. At the very top, we've created a new type of variable called a static variable of type Game Manager. So this is the actual type of the class. So this variable name, GM, is essentially a shortcut to point to the Game Manager itself. And because we made it a public static, this allows us to access the Game Manager through other scripts external to this script itself. And we'll see that here in a moment. So you can see all the other variables that we set up, things that we've seen before. Score is not a float, it's an integer. We can't have decimal scores, so that's of type int. We've seen bools before, can, beat, level, and so forth. Text is the type that is the actual UI text component. So you can see where we've defined the main score display and the main timer display as text variables that we can drag and attach. The game over outline is just a game object. Audio source is the audio source component. That's where we drug the camera over and it grabbed the audio source component off of that. And of course, it sets up the music audio source variable, so we can then refer to that within this script, and various other public variables. So we have a fairly detailed start function here. This does all the setup for us. One thing it does is it actually sets that GM or that Game Manager variable. So if it's set to null initially, it's going to set that to the Game Manager component on this game object. We set up the initial scoreboard, so we set that main score display.text equal to the string 0, and we turn off, so you can see set active for the game overs control outliner to false if it's specified, and then we do that for a few other things that we haven't actually set up yet. The update loop is what actually is our main game loop. This is basically saying if the game is not over, we check a variety of things. So the first thing that we check is, can we beat the level? And if we can beat the level and the score is greater than the beat level, we call a beat level function defined below. So if we have not beat the level, then we check the current time. And if the current time is less than 0, that means the game's over. So we call an end game function defined right here below. Else the game is actually playing. We're in the main game event loop. So we continue to reduce the time based on the change of time between this frame and the previous frame. So that's time.delta time. And then we update the main timer display. So the update here is sort of a nice thing that we get from C#. We set it to the current time, but then we format it using this toString function. So we can format it to a standard pattern. So the quote here has 0.00. So that's going to format it to a standard 2 decimal place level of precision. Since we're using C#, we can actually look up a lot of these functions on the web. So we can just Google something like C# toString, and we could find a really nice reference that talks about all the different patterns that we can apply to a string. So down below, we've got various internal or private functions. We've got the in-game function that sets the game to be over. It changed that timer display from the time to the words game over. It turns on the game outline, and it also turns on the play again buttons if they're set. We'll do that in a moment. And then it actually changes the music, and it just changes the pitch to be 0.5. So that slows the music down. So the music kind of changes in the game over state from the play state. It makes it sort of less hectic and allows the player to quickly realize that something has changed. Mainly the game is over. Beat level is very similar to end game. It does many of the same things, just with slight tweaks. Scrolling down to target hit, this is what actually does the tallying of target hits. So it passes in a score amount and a time amount, and the score amount is if you hit a target that adds score, this will add it and update the score display. If you hit a target that maybe adds time, this will add that time and then update the timer display. And then the final two functions are also public, so we can refer to these from the outside. There's a restart game, which will restart the game by loading a level that's specified in the play again level load variable, or a next level function that will move to a next level, defined in the next level to load variable. So let's go back to Unity and let's get our targets working. So let's go to the target prefab and we're going to attach another component. So let me go down to scripts and let's pick the target behavior component. And you can see this allows us to specify a score amount and a time amount for the given target. So since I attached that right to the prefab, our targets out here in the world will now all of a sudden have that target behavior script attached. So let me go to that center target. So let me tap on it, hit F. I'm still in 2D mode, so let me switch back to 3D mode. So this is the center target. You can see it's got the target behavior. And I'm going to go ahead and set the time for this middle one to 3. So it's going to increase the time of the game. And let me click on one of the other targets here. And maybe for this one, I'll change the score amount to 5. And the other target, I'll set the score to -10. And before we play it, let's go ahead and do a quick code walkthrough. So let me double click on target behavior. And you can see at the top, we've got those, the score amount and the time amount, of course. We've got an explosion prefab that we can set up later. The function is on collision enter. So, this is a different type of function. It's not an update function. This is actually a physics event that happens when two game objects collide. And of course, on collision enter is then called. And it passes in data about that collision, which I'm storing as new collision. So this first little block of code basically checks to see if there's a game manager, and if there is a game manager, is the game over? And if it is, it exits, because we can't shoot targets when the game is over. So you can see here the game manager.gm is what is actually referring to that public static variable GM. So that's how we can get access to the public variables and public functions in the game manager script. So the next block of code looks at the game object of the collision and checks its tag. And if it's tagged as a projectile, then it runs this block of code. So if an explosion prefab is set, it instantiates that prefab at that location. We'll set that up later. Once again, if the game manager exists, it calls the target hit function within the game manager. So it passes in the score amount and the time amount that should be changed. Then it destroys the projectile. So once the projectile hits something, it gets destroyed, and then it destroys the game object itself. So it would destroy the target as well. So one of the most important things here is this right here. So this is checking the tag to see if it is actually a projectile. And we actually haven't tagged our projectile yet. So this way, when a collision happens, it knows it's a collision with the projectile as opposed to a collision with another target, for example, in which case we wouldn't want to, give the player a bonus score or anything for that. So let's go back to Unity and go to our projectile prefab, and under tag, let's go ahead and tag this as a projectile. So projectile is not a default type here, so we have to click add tag and hit the little plus to add a new one. And we're going to call this projectile. And then let's go back once again to the projectile and then tag it as projectile. So now if I play, that target behavior script should run when a projectile runs into it. And then, of course, that will call our game manager to do the necessary update. So let's go ahead and test this. So I shot something, and notice it sort of works, but not all of my targets are being hit. So let me go ahead and stop. This is due to the fact that our projectile is moving so fast. To help with this issue, we need to go to the projectile prefab and change the rigid body from collision detection discrete to collision detection continuous. This is sometimes needed when you want to detect collisions between very rapidly moving game objects. It's more processor intensive to do this, but it's a necessity in our game. So with that change, let's go ahead and press play again. And now I can shoot my 3 targets, and you can see it add time, it removed score, and then it added score back, and game over.
In the next video, we'll add the ability to restart our game or play again. Since our mouse cursor is locked and invisible, it's difficult to have a play again button that we can click on with the mouse pointer. Rather than have a 2D button, as we've done before, in this video we'll create a 3D button that we can shoot in the scene, much like how we shoot the targets.
Our objectives will be to create a game object with 3D text for the Play Again button, apply a collider and the Play Again button script to make it functional, examine the code, and polish the experience so the Play Again buttons feel dynamic and only appear in the game over state. Okay, I'm going to create my game object for my Play Again button. And to do that, I'm going to go under Create, 3 Objects, and I'm going to pick 3D Text. And you can see it appears out there in the world. And I want to position this in front of my camera. So I'm going to position it at maybe 0, perhaps 3 meters high, and then at 14 meters in the Z direction. So you can see it right out there in front of my camera. And let's go ahead and set up the text. So right now it says Hello World. I'm going to make it all caps, Play Again. I want to align it to the middle center, and you can see it now is more centered. I'll set the alignment to center as well, and I'm going to set the font style to bold. And let's go ahead and modify the color. So I'll click the color swatch. I'm going to leave it at white, but I'm going to make it sort of semi-transparent. So rather than 255, I'll set it to 150, so it's somewhat transparent. Now we need to detect collisions on this game object, so let's go ahead and add a box collider so that the projectile can run into it. So let me click Add Component, Physics, and choose Box Collider. And if I zoom in up here in the scene view, you can see now the green outline reflects that box collider. Right now the size is 0 thickness, so let me change this to 1 to give a little bit of thickness to the box collider to help it detect that collision and make it a little bit easier to shoot. Now I've already created a script called Play Again, so let's go ahead and attach that to this game object, and let's double click on it to do a quick walkthrough. You can see this is sort of a very simplified version of our target behavior. It looks for a collision enter, and it checks to see if the game object that was collided with is tagged as projectile, and if it was, it tells the game manager to run the restart game function. So let's go back to Unity and test this out. So if I shoot this, notice at the bottom I got an error message. Let me exit out and click on this. It says level couldn't be loaded because it has not been added to the build settings. And notice the sort of double quote there, or I think those are 2 single quotes saying that the level name is nothing. So let's go back to the game manager and notice that we never defined the Play Again level to load. So let's go ahead and do that and say level 1, because that's the name of our level, and hit play again. And once my timer runs out, let's go ahead and shoot play again, and it starts the game over. So let's go ahead and stop. So our Play Again button functions the way that we want it to function. Now we just need to set it up a little bit more. So let's go ahead and rename this from new text to Play Again. And then let's make this into a prefab, because we're going to actually have multiple of these buttons on the screen when the game is over. So let's make that into a prefab. We'll keep the one that's out there. And let me switch to a top-down view. Basically what I want to do is have 4 of these kind of in each 4 quadrants of my world. So I'm going to go ahead and duplicate this Play Again, and it creates a second one. And I want to reposition this to the other side of the world. So I'll leave it at 0, 3, but rather than 14, let me make it at -14, so it's on the other side. But of course, it's going to be facing backwards. You can see that if I spin around here. So it'll be facing backwards to the player, so I need to rotate it. So let me rotate it 180 degrees. Let's go ahead and create another one, duplicate it, and we'll position this one at 14 units in the X direction. They're all going to be 3 high in the Y, and at 0 in the Z. So that's right on the other side, but we need to rotate this one as well. So let's rotate it to -90 and check to see if that's accurate. It looks accurate. And we'll go ahead and duplicate this Play Again to create a second copy. And then we want to make it -14 in the X direction, so it's on the other side. And then we need to rotate it properly. So right now it's backwards. So let's make this rotation as 270 degrees. So now you can see we've got 4 Play Again buttons sort of around the player. No matter which way they're facing, they'll see a Play Again button. Let's go ahead and create an empty game object to hold these. So I'll create empty and name this Play Again buttons. I'm going to reset the transform to be at 0, 0, 0. And let me go ahead and add all 4 of these game objects to that empty game object. Now, to make this a little more interesting visually, I want these to rotate. And since I put these all into a container game object, I can put the rotation on it. So if I select this, you can kind of simulate that by going to rotation under Y and seeing the sort of nice rotation effect that we're going to get. So I'll undo to go back, and let's add a component. Of course, we're going to do this with a script. And I've already got a script called rotate, which rotates around various axes. So let me make it around the y-axis, and I'll just leave the speed at 10. And you could certainly do a code walkthrough of this. It's very similar to our target mover script. And the final thing I need to do is set our game manager to basically control our play again buttons. So we don't want these on the screen all the time. So initially, I'm going to make this inactive so we don't see it. And under the game manager, we can actually attach the play again buttons, which will actually make this active after the game is over. So let me go ahead and do that. And let's go ahead and play. And I'll just let the game run out very quickly. And you can see game over. Our play again comes to the screen, and it's rotating around the world, and I can target one of them, shoot it, and my game restarts.
In the next video, we'll add visual and audio polish to the game through particle effects and additional sound effects. In this video, we'll create a few particle systems to create visual polish in our game, as well as add a few sound effects. Our objectives include using Unity's particle system to create a simple explosion of sorts for the various types of targets. We'll also add sound effects to go along with each particle system explosion.
Okay, we're going to go ahead and create a particle system. So go under Hierarchy, Create, Particle System. And I'll go ahead and rename this right away as my target positive explosion. And we've got the default particle out there. Let me go ahead and reset the transform to be the center of the world. And let's go through and modify some of the properties of the particle system. I've played with this for a while, and I've preset this up. So I'm going to do this relatively quickly. So the duration, rather than 5 seconds, I'm going to set this to 0.4, so it's not going to last very long. And I also don't want it to loop, because it's going to be basically a single explosion and then end. So the lifetime of each particle I'm going to set to 0.4 seconds, the duration of the overall particle system. The start size, I'm going to vary between 2 values. So I'll say random between 2 constants. And I'm going to make it 0.2 meters to 0.5 meters, because the target is going to be blowing into small pieces. So I don't want them to be the full size of the target. I'll give a little bit of gravity, so each particle will fall with gravity. So I'll set this to 0.5, and I'll leave the rest of the settings unchanged. Under emissions, I don't want this to continually generate particles, so I'm going to set the rate as 0, but then I'm going to add a burst right at time 0. I'll burst 10 particles. For the shape, the default shape is the cone. When I shoot the target, I want the particle to go in all directions. So a good way to do that is to pick a sphere, so the targets will render in all directions. And then I'm going to go down to size over lifetime and turn this option on. And I want them to decrease in size over the lifetime. So let me go ahead and click on that. And I'm going to pick this curve. So it starts at 1 and goes down to 0. And the final thing, I'm going to go down to the renderer. And the default is the billboard rendering 2D billboards. I'm going to change this to the mesh renderer because I'm going to be rendering actually cubes coming out of this particle system. And I need to set the mesh. I think it just by chance picked the cube, which is fine. So if it didn't do that, I would bring up the target and pick my cube. And then I need to set the material. So once again, we've got a bunch of materials already created. Let me just use the target. And I'm going to pick the target positive material, since this is the particle system for my positive target. So it'll be the green color. So if I zoom in on this particle and then stop it and then simulate it, you can see it's basically sort of boxes blowing out in all directions. So we've got our particle system set up. I want to do a couple more things here. I want to add an audio source because I want a sound effect to go along with this particle effect. So we'll add component, audio source, and let's go ahead and attach the audio clip. So I'll hit the target, and I'm going to use the positive hit sound effect because this will be for the positive targets. And the final thing that I want to do is add that timed object destructor because the particle is going to be generated when I shoot the target. I want it to play, and then I want it to clean up after itself. So let me go ahead and add a component, script, and picked the timed object destructor. And I'm just going to have it exist for 1 second and then destroy itself. Remember, the particle itself, we said, will only last for about, a little less than half of a second. Okay, we've got this game object all set up. I'm going to go ahead and make this into a prefab. So let me go ahead and drag and drop it into the prefabs. And of course, I can get rid of it out of my game world. And I want to make very similar prefabs for the negative targets, so the targets that maybe take away time. So let me click on the positive explosion that we just created and duplicate it. You can hit Command D or Control D. And let's go ahead and rename this to negative explosion, or target negative explosion. And really, I only need to change a few things. So under the renderer, rather than the positive material, let's apply the negative material. So target negative. And then the audio source, rather than the positive hit, I'll choose the negative hit. And everything else remains the same. So I'm going to go ahead and make a third one of these. So I'll duplicate that and change the sound to target bonus explosion. And once again, under the renderer, I'll change the material to be the target bonus material. And the audio clip, I'll change to the bonus hit audio clip. And then everything else remains the same.
In the next video, we'll create prefabs for the various types of targets in our game. So far, we have just one target prefab that all of our targets are built upon. Ultimately, we want to be able to spawn 4 different types of targets in our world, each with their own look and behavior. In this video, we'll create these target prefabs. Our objectives include creating 2 positive targets that increase the score when hit, 1 negative target that reduces time when hit, and 1 bonus target that increases time when hit. We'll set up each target, test that they behave properly, and create a prefab of each so that we're ready to spawn them into our game.
So we've got these 3 targets out here that are derived from one prefab, the target prefab. Ultimately, I'm going to make a variety of prefabs for each type of target. So before I do that, I want to attach one more component to the target called the target exit script. So let me go to the prefab for the target and go ahead and add the component script target exit. And what this script is going to do is it will destroy the target after a defined number of seconds. So this is actually a gameplay behavior or a game system where the target's going to appear and only last in the world for a certain amount of time, and then it will exit the world. So since I just attached this behavior to the prefab, of course, each of these targets out here will now have that behavior attached. So let's go ahead and create each of our target types. So I'm going to select the first target and zoom in on it. And I'm going to name this my target positive 1 because it's going to be my first positive target type. And the material for this should be the target positive material, which it already is. For the target behavior, I want to give a score increase of 5, and the time amount should be 0. And then I need to set up the explosion, which we just created. So we'll set this to the target positive explosion when we shoot this target. And the exit time we will keep at 10 seconds. And the last thing is I want to define how this target will move. So this target will move in the horizontal direction. So let me switch this to horizontal. And I'll leave the motion magnitude the default for now. Okay, we've got our positive 1 target set up. So I'm going to go ahead and make this into a prefab. So I'll drag it over to prefab. So this target positive 1 is now attached to that new prefab and is no longer attached to the original target prefab. So let me duplicate this target 1 positive and rename it target 2 positive. I'll just move it out here so you can see it's a different game object. And this is really going to be identical to the target 1 positive, except it's going to move in the vertical direction. So the motion state, I'll switch to vertical under the target mover. And I'm going to make this into a prefab. Now let's go ahead and make our negative target type. So let me select one of these other targets that we haven't set up yet and jump over to it. And let's go ahead and tweak its properties. So once again, this is derived from the original target prefab. So I want to change its material. So I've got a target negative material, so I can actually grab it and just drag and drop it, and it will change that material. And you can see it changes it into this yellowy orange color. In terms of the motion type, I'm going to make this spin. And you can see my score amount says -10. I actually want to make this actually negate the time, not the score, because that's, the most important thing in this game is the amount of time that you have to shoot things. So let me change the score amount to 0, so it won't increase or decrease the score, and set the time amount to -3. So we're going to lose 3 seconds if we happen to shoot this target. And of course, I want to attach the explosion, which we created. So let me grab the target negative explosion. So you can see where naming things becomes very important when you're setting things up so you can really understand what you're doing. And I'll leave the time exit at the same time. And of course, we need to name this. So let's call this our target -negative. And let's go ahead and make this into a prefab. So I'll drag it over here to the prefabs. And we're going to make one more target type. So this last target that we have out here derived from the original target prefab. I will go ahead and rename this as our target-bonus. So this will be our bonus target that when we shoot, we get bonus time. So I'm going to modify the material first off. So I want to change it to the target bonus material. So it's going to be a white box out in our world. We're going to make the motion or the mover spin as well. And the behavior, we're going to increase the time by 3 seconds. So it's sort of the opposite of the negative behavior. And we want to attach that explosion effect that we just created. So target bonus explosion. And for the exit, I'm going to actually only have these exist for 5 seconds in the world rather than 10 seconds. And I need to make this into a prefab as well. So let's drag it out to prefabs. And let's go ahead and quickly test our game. So first off, I'll shoot that positive one so I get time. Shoot this one so I get 5. Shoot this one, and then shoot the final one so I lose time and game over.
In the next video, we'll create our target spawner. Having just a few targets in our world does not make that interesting of a game. By spawning the targets, the game will become much more interesting for our players. Now that we have our target prefabs created, in this video we'll set up the spawner. Our objectives will be to set up the spawner game object and examine the spawner code, which applies several of the coding techniques that we've learned across the project so far.
Okay, since we're going to be spawning targets in the world, we can get rid of these initial targets that we have out here. So let me just go to the targets game object and command delete or control delete to remove those targets. And let me go to the game manager. So far our game has only lasted 5 seconds long. I'm going to modify this to be a 15-second game since we're going to be spawning targets and we actually want to see the effect of that over a little bit longer period of time. So let's go ahead and create an empty game object and we'll call this spawner. So this game object will perform our spawning operation. And I'll go ahead and reset it back to the default transform. And let's go ahead and attach the spawner script that's included in our resources. It's called spawn game objects. And here in the editor, you can see that we could define the seconds between spawn. Right now it's set at 0.1 seconds. So it's going to spawn things fairly rapidly. And then we've got a variety of ranges. So the way this works is it's going to spawn objects within the defined ranges. So between the minimum X and the maximum X range, so basically between -25 in the X direction and +25 in the X direction. For Y, it's going to default to 8 meters high, so 8 meters up to 25 meters up, and then the Z between -25 and +25. So we could modify these, which will basically define different areas that objects will spawn. Now, in terms of what is actually spawned, these are defined down here in the spawn objects dropdown. Let me go ahead and click the little cascade here. And right now you can see the size is 0. So we created 4 different target types, but I'm going to actually make it spawn 6 different types, and I'll explain this as I go. So let me change this from 0 to 6, and you can see there's 6 elements here between 0 and 5. So it's looking for game objects. So let me bring in the target bonus as the first object. Make sure to grab the non-explosion version. Let me grab the target negative. And then for the second element, or I guess the third element, let me bring the target +1. And I'm going to actually bring 2 of these out. So +1 is going to hold 2 spots. And +2 will also hold 2 spots. The reason I'm doing this is just sort of balance reasons in the game. So as it's randomly picking one of these spawns, it's more likely to pick, +1 or +2 over bonus or negative. So let's go ahead and test, and then we'll do a little code walkthrough here. So you can see objects spawning out in our world. I can shoot them, of course. I can get +5 points when I do that. If I hit the negative, I lose time. If I hit the positive, I gain time. And I see how long I can last. Okay, let's go ahead and escape and stop playing. And let's do a little code walkthrough. So let me double click on spawn game objects. And you can see all those variables defined at the top. They're all floats. The one that's sort of new is the game objects with these 2 brackets. So this is called an array. And you saw the result in the editor. By creating this array of game objects, it created that little cascade dropdown where we can set the number of elements. So initially it was set at 0. We changed it to 6, which gave us 6 game objects that we could then specify. So moving down here, you can see that we've got a start function. This is where we set up our next spawn time. So the next time that we're going to spawn equals the current time. So time.time is the current time plus the seconds between spawns. So that, of course, was defined above or modified it through the editor. So when we enter the update loop, we check if the game is over. And if the game is over, we stop spawning, so we exit. So return is a quick way to exit out of the current function. But if the game is not over, then we check the current time to see if it's greater than the next spawn time. So once it's greater than the next spawn time, then we know we want to spawn something, which the code down here basically calls this make thing to spawn, and it also sets up the next spawn time for the next spawn. So let's scroll down to the make thing to spawn function. So this creates a vector3 variable local to this function, and then it sets up the X, Y, and Z locations based on those random ranges that are defined above. So it calls random.range between the X minimum range and the X maximum range as an example to set the X value of that spawn position. Then we determine which object to spawn, so we pick a random number between 0 and the length of that spawn object's array. So in our case, it'd be between 0 and 5. And so we're basically picking that index into the array. And once we have that, we instantiate a game object. So right here, we're picking the array element using that index between 0 and 5. We're spawning at the current spawn position that was just defined above. And then we just pick the rotation of this game object, which is just 0, 0, 0. And then the last thing that we do is we modify the parent of the spawned object to be the spawner. The reason we do this, as it says here in the comments, is we want the hierarchy to not get super messy. So let's go back into Unity and see the result of this. So if I hit play, notice my hierarchy isn't getting crazy. If I hit escape so I can get my mouse pointer, you can see though I'm getting all of these targets within the spawner. So that's kind of a nice thing there in code that you can do, just to help your project stay a little bit under control.
We now have a fully functional box shooter game. In the next video, we'll further polish our game through the use of animations.
video, we'll animate the entry and exits of the targets to create additional visual polish in our game. Our objectives include creating several keyframe animations for the targets using the animation editor. We'll create animations for the spawn, idle, and exit states of the target by adjusting the scale of the target over time. We want to create an animation on one of the targets. So let me bring one of the prefabs out on the scene so we can see it and we can modify it. So I'm just going to go ahead and grab the target, +1, and drag it out onto the scene. I want to position it so I can actually see it. So let me just drag it out there and then we'll modify the position. So I'm going to set it at X of 0, Y of 3, and Z of 12. Okay, so it's just right out there in front of our camera. So with the target +1 game object selected, I'm going to go ahead and open the animation window. So under Window, let me pick Animation. And of course, this brings up the animation window. And I always like to anchor the animation window to my main interface when I don't have multiple windows, just to make it a little bit easier. So I'm going to grab the tab for animation and drag it down here to the game area. So now I've got 2 tabs down here, the game and the animation. You could really bring this anywhere you want, and perhaps we'll move it around as we play around here a little bit. So the first thing it says, to begin animating target +1, create an animator and an animation clip. So let's go ahead and click Create. It's going to ask us to name our initial animation clip. I'm going to call this Target Idle and save it. And this just created 2 things in our project. It created the Target Idle and animation clip and the target positive animator. So I'm going to go ahead and create a new folder to hold these things, and I'm going to call it Animations. And I'll go ahead and drag these 2 things up into that folder and go ahead and close some of these windows just to clean up a little bit. So this initial target idle animation that we've set will be the default state of our target during gameplay. So I don't actually want to set anything on the idle. I just wanted to create it so it basically grabs those default settings that we've already set up on the target. So now what we're going to do is we're going to create another animation clip. So I can click the drop down here and select Create New Clip. And I'm going to call this one Target Spawner. And it created that, and of course, once again, it put it out in the top level so I can drag and drop it into animations. So this is going to be an animation that's going to play when the target is first spawned. So to set this up, first off, make sure that your game object is selected so we see it in the inspector. So over here in the animation editor, we're at frame 0, so you can see it here or you can see it in the timeline. And when the object first enters the world, I want it to be basically invisible. So kind of an easy way to do that is to change the scale to 0. So let me change the scale from 2 to 0, 0, 0. You can see that because we're recording and I made a change, it shows that change as red, which is kind of a nice feature of the editor, so you can always see quickly the values that have changed in the inspector. So let me move out to frame 10 in the timeline, and let's change the scale again. So let me change the scale to 1.3, 1.3, 1.3. You can see it auto-created a keyframe in the animation editor since we are recording. Let's move out one more to, let's say, frame 25, and we'll go ahead and set the scale to the regular value of 2, 2, 2. So if I go back and play this, you can see basically it just creates this little animation of the cube sort of popping into existence. And of course, we want this animation only to play once, so we want to turn off looping. By default, animation clips have looping on. So for example, if I click on Target Idle here, you can see that looping is on. For idle, we actually want to keep it on because it's just going to sit there in the idle state, so we want it to loop over and over and over again. But for the target spawner, we just want it to play once and then be done. So let me turn off looping here. So let's create one last animation that will play when the target is exiting the scene based on the target exit script we already attached. So once again, let's click on the target positive game object, go over to the animation editor, click on the drop down here to create another animation clip. And this one I'm going to call target exit. And once again, I'll move it into the animation folder and click back on the game object again to set up my animation. So this is basically going to be the opposite of the entry into the world. So let me go back to frame 0. And I want my scale to be the default size of 222 at frame 0. So I'm not actually going to make a change here. Let me go to frame 10 and let's modify the scale. We're going to actually scale it up a little bit because it's kind of bloop, full and then out of existence. So let me change this to 2.1, 2.1, 2.1. Notice when I did that, it created both a keyframe at frame 10 and at frame 0. So if I scrub back, you can see it goes from 2, scrubbing forward, up to 2.1 in the X, Y, and the Z location. And let's go out to frame 25 and then set the X, Y, and Z scale to 0. Okay, and then if I play, you can see that it scales up and then down. Now, we've been looking at the dope sheet, which is this sort of keyframe view here. You can also change the curves view, which basically shows, if I open up the scale property here, it shows sort of visually what's happening, scaling up and then down. And you could actually drag the keyframes here, and you can right click on keyframes to get little control points, which you could then use to basically modify the behavior of how these things transition from one state to another. Okay, and you could do that over each of the X, Y, and the Z. I think I'm working on the Z right here. I'll go ahead and undo what I just did. Okay, I'll go back to the dope sheet. Okay, our animation is basically set up the way we want it, except for, of course, we want the exit to play just once. So let me go to that animation and turn off the loop. Okay, we've recorded the animations that we want to record, so let me turn off recording to get out of record mode. And now we've got our 3 animations for the target.
In the next video, we'll integrate these 3 animations into the game through the animator. The animator is a powerful interface that allows us to set up states of our animations and the transitions between them. In this video, we'll use the animator to set up the animations of our targets. Our objectives are to explore the animator's interface to get a better understanding of how it works, set up the entry animation state for our target, set up the transitions between animation states, and trigger an animation transition through code.
Okay, let's go ahead and select the target-positive game object. And notice over in the inspector, we have an animator component attached. The animator is what assigns animations to our game object. The animator component requires an animator controller, and you can see that right here. It's called target-positive1, and this was created and linked in automatically when we created our animation clips. Let's go ahead and rename that. So if I click on it, it highlights it over in the project view. So let me tap on that and rename this. We'll call it target animator controller, just to make it a little clearer what that actually is and not just have the same name as our prefab or our game object. And let's go ahead and open the animator controller. So this brings up the animator interface over here in this tab. With the Option or Alt key pressed on your keyboard, you can press the left mouse button to essentially pan around this view. And what we have here is we have the various animation clips that were created. So you can see there's target idle, target spawn, and target exit. And these basically represent the possible states in our animator or in our animation. Over here you can see 2 properties. One is the entry property and the other is the end state property. And you can see there's a line from entry to target idle. Basically what this means is when the animation starts, it will play the target idle animation. I think that was set up because this was the first animation clip that we created, so it picked that as the default. We don't actually want target idle to be our default because when the target enters the world, we want it to play the target spawn animation. So we can make this change by right-clicking on the entry node and choosing Set State Machine Default State. So this will change the default state from target idle to the state that we select. So if I choose this, notice I have a live link now on my mouse, and if I move it up to target spawner and then click, notice it moved that transition from the target idle to the target spawner. And you could drag these states around however you see fit for whatever visual layout. So I'll go ahead and move this down and then move the target idle up. and then the target exit. So, from entry, I'm going to play the target spawner. Once the target spawner is done, I want to move to target idle so we can make a transition, very similar to what we just did. So let me right click on target spawner and choose make transition. And I've got a live link, so let me drag up to target idle to set that transition. Now if I click on the transition, the inspector updates and it shows me a variety of things. Essentially it's telling me that the transition is going to go from the target spawner state to the target idle state. Has exit time is checked. Basically, when the target spawner is done, it will move on to the target idle state. This clip does not loop, as an example. And this shows me sort of the transition that's going to happen between the target spawner and the target idle. So you can see there's a fair amount of overlap where the transition starts and the transition stops. So you can actually live drag these to reduce the transition, or you can open up settings and specify the transition duration. So I'm going to make the transition very small. So let me go ahead and play. One nice thing about the animator is you can actually preview the animation as it happens. So I'm looking at my target positive 1 game object out here. It has that animator controller attached. So if I play, I could actually view this. And you can see visually it was pretty quick, but it showed a little progress bar on target spawner, and then it immediately moved up to the target idle, which is exactly what I want to have happen. And then eventually the game object was destroyed, so that's why it stopped playing. So we have one more transition that we want to have happen between target idle and target exit. So what is actually going to make this transition happen? Like I said, target idle we want to continue to play while the target is out in the world, but once the target is going to be destroyed, we want to play the animation before it's destroyed. We actually already attached a script to the target called target exit. So let's go to the game object and look at that target exit script. Let me go ahead and double click on it. We haven't really done a code walkthrough of this yet, so let's go ahead and do that. You can see we have a couple public floats at the top. One specifying an exit after seconds time, a number of seconds before we want to exit, and then an exit animation speed. We have an internal or a private variable. Notice we could actually specify private here. If we don't specify public, then it's just assumed to be private. So a start destroy is false initially, and then another private float called target time. So on start, we initialize target time. So we basically set the target time to the current time. This is how we get the current time, plus the exit after seconds value. So in this case, it'd be 10 seconds, or we can override that in the editor, of course. So after the current time plus 10 seconds, that's going to be our target time. Then we go down into the update loop. So this runs over and over continually. So every time through, we check the current time and see if it's greater than equal to the target time. If it is greater than equal to the target time, then we check to see if this game object has an animator component attached. And if it doesn't, meaning is this statement equivalent to null, then we just destroy the game object directly because there's no animator, so we can just destroy it. And that's the way that targets have been. But now that this target actually has an animator component, we actually want to play the animation before destroying. So that's what the next bit of code does. First, it checks to see if we've started to destroy or not. Once again, this was an internal variable, private bool, that was initially set to false. So the first time this would evaluate to true. So if not start destroy, then it's going to go in here and immediately set that start destroy to true. So the code here will only run once. So next time through the loop, of course, this will evaluate to false and it won't run this code again. And then what we're going to do is we're going to trigger the animator to make that exit transition. So this is sort of where the magic happens. We get a reference to the animator component on this game object, and we call this method on the animator called setTrigger, and we pass the value exit. Of course, at any time you could select something like this, and you could do the command single quote or under help, select Unity API reference. And this will bring up the reference. Of course, we're talking about the animator, so I can click on that, and we can read the description of how this works. But I'm just going to go ahead and jump back into MonoDevelop and describe it. So we pass that trigger to the animator, and then we want the animator to basically trigger based on what is passed in. After that happens, we invoke a function call after a certain number of seconds. So basically, we want the animation to play. Then after a certain number of seconds, as specified here, I believe it's 1 second defined, it's going to call the kill the target function down below. So basically, once the animation plays, we're going to destroy the game object by calling kill target. Okay, so we need to set up our animator to receive this exit trigger. So let's go back to Unity and set that up. So up here at the top of the animator, notice we've got layers view and we've got parameters view. So we want to be in parameters, and we need to create a parameter for that exit. So let me go ahead and click the plus, and notice you can create different types of variables: a float, an int, a bool, or a trigger. For purpose of example, we're going to use a trigger. It's probably the simplest. Bools could be true or false, and of course floats or ints can be various numbers. So let's go ahead and set the trigger up. It creates a new trigger. We're going to name it exit, because that's the string that we're actually passing from that script. So we've got that parameter created. Now we can create a transition from target idle to target exit. So let me go ahead and right click again on this state and say make transition. So from target idle, we'll go to target exit, create that transition. Let me then select that transition, and I can uncheck has exit time, because I want target idle to continually play over and over again and only make the transition once the condition is applied. So notice down here it said transitions need at least one condition or an exit time to be valid. So let's go ahead and create the condition here. So let me hit plus, and notice that the condition popped right in there. If we had multiple of these, we can click the down arrow, then select the appropriate condition. If it was something like a Boolean, you can set that here and then set, if it's true, do the transition. If it's false, do the transition, or whatnot. But we're just using a trigger, which is very simple. Once again, we actually have the sort of the timeline of the transition. Notice it's a fairly big transition, almost the whole duration of the target exit animation. So we want to reduce this time. So let me go ahead and drag this down to be a very minimal amount of time. And then let's go ahead and preview this once again. So let me hit play. And let's watch it. So we did the spawn. We're in target idle. I think this is going to play for about 10 seconds. And then that target exit will call, and there it goes. It called the target exit animation, and the target left the world. So let's go ahead and stop. So now that we have that animator all set up on the target positive game object, let's go ahead and apply that to the prefab, because remember, this is built out of a prefab, but we've been doing changes locally on this game object. So if I click apply, this will apply back to that target positive one prefab. But remember, we have multiple targets now. We have the positive 1, positive 2, negative, and bonus. So there's no easy way to sort of click a button and have that apply to all of those other prefabs, since they are separate prefabs at this point. But what I can do is I could actually copy this component. So let me go to the animator and click on the little gear, go down and select copy component. Then let me go to the other prefab. So let me go to the target positive 2 prefab, and let's go down, and just on any of the components we can click the gear and choose paste component as new. And this animation is going to work just as well on this prefab as it did on the other prefab, because it's just modifying the scale. So this animator is sort of a universal animator that I can apply to any of these prefabs. So let's go to the target negative and do the same thing. Paste component is new, and let's go to target bonus, and once again paste component is new. So they all have that animator controller. And finally, let's go back to the hierarchy and let's remove this target that I put out into the world, since we really want all the targets to be created through the spawner. So let me command or control delete. Let's move to the scene view. So let's go ahead and play our game, but let me go ahead and maximize on play so we can get a really good view of the world and play. So as I'm playing, you can see that the objects the targets are animating in, and if I don't shoot them in time, of course they will animate out of the world as well. So we have that sort of nice visual polish on all the targets. I'll hit some negative targets here. And, of course, this is Box Shooter.
In the next video, we'll finish up the project. In this video, we'll finish up the Box Shooter game. Our objectives will be to polish the project, add a few features of your own design,
do the final build, compress the project, and then upload it to the peer review system. To complete this, follow the steps closely listed in the peer review assignment. If you need a review of the process of how to build and upload your project, you can rewatch the Build and Deploy video from the Solar System project. Once you submit your project to the peer review system, make sure to go ahead and do the peer reviews of other learners' projects. Well, you did it! You got to the end of Intro to Game Development. As I said up front, making games is hard fun, and I do hope that you've been having a lot of fun and learning a lot as you've worked through this course. But this does not have to be the end of our journey together. This is actually just the beginning. I hope you will continue on and complete the specialization in game design and development. Our next course, Principles of Game Design, will switch gears a bit to the more conceptual side of game design. The third course, Developing Games for Modern Platforms, will bring us back into Unity for more hands-on project work. In the meantime, I encourage you to continue to explore Unity and expand on the games that we've built, as well as trying to build some small games of your own design using the techniques that we've learned. Best wishes, and come back soon to continue your journey into game design and development.